Yeah, good morning to everyone who's here, and also a good morning, good afternoon, or evening for everybody who is joining us from home. It is so great having you, and isn't this a great venue here in Amsterdam? I'd quickly like to introduce myself too. My name is Caroline, and I work for eyeo, the company behind AdBlock Plus, and I'm a product owner for the Acceptable Ads standard. And I'm sure we've all come here, and we're eager to hear everything that's new with the developments on the ad filtering tech, also about privacy-related questions, and I don't want to hold you for much longer, but I have 3 quick things that I'd like to pass around in terms of how we organize the event during these 2 days. So, 3 things. First one is Q&A, the second one is breaks, and the third one is the 6th floor. So, Q&A, we have not only a remote audience listening in, but we also have remote speakers. So this hybrid setup with on-site and remote made it a bit challenging with questions, which is why, for technical reasons, we unfortunately had to make a little bit of a tough call to do live and ad hoc Q&A only here for on-site speakers with the on-site audience. However, that does not mean that we leave the remotees behind. You're, of course, also invited to ask questions via the event's Slack channel. And I would encourage you to do so at any time. And obviously, everyone with a phone here can do that too. And the speakers will then try their best to answer those questions within the 2 days of the conference. Okay, coming to the second part, the breaks. We have very crisp speaker changes that will only take about 5 minutes. And then we have more extended breaks for coffee, drinks, and networking, obviously, downstairs on the 6th floor. And you will just take a right where you came from. You saw the bar. This is where you will find everything. And speaking of the 6th floor, there are also meeting rooms that you can use at your convenience. If you need to skip a session or take a call or anything like that, there are meeting rooms behind the bar. So just go there, and the meeting rooms have signs, so you know where to go. And I think those were the house ads. So I believe we're almost good to go to kick the day off. And I am very pleased to welcome, actually, Gertrud Kolb to the stage. Gertrud is eyeo's new Chief Technical and Product Officer. And she's basically leading all the tech and product directions within eyeo and helping us thereby to accomplish our mission to establish a fair and sustainable value exchange on the web. And Gertrud has extensive experience in IT solutions companies and also has been working in digital news world for a very long time, almost 2 decades. And yeah, she brings all this expertise to the table, helps us, and I wish you a nice keynote from Gertrud. Thank you.
Also from my side, a very warm welcome to this 5th Ad Filtering Developer Summit. In this nice city, nice venue, it's so good to meet in person again. We had our first coffee together, and for some of you, it feels, I think, like a little class reunion. Many of you know each other, and I think it's really cool to have these 2 days in person here together. And we have a really packed agenda, interesting speakers. I'm really excited about these 2 days. This is the 5th summit, and for me, this is my first one, so I'm the newbie. And at first, I would like to thank you. To thank you for trying to give me my advertising experience back. You know, when I was a child, I loved television commercials. These fixed breaks between 2 shows with the commercials on television. They were predictable. You know, now you have a break, one spot after another. They don't interfere with the show, with the storytelling at all. You could use this break to grab a glass of water, go to the toilet, have a snack. And sometimes there were really cool spots, very cool spots. My favorite one was the one with Levi's. You remember this guy lay down in the bath tube with his jeans on? This was a kind of inspiring for me. I did this after. I also lay down in the bath tube with my jeans on. So this was cool, television advertising. Also the political commercials. Do you remember this? In Germany, it was fixed time slot right before the news, 8 p.m. in the evening, with this information, now it comes political advertisement, pay attention, we are not responsible for the content of this ad. So it was quite clear. But then the private television stations came up and some things changed. So this is always something I realized when I was a child. Now every 15 minutes there was this break of advertisement interfering the storyline. We saw animations in the right corner. It was disturbing, it was annoying every time these advertisements in the private television. But even for the public television and for the private television, there were rules, restrictions. In Germany, so-called Rundfunkstaatsvertrag. They were fixed. It was clear how much ads, the content of ads. We had rules in these days. And of course, when I was older, it was clear these private television stations, they need monetization because they don't get this support from the state like the public television. So I understood that. And then the web came up. No rules, no restrictions. We all know what happened. So much advertising. It was so annoying. It was so much stuff. It was like a wild, wild west. Everything was allowed. We were in a kind of legal vacuum. And then the users fought back. We all know this story. Can you fix it? Thank you. Can you hear me? Perfect. Adblocking came up. Our rescue. And then, of course, the idea of ad filtering, to let the good ads through, to bringing together the user needs, good advertising experience, with the monetization opportunity for publishers and content creators. At the moment, we have 37% of all users worldwide using a kind of ad filtering approach. Small sidestep, at eyeo, in the last few weeks and months, we worked really hard on our report, The Global State of Ad Filtering. There you can find all figures and key facts and trends. And after me, my colleague Kathrin will present you this report. So what does this tell us all? Advertising is not bad per se. On the contrary, it's absolutely legitimate to really have advertising for products to sell them. But of course, the mood can quickly tip. And when I talk about ad filtering, of course, I also mean trackers, all the bad stuff. So ad filtering, tracker filtering, content filtering, we use these terms equally. And it's all about cleaning up the web. And how do we do this? This is really fascinating. This was one of my biggest surprises when I started at eyeo, that we use these filter lists and filter rules and regular expressions to identify the requests, and then we can block ads. These filter lists are really quite flexible. That's cool, good news. But on the other side, they are error-prone, hard to maintain, and most importantly, easy to circumvent. And when I think about ad filtering, I always have this picture in my head of the non-profit organization Clean Up Ocean. I don't know if you know this. This is really impressive. This organization, they build boats, kind of trawlers, and they're shipping through our oceans with nets and special equipment and collect garbage, trash, plastic out of the ocean the whole time. The ocean is quite big, and there comes more and more garbage, and they collect this garbage, and then you have mountains of this garbage, and you can recycle it. This is so impressive, but it's a kind of mammoth task. And always, I think when we talk about ad filtering, they clean up and clean up and clean up, and we filter and filter and filter the web. collecting all this trash out of our web. And it's obvious we need automation. This is one of the most important topics when we talk about ad filtering. And we know there are some interesting approaches on the table around machine learning. We will hear also at this conference about this. But what should we automatically collect? What is acceptable? What is not acceptable? What is trash? And what is no trash? This is a complex task. Normally we talk about the user experience, so we have bad ad formats and we don't like animation, and that's all about user experience. And also when we only talk about user experience, to detect, to distinguish technically ads from content is really not easy. It's really complex. But another question, we have a standard, but what about asking the question, what is acceptable for me? What is acceptable for you? Does it make sense to have one dedicated common standard? Or does it even make more sense to ask the question, what is acceptable for user segments or for individuals? And of course, privacy, our really important topic for the last years. How can users be served with relevant ads that interest them, doesn't annoy them, without violating their privacy when we share their data to third parties? And of course, we always talk about the idea of giving the control back to the user. And I think that sounds so cool, doesn't it? Giving the control back. But on the other side, these solutions also can overwhelm the user. When we think about the consent layers, we hate consent layers and we click OK because it's too time consuming to understand all the information which are behind this dialogue. So when we talk about an active choice for the user, I guess it's not a smart solution that will win. And then about, of course, the content of ads. We normally talk about user experience, privacy, security, but when it comes to the content of ads, and we know sometimes for the user it's not easy to distinguish on the side what is yet now content and what is ad. And we know the more negative emotions we have, the more engagement, the more clicks do we have. And what impact does that have on the consumption of misinformation? What impact does this have on our society and our political systems? So to sum it up, ads will not go away. They do fund the web, that's for sure. There is a good advertising experience, but there are many open, relevant questions. And I'm sure in the next 2 days we won't answer all these questions, but I am sure we will have relevant, interesting discussions. We will talk about relevant ideas and approaches to shape a better web. And I wish us all great 2 days. Thanks a lot.
Hello everyone, also from me a very warm welcome. My name is Kathrin Jennewein, I'm the PR manager of eyeo, and I have the honor of presenting the Global State of Ad Filtering report to all of you today. We're going to start with a very quick overview of what you can expect from this document. It contains of 3 major parts. The first one is the key insights into the current landscape. We have some ad blocking stats there, also insights from industry players, and some challenges and opportunities. The second part is some key statistics and figures We have user attitudes there and also motivations, ad-blocking countermeasures, and also some information on ad filtering statistics. And the third and last part is a future and an outlook in what might come in the next years for ad filtering. The first part, the key insights into the current landscape. Among other, some very interesting topics, you might find some insights there on Manifest v3 and also a network-level ad filtering. Andrey Meshkov, CTO and co-founder of AdGuard, even thinks that v3 might be a step towards having browser extensions on mobile and sees very big opportunities for ad filtering ahead of us. In the second part, we were looking into user attitudes towards ad filtering and also advertising. We have also the topic of circumvention there, and of course privacy, one of the most important topics for eyeo and our users, of course, and also many of the companies that are here today. It is also a focus topic for this year's Ad Filtering Dev Summit, of course, and for our users. 58% of ad blocking users want to protect their privacy by using an ad blocker. Now we come to the third, and for me, my most favorite part, the outlook into the future. We collected some very interesting insights on circumvention and also the use of machine learning there. We will have a very interesting talk by my colleague, Dr. Humera Noor Minhas today about the machine learning efforts at eyeo. We will also look into the future of mobile ad blocking and the consolidation of filter lists, and the developing ad filtering on new devices and new tech automation. And I'm going to close the presentation with a quote from the ad filtering report. Where there is internet, there will be ads. But where there is internet has changed dramatically throughout the last years. Knowing this, we must build a plan and continue investing resources in new technology. By doing that, we can address online advertising that doesn't respect user choice and the user experience. You can download your copy of the Global State of Ad Filtering report here, and also, of course, on our website. Thanks very much for your attention.
All righty. Thank you, Gertrud, and thank you, Kathrin. You can leave that slide on maybe for one more minute with the QR code in case somebody wants to scan it here on site, or I believe maybe this is also how you people at home do see it. I would certainly download this report. Sounds very interesting. Thank you, Kathrin. Yeah, we're also cruising a little faster than our foreseen schedule, but that doesn't stop us from anything. So our next guest here will be Arjan van Leeuwen. And Arjan is going to talk about something very interesting. So I have worked at eyeo for about 8 years, and I worked in the business side of things. So sometimes I would hear things from partners that were saying that something must have been added on the blocking side, like on various blocking lists, and that things we had brought into place didn't quite work properly, which wasn't a big problem because we could most of the time fix it very easily. But it's basically what Gertrud was referring to. Some filters are very error-prone and can basically break things sometimes. And these breaks can have various scopes. Sometimes elements can go missing. And I have certainly also seen pages from a user experience going or browsing the web, seeing pages that turned out much more empty with much more white space than I would have anticipated. And sometimes things can also be more severe. For example, if domains get blocked entirely, this can also break links. So, as said, the effects can be quite different from what happens, but they can be also very big at times. And I am very happy that our next speaker, Arjan, as I said, is going to address this issue. Arjan has many, many years of working experience working for Opera, And yeah, he's very versed in software development and engineering, and he's currently the product engineering lead at Opera. So that said, I will leave it up to Arjan, and a big round of applause for Arjan, please. Thank you.
Can you hear me? Yes. Hi, welcome everybody. So I'm Arjan van Leeuwen and I work for Opera. And we're going to talk about breaking things. So for some time now, Opera has had a built-in ad blocker. And one thing that we know about the ad blocker is that users really love it. They love it so much that we know that if users find their way to enable the ad blocker in Opera, then they'll stay longer with the product and they'll have more fun from using the browser. So even our own statistics show that what we want is people to enable the ad blocker. So when the user starts Opera for the first time, they'll receive this onboarding screen that you see here. And one of the things we try to do there is to get people to enable the ad blocker right at the start when they start using Opera. So the idea is that they click that big switch at the bottom, and at the same time you see, I couldn't put in an animation because it's really hard in this presentation to put in videos, but it shows a little animation that tells you where the ad blocker is in the Opera UI. And then when you hit the big switch, you will see the ad blocking dialog come up that normally hides at the top right in the address bar, and it has like a couple of options related to ad blocking. So this is where you can turn off ad blocker for a specific site. Recently we've added acceptable ads to our ad blocker. It's also something that is explained here. You can disable it if you don't like it. And we also have some other content filtering related options, like you can enable our tracker blocker as well, which is based on easy privacy. And very important, and I'm going to get back to this, at the bottom of the dialog has a little warning. It's not too scary, because if we make it too scary, we scare off people too much. But it says in small letters, I hope you can read it, blocking content can cause some websites to not work properly. And this is true. Now, not everyone goes through this onboarding, right? Because some people already have Opera, they're existing users, or they just close the onboarding because they don't like to. They know how a browser works. So then probably the first time they get into touch with our ad blocker is when they use the quick settings screen. That's when you press a button on the top left in the browser UI. You see the setup screen, and the ad blocking is there, pretty prominent. If you can see, it's under privacy and security. So many people find their way there. They turn it on from there. And it's a very nice way to turn it on because you can immediately see the effect. It will refresh the page that is visible at that moment and show you the ads that are blocked, the number of ads that are blocked, so you can basically see the effect live. This is my preferred way of doing that. There's extended settings where you can turn on ad blocking. You look like this. You can also have some more options here, like managing exceptions or adding your own block lists. Again, acceptable ads is here. And we even figured out that some people really equate ad blockers with extensions. So they might even know that Opera has a built-in ad blocker, but the first time they start the browser, they're going to go to extensions and try and find it there. So don't shoot me for this, but we actually promote our own ad blocker in the extension screen. So there you can also enable the ad blocker. It even happens in the add-on store for Opera, where people end up as well. There's a couple of built-in Opera features that are promoted as on the recommended list in the extension store. And we have plenty of people who manage to figure out here that Opera has a built-in ad blocker. And then they start enabling it. And all these ways, when you enable the ad blocker, you always end up with the same dialogue that tells you this is where the ad blocker is, this is how you can turn it off, and it might damage some pages. So the intention of all of this, all these different places, all these different paths that we have created to enable the ad blocker, is to get as many people as possible to enable it, because they like it. They want to have an ad blocker. And we've been very successful with this. It really worked. We have a lot of our users using the built-in ad blocker now. Like this graphic, if you were here at the conference in 2019, I showed the same map. I updated the numbers, but I didn't have the original drawing anymore, so I couldn't update the circle. So this is now completely inconsistent. You see the number does not conform to the blue line in the circle there. So sorry for that, but what's great about it is that you can actually see how the numbers changed since 2019. So if you take a look, for example, at the US there, it says 40%, that's a statistic from last week, so it's very recent. And you can see in the thick blue line in the circle that it used to be 3 years ago, around 25%. So it's a big increase in users using the ad blocker. And yeah, something else you can see is that in some countries, almost half of our users, practically half of our users, are using the ad blocker. So you can see that in Canada, in the UK, in France. So we really have a lot of people using the ad blocker. Even in countries where we weren't that successful, like in Ukraine, Russia, Japan, we still managed to increase it a lot compared to 3 years ago. So this is great, right? We did exactly what we wanted, and we have more happy users. They're happy ad blocking users. Yeah, everything's good. Yes, but no. Not everyone's happy. We have a whole new group of complaints from our users. What's the #1 task of a web browser? It's browsing the web, it's showing websites, showing them correctly. What's the #1 reason that people change or leave an alternative browser? It's that a site did not display correctly. So we get a lot of complaints from users about sites not working correctly. And that's always been this way. We're used to it. It's part of the job. There's lots of different places where users can voice their complaints. There are forums, there's blogs with comments, there are the bug reports that are coming in. We have people on social media that are handling things from our users. And they always, whenever there's like a site not working correctly, we always give a standard reply to people. Turn off your extensions, try to get settings back to default, and turn off your ad blocker. And in many, many cases, this solves the problem of the user. Not our problem, the user's problem. Because our problem was that the site was not displaying correctly, and only a few users reached out to us to talk about it. So let me tell you about a couple of common problems that happen when the ad blocker prohibits the page from working correctly. And you're all going to recognize this. So I just thought it was fun to make a quick list. The first one, a button is not responding when you click it. And this is something that tends to happen, to me at least, exactly when I've done a lot of work on a site. And for example, I filled a shopping cart with exactly the products that I wanted to order. And I've been very careful in my choices. And then at the end, there's an order button, and I click it, and it doesn't do anything. What do? I turn off the ad blocker, because I know what's going wrong. But what do users do? Nothing. They maybe try shopping on a different site. Maybe they change their browser. But it didn't work as intended. This next one you'll know about if you have any cookie dialog blockers. It's very annoying when it happens. the ad blocker managed to hide the cookie dialog, either because of a filter that was meant for that, or because of a filter that wasn't meant to do that, but it did it anyway. And what didn't go away was a functionality that the site made so that users can't scroll the page while the cookie dialog is visible. And then you're stuck on the site. Like if you're on any news site, the main interaction you have with the site, the main thing you do when you read a site is actually scrolling. And you can't do it. It doesn't work. So if you can't scroll a page, who are you going to blame for that? Yeah, the browser. Didn't scroll the page. Then you have the blockers, right? You go to a site, and the first thing that happens is a pop-up comes up and says, I see you have ad blocking enabled. Please disable it to see this site. And personally, I think that sites do have some sort of a right to say that you can only see them if you see the ads as well. And maybe you disagree with me, that's fine. But what I really hate is that on some sites you have this, and at the moment that you decide, okay, I will turn off my ad blocker for you, for this site, they suddenly have like immediate wall-to-wall ads on the whole site, everything moving. It's like, it seems that the worst sites have these dialogues and have the idea that if I have the courtesy of disabling my ad blocker for you, you should have the courtesy to display some friendly ads to me, because that was the reason I had an ad blocker in the first place. Anyway, that's what happens. And I'm mentioning it here, not because of that, but because a lot of users see this and they do not know how to get out of it, because they haven't figured out how to turn off the ad blocker on a site. Half of our users have enabled the ad blocker, but how many have actually seen that dialog that allows you to turn it off for a specific site? Do they know how to do it? And a lot of sites, I know, add some kind of description or explanation on how to do it, but you know, most of the sites will not describe how to do it for Opera. They will describe how to do it in a very popular extension that will remain unnamed here. So yeah, it's a problem. People get stuck. Another one. This one never happens on YouTube. Everyone knows YouTube always works. The video doesn't play when you're on you want to live stream some like local cookie baking contest on your regional newspaper's website. And the ad blocker has successfully blocked a video ad. That's very nice, but it also managed to block the whole video that you wanted to see. Yeah. What are you going to do? And then I didn't yet say about the absolute worst thing that can happen with the ad blocker. And that's that you cannot see what you wanted to see. Sometimes elements just get hidden that shouldn't be hidden. And I ran into this very recently. I was trying to order something on a site of the French post office, and it managed to hide the checkbox for agreeing to terms and conditions. And that's really annoying, because you cannot continue without clicking that checkbox. And I was trying to find where to click it. It just wasn't there. You do not know what is not there. So in the end, of course, I found out that I can turn off the ad blocker and I can see the checkbox, then I can click the checkbox, and then I can continue. But these are real problems. If you don't see something on the page, you don't know that something is wrong. You might never realize that there was something essential that you needed, either to read or to do something on the page. So there are actually a lot of market differences with this as well, because the internet is a big place, as you all know, but it's divided into much smaller places. And in terms of different spheres, you have like different languages and regions where there are sites. And it's very common that the filter meant for an ad that appears here in the Netherlands is breaking something on a site in France, just because, well, that wasn't tested when it was created. The problem is that there are users in all these different countries and speaking all these different languages and using all these different sites, many small sites that I don't know about and no one at Opera knows about. So if things break there, we will not realize. And we need our users to tell us. We're not everywhere. Maybe something broke in our ad blocker. Maybe there's something wrong with the filter list. Maybe we need to do a quick fix somewhere. But we don't know about it unless we get told by users. So how can users tell us things? Well, there's these usual ways that I mentioned, forums, blogs, bug reports, but those are quite specific. Most people won't find them. For other things in the browser, when we have browser features, we use something called the feedback dialog. It allows people to tell us whether something's to their liking or not. And this works very well for specific browser features. Here you have one in the snapshot feature. Here you can see the same thing in the address bar in Opera. And when people click either thumbs up or thumbs down, then they can leave a comment. They don't need to, but they can. The reaction gets sent to Opera. And the numbers that we get from this are extremely useful because they allow us to analyze the trends. So here I have something from a feature called Easy Files. It's a file selector in Opera. It's not very interesting what it does right now, but what you can see here is that from the ratings, we immediately see when something goes wrong, when there's something that the users don't like. So you can see there suddenly drop down. This was our moment to go check the comments and see what's happening there. Then we make a fix for it. People slowly get the update, and the ratings go back to their usual number. So this really works for features in Opera, but it doesn't work for sites, the main functionality of the browser. We've tried creating a dialog for users to tell us when there's a problem with a site. And we tried changing this dialog and getting more people to actually tell us things about it. But it's surprisingly hard to get people to tell you anything about things going wrong. The input we get from this is either too generic or too specific. It's either nothing works or this site that I found somewhere doesn't work. And because we don't get enough people saying when things don't work, we can't do analysis on it because we don't know whether someone saying that one site doesn't work means there's a problem on the site or something else. We need much more input to be able to say, okay, we can detect that there's a problem on this specific site because many people are complaining about it. We just don't get enough people saying this. But the biggest thing is really that users don't know something is wrong. Like I mentioned with the hidden elements, like I mentioned with the buttons not clicking, people might realize that something's wrong, but they're not thinking about the ad blocker when they see it. They just think something's not working correctly. What do I do? They might blame the site. It's good for us if they do this. But usually they blame the browser. And you see that when we do get a bug report about the site, having some breakage because of a filter or some bug in our ad blocker, it often comes with the notice, I tried this in Chrome and it works there. And well, it did because they didn't have an ad blocker installed there. And we don't really have the opportunity to tell users, okay, maybe the same would happen. Maybe you can test it in an ad blocker in Chrome. So yeah, the user came to browse the internet and they left because they couldn't browse the internet. I'm not here to blame filter list authors. I know you're all doing a fantastic job at making very specific filters, and most of the time, they work great. The thing is that whether it's the fault of our ad blocker or some filter list that we use, we are doing changes to a site that the author did not expect. And sometimes that breaks things. Maybe the site is doing an update and then something breaks. Maybe we are doing a filter list change that breaks something. It's in the nature of things, if we change the site and make changes that the author didn't expect, then sometimes it will break things. Actually, I wanted to say that the speed of fixes on the most used filter lists is really amazing, because the most common fix for our users when they have something not working is to wait a few days. And then actually the filter list will catch up and the problem will be solved. And that is really amazing. But the problem is, it's not enough. It's too late for some people. It's not enough because not everyone knows that ad blocking was behind this. It's not enough because not everyone knows that ad blocking is not an exact science. I often get comments saying, like, why isn't this ad block, this was changed? Your ad blocker is broken. And it's not enough because for some users, a site not working just means that the browser is not working. I'm kind of sorry if you came to this talk expecting solutions from me, because I don't have them. We're trying a lot of technical solutions. We're seeing a lot of advances in this space, and you will see them at this conference. There'll be very interesting new things to try, which will surely improve the situation. But keep in mind that there will still be sites breaking, and that this is actually a big problem for users. They don't always know it's because of ad blocking, but they do want it fixed. I think we need more user input, us together. And I know that the input we get isn't enough, and we haven't been successful in getting more input that we need from our users. So I'd like you also to keep that in the back of your mind and see if we can develop together more ways to get input and to get a way for users to tell us that something's broken. Because even if it's a little breakage, and even if it's on a site that no one uses, there's always someone who uses it. It's a real problem. Thank you.
All right. Thank you, Arjan. This was very interesting. I can definitely relate to a lot of the issues you described. So just out of curiosity, I will just ask the audience here, who of you has never experienced any of these issues that Arjan described? I didn't expect any hands, to be honest. Who of you could relate to every of the issues that Arjan described, more or less? That seems like nice. 60%, 70% of the people here. So yeah, that is quite a lot. I really like the ways you described how you're trying to tackle the feedback loop with the users and trying with these intuitive dialogue, UIs, and so on. And yeah, we actually have a bit of time left here now for questions and answers. And if we have some in the audience, you may have noticed that I brought this wonderful little cube with me. I see already a question coming up. Just a quick explanation. This is basically a catch box. It's a microphone that you just want to tilt towards you with the black part and speak right into it. May look funny, but this is how it works. And Susanna is going to throw it at you. Andrey, heads up.
Does it work?
It does.
It works.
We can hear you.
Have you tried any automatic solution to detect
Closer.
To detect
Yes, yes.
websites breakage?
Can you maybe repeat the question just to make sure our remote
Have you tried any automatic solution to detect websites breakage?
Yes, we've done some experiments with that, but we have not been able to make this work reliably. And I think, especially with hidden elements, we have very big problems deciding what's correct and what's not.
Short follow-up. By reliably, do you mean that you had false positives, or that you had stuff not detected?
False positives.
See, thank you.
Way too many.
Hi, Ian. Thanks a lot for the presentation. A question from my side. From the problems that you described, how many would you attribute to the ad filtering engine and how many to the filter lists?
So it's, I think it's very hard to describe for me, because usually when there's a problem with the ad filtering engine, with our ad filtering engine, we actually get much more input about this, because then there's going to be more sites breaking, because it's going to be a generic breakage. And then this allows us to fix it, and then we'll get less of that. But more of the specific feedback when it comes to individual sites, it's usually about something in the filter list, doing something that doesn't work correctly. What we usually do if we get an issue like this, someone in our test team will first try to do the same filter list in another ad blocker just to see if it's our ad blocking engine to blame or the filter list. And then usually when it's the filter list, if it's a small site, they will actually not continue. They will just hope that the filter list author fixes it quickly.
Got it, thank you.
Throw it. Yes.
Is there much communication between Opera and filter list authors? So if something does break, there should be like an open line of communication. So if website A breaks, that rather than just hope and wait something that gets fixed, is submit a report or just let somebody know. Like I guess go through GitHub and maybe submit a report saying, here's a website that's breaking. Can you guys see the same issue we're seeing?
Right, so the question is there communication between the filter authors?
Yeah, and Opera, I guess, yeah.
Yeah, so usually if there's something on a big site that we know a fix for, then we'll try to submit that fix to a filter list author, but I can't say there's a lot of communication between us and the filter authors, and we should probably improve that.
Okay, that's good.
All right, I'm gonna throw it right here. Attention, ready? There we go.
All right, College Irvine here. I was wondering if we can improve the communication also between ad blockers and website authors / publishers. Like best practices to follow, or if there's some communication like, oh, something breaks, users break, like users report breakage on your website, be informed about that.
Yeah, I think that's a very important one. We have some experience in this because there's also, of course, sites that break because you're using a different browser. And in this case, usually we need to, hunt the website owner and tell them, look, something's wrong on your site. You're detecting a user agent, and this should work in Opera, but it doesn't. But I have to say that reality is that it's very, very hard to reach website authors and get them to change anything. And this has been a consistent problem throughout the company's existence.
Yeah, I get that there's like websites who you can't reach out at all, but there's also like maybe better players who want to make sure their website is set up in such a way that the chance of breaking is as low as possible.
Right. So yeah, I guess here there's a chance also to publish more and
Sounds good.
Get people to see.
Okay. Any other question from the audience? Ah, over there.
So I like the idea of having feedback from users about sites breaking, and I wonder if you said that there's not enough feedback about sites, it's too generic or too specific. Do you think it's a fundamental issue with users not knowing what to report or how to report, or is it just a UX problem of the feedback mechanism not being discoverable in the UI of Opera? What do you think?
I hope it's a UX problem, because that means we can solve it. But the different things we've tried, we have not yet gotten enough feedback. There's also the thing that you cannot really disturb users too much and tell them you have to fill in this thing, because that's also not something they want. So has to be a balance that can be found between telling users that they can give us feedback, but not making it too obvious that it's annoying for them.
Okay. Any more questions from the audience? Don't be shy. Everybody has caught the catch box so far. It's fun.
Hi, your presentation was pretty much focused on desktop, if I got it right from the slides. So do you have similar mechanisms in place in your mobile apps? to collect feedback, and how is the split between mobile and desktop when it comes to the number of reports?
So I work on the desktop browser in Opera, and I cannot really tell you a lot about the mobile browser. We have an ad blocker in the mobile browser. I don't think there's a feedback mechanism, or not a quick one in any case. On mobile, this is an even harder problem because they have less space to give users the opportunity to do anything in the UI. So I think actually we get off easy here.
Anyone else having a spontaneous question? Otherwise, I might have a last one for you, Arjan. What do you think how filterless authors could help prevent these issues for the users?
I think, well, what's always important is to stay very specific. Most of the breakages you see are with filters that are a bit too generic. And then what happens is they break sites that they did not intend to break, but that they did not intend to fix either. So they weren't intended to block an ad on that site, but something goes wrong anyway.
Thank you. Final chance. Going once, going twice. OK. Thank you so much, Arjan. Big applause. OK. This was a really nice Q&A. Good exchange. Thank you for your questions. And by the way, we got this Q&A session here on site right now that you could hopefully see live at home as well. Still encouraging you also to use the chat. I'm sure Arjan will find a minute or two to also maybe answer a question there. All right. Then we are moving on with the program. We have one more speaker before we take one of the more extended coffee breaks. And our next speaker here will be Andrey Meshkov. He's the co-founder and CTO of AdGuard. And about, what is it now, October, at the beginning of August, I think it was, that I was reading industry news, as I usually do, and I was reading AdGuard published the world's first ad blocker built on Manifest v3. So I guess Andrey has quite some experience in building an ad blocker that works with MV3 and also knows the downsides and challenges that there are with it. And by the way, I'd also like to mention that AdGuard is our co-sponsor for the event today, and thank you for the engagement and making this possible. And yeah, that said, I would suggest, Andrey, please come to the stage.
Test. Hi, everyone. I'm really happy to see you all in person. It is finally a great experience to see you whole, and not just a part of you. And, well, let's see if it works. And today's topic is Manifest v3. So AdGuard started as a network-level ad blocker for Windows, but now we make a lot of different products, a VPN, an ad blocker, a DNS, and of course, we make lots of browser extensions. It's not just an ad blocker. It's also a VPN extension, an assistant extension for our desktop products, and so on and so on. So, well, the good thing is that I had an opportunity to take a look at Manifest v3 from different perspectives, not just from the perspective of a content blocker developer. And today I would like to tell you more about my experience with Manifest v3. Well, and everyone says it's bad. You see, you open the news, you read, well, the end is nigh, no more ad blockers and so on. But, well, no one tells you how bad is it exactly. And today I will try to explain everything in detail, and you will come to your own conclusions. But first, of course, we start with a history lesson, because, well, I love history. I should have been a historian. Just in case someone from the audience didn't hear about Manifest v3 and, I don't know, lived in a cave for the last years, let me give you a quick explanation. So you all know what a Chrome extension is. The extensions platform was first introduced, correct me if I'm wrong, in 2010. And it was a feature that literally everyone requested back then because Chrome was a great browser, and it is a great browser still, but it was not as customizable and as extendable as its main rival, Firefox. And so in 2010, the very first version of Chrome Web Store was launched, and the developers were allowed to extend Chrome's capabilities with additional features. This is when the very first version of the extensions platform first saw the light, and no one called it Manifest V1 back then. But for the sake of consistency, I will call it that way. So in Manifest V1, the extensions were rather limited. There was no possibility to control web requests. Basically, they could only show an icon and run a JavaScript file on a page, I don't know, create a new tab, and that was all. Not ideal at all, but actually the very first version of Adblock appeared and worked with Manifest V1, without any web requests at all. And it was enough for this Adblock extension to become extremely popular. Even though it was not ideal, it was working only cosmetically. Oh, I didn't see you. And without actually preventing loading of any ads. So in 2012, again, correct me if I'm wrong, the second version of extensions platform was introduced. It's not that it was that different from the first version. Basically, they just introduced the concept of a version and, I don't know, called it version 2. So makes sense. New APIs were added, and one of the main additions was web requests. The API that allowed extensions to control and manipulate web requests. And it was the turning point for ad blockers, since now we could actually decide what is allowed to load and what is not allowed to load. And it improved the quality of ad blocking, well, very, very strongly, I don't know. And then the APIs were slowly extended and improved with years and years. But overall, the situation stabilized until 2018. When Google introduced the new revolutionary changes to extensions platform that were called Manifest V3. And now we'll all learned that extension platform has versions, and well, and one of these changes was so-called declarative net request API that was supposed to replace the old web request. And it was heavily criticized, and I must admit that I was among the people who criticized it, and well, I still don't think that this is good news for ad blocking. But how bad is it? How bad is it exactly? In order to understand that, we should first take a look at how the old MV2 extensions work. And here's how it looks like. Briefly speaking, the content blocking extensions download filter lists that contain, well, the content blocking rules. These extensions then apply these rules when filtering web pages, and finally, work's done, the internet is usable again, everyone's happy. Technically, the extension's design looks like this. So we have the extension consists of a background page that runs privileged JavaScript in the background and a bunch of content scripts, one per frame. The background page runs all the time. It initializes so-called filtering engine, which is built using the sad filter lists. And the main part of this filtering engine is a search index that allows to very quickly find rules for a given web request. The filtering engine is also responsible for applying these rules. It decides whether the request is allowed or not. It decides what kind of cosmetic rules should be applied to a page, and so on and so on. Now that we know how it looks in general, I would like us to take a look at the rules, because, these are the most important parts of a content blocker. And mainly, filter lists consist of two kinds of rules. One we call network rules. They are supposed to block requests or modify responses, and they could be applied on different stages of a web request lifecycle: before web request, after receiving headers, before sending headers, and so on and so on. And on this slide, you can see an example of such a rule. But I will not dive into specifics here. And instead, I would like to introduce you the other part, the equally important part of content blocking, which is cosmetic rules. They are supposed, this is an umbrella term. It's not just about hiding elements, at least in my understanding, despite the example is exactly about that. Cosmetic rules are supposed to modify web page styles or web page behavior by injecting special CSS or JavaScript. So now that we know about these rules, let's talk about filter lists. Filter lists are basically simple text files which combine different kinds of filtering rules that in turn control how content blockers work. These filter lists, they are maintained by volunteers and/or professional maintainers. And there are currently over 2,000 known lists, and the number is growing. Remember this fact. We will return to it later. How does maintaining filter lists work? It is basically, for the most part, reacting to user reports and promptly resolving their issues. User reports may be about a missed ad or a missed tracker, or about a website breakage, whatever. The maintainer's task is to solve this issue as soon as possible and push a new update. And one more thing about maintaining filter lists, which is also important to realize, is that it is actually a very hard work. You can take a look at this slide and see that in AdGuard filters, one of the filter lists, powerhouses, there are about 80 new issues solved daily. And this is huge, actually. So this is a lot of work which is done. It is very important to then deliver this update to the users. Well, because some of these 80 issues might be critical, and it happens every day. Now that we know how it worked in MV2, let's talk about what will MV3 change. And it changed a lot. First, a couple of words about, how I learned it. We recently launched an experimental MV3 extension, and this talk is basically based on our experience with it. And the first thing I would like to talk about is the architecture of an MV3 extension. At least this is how I see it. One short disclaimer. This diagram shows what we expect to have in the future, because it has off-screen document on it. And currently, it is not available. And, in our experimental extension, we just use a single service worker and a bunch of crutches around it to make it work. But hopefully, with the off-screen document, it will be better. So the MV3 extension has more parts in it. There's a service worker, which is supposed to replace the background page. The problem with service workers is that their lifetime is limited by a seemingly arbitrarily chosen duration of 5 minutes, and after that, it is getting killed. So it's not a good place to keep the filtering engine, because the initialization of this filtering engine is a heavy operation, and repeating it every time the server, it's just too much. And why do we still need the service, the filtering engine? This is a good question because, well, now we have declarative net requests. Why not just use it? The thing is that network rules is only half of what we need. The other equally important half, the cosmetic rules, we still need to run a filtering engine that works with them. And the only seemingly suitable place to have it in Chrome is so-called off-screen document. This is a new entity that works in the background and can outlive the service worker. Well, and I have hopes for it. The network rules, in turn, are now built into the extension itself in form of static declarative rules sets. The extension cannot change them in runtime. We can only change which one of them is enabled or disabled, and so on. And a couple of words about network rules. You see, historically, content blockers created some sort of a syntax for filtering rules, and every content blocker follows the same pattern. We can extend the syntax a little bit from this side or that side, but generally the idea stays the same. Declarative net request uses a different syntax, a JSON-based syntax, and, well, naturally, we want to keep using the old one, so we had to come up with some kind of a conversion mechanism that converts the old syntax into the new one, because no one wants to interact with JSONs. Everyone wants to use the good old filter lists. It's not much of a problem. We did this already with Safari content blocking. Now we do this with MV3. Not a big deal, but, well, it's important to realize. And filters conversion, this mechanism, it actually produces two different artifacts for every filter list. This is a declarative rule set and a source map. And source map is a very important concept that, well, appeared here. Because, as I said, maintainers know nothing about JSON format. They don't want to know anything about it. They want to interact with regular rules. And we need to have something that connects the regular rules with these declarative rules. So these are called source maps. And regarding cosmetic rules, MV3 doesn't provide any alternative to cosmetic rules, and what this means for the extensions. We still require very wide and powerful permissions. So one of the goals of MV3 was narrowing the scope, but unless we have an alternative to cosmetic rules, a declarative alternative, that won't be possible. We still will require, well, all URLs, permission, and, well, everything you have. And also it means that we still have to run a filtering engine instance in the background. Otherwise, it would be too hard to quickly find cosmetic rules that should be applied to this or that page. And a bit illogical, but we're getting back to declarative rule sets. Just to show you how exactly they are built into the extension. So extension manifest file has a special section where you configure which lists you include there. You do this on build time, and in runtime, extensions can only enable or disable the said lists. We also have dynamic rules that can be changed in runtime, but the number of these rules is very limited, so it's okay for hotfixes maybe, but well, the usage of dynamic rules is rather limited. At first, we thought that this is not much of a problem, that the review process for MV3 extensions will be more prompt and reliable than it was for MV2. We will just upload a new version of the extension every day. But it seems that it doesn't work that way. The review process still may take like a couple of days, and this is not ideal. We need to deliver updates more often, and that's why we need to talk about dynamic updates. And bad news, you cannot serve differential updates to an MV3 extension because the problem is that we cannot disable individual rules inside a static rule set. So you can only apply a part of a differential update. You cannot apply the negative part. But there are good news as well. This is a work in progress, and I really hope that this functionality will be available soon. And I think Felipe from Igalia will be talking about that today, and please do not miss his talk. Well, it will be useful. And finally, one more important thing. This is about rule limits. You see, Chrome imposes rather strict limits on the number of rules and rule sets in an extension. The current limits, I must admit, are much better than they were in the very beginning. So there's a guaranteed limit of 30K rules per extension, and there's also a limit of 300K rules shared among all extensions. And right now, it is very hard to say is it okay or not, because if you run just a single content blocker, this seems to be okay. But if you run, for some reason, many content blockers, and users tend to do that all the time, so that's their usual pattern. Something is not blocked with their current ad blocker. How to solve it? Of course, install another one, and then another one, and then another one. And then it's uncontrollable. And that's why it's rather hard to predict what impact these limits will have and whether they're okay or not. And finally, service worker and friends. When Manifest v3 was announced, what we feared most was declarative net request. So everyone was so concerned about it. But in reality, it appears that the real main source of pain for every developer was actually this move to service workers. And I honestly suspect that declarative net request is actually just a consequence of this move, and well, and that's all. Now we're in a situation when two different approaches to this move exist. Safari and Mozilla push for using so-called limited event pages, which is almost the same as the old background page, but with a few benefits, since it can get killed, but only when it is not used anymore. Sounds like very logical. Chrome team insists on service workers because, well, they will tell you. And in order to cover the other use cases, they plan to implement a new type of a background page called off-screen document. The difference is that this document doesn't have access to extension APIs, but at the same time, it does have access to DOM APIs. And it can communicate with the service worker, and it can outlive it. And as an extension developer, of course, I would probably prefer limited event pages because, well, you know, I have enough headache with other things in MV3, so, well. But honestly, off-screen document makes sense on paper, and well, let's see how it plays out. I'm not ready to criticize it too much at this point. Impact on filter lists. So I think that filter lists and filter list maintainers might be the main victim of MV3. What happens to them? How will MV3 influence the work of filter lists maintainers? Let's take a look at 3 points. The first one is debugging filter lists. Maintainers need to have tools to debug their lists and check new rules. In MV2, every content blocker provides such a tool. For instance, on this slide, you can see the tool that AdGuard provides, and well, Adblock, uBlock Origin, and well, we all provide this kind of tools. In MV3, debugging is much more complicated, mostly because the maintainer now is required to use an unpacked extension. So basically, it means you should go to the repo, clone the extension, build it yourself. And consider this, a maintainer may need to check the new rule with several ad blockers, and this means that these ad blockers may have different build systems. Their main branch might be out of sync with what you have in the Chrome store. And all this combined makes the whole maintaining process, debugging process, much more complicated, and the probability of an error is much higher. And I really hope that this limitation can be either lifted, or maybe there could be a better way to, to allow users to get access to the debugging interface. The second point, this one is not for browser developers. This one is more about us. So rule syntax, it doesn't change. This means that we will be using the same lists for all extensions, regardless of whether this is an MV3 extension, an MV2, or, I don't know, a desktop product. That's why we developers need to provide maintainers with a way to control which rules are used in MV3 extensions and which aren't. And fortunately, there is already a mechanism that can be used for that. It is called preprocessor directives, and it is supported by AdGuard and by uBlock Origin. And I really hope that other content blockers will also support it, because, well, I think that it is very important at this point when we have such a split. And finally, third point, and I would like to talk about limits again. So Chrome imposes limits on the number of static rule sets that can be included into the extension. You can only include up to 50 rule sets, and you can only enable up to 10 rule sets. Now combine this with the fact that there are over 2,000 known filter lists. How are we supposed to choose the chosen ones? What will motivate people to create new lists when all the slots in the browser extensions are already occupied? What will they do when their custom list does not fit the dynamic limit anymore? And there are several things that can be improved in this regard. And the first thing is obviously increasing the limits, because, well, why 50, why 10? And I hope that if we present the real use cases to the browser developers, they will listen and increase it, well, a little bit. I'm not asking to set it to 2,000, okay? So the second point is that we may need to start thinking about consolidating the most popular lists. It's not that I suggest merging everything right away. I don't think it's possible. And I even think that every ad blocker may do some kind of a consolidation on their side. I don't know, merge easily AdGuard based filter merge, easy privacy, AdGuard tracking protection, and well, in a single rule set in Chrome, for instance. But anyway, we should at least start considering that we're doing the same work 3 times, at least 3 times. And finally, the dynamic rules limit, another point. It might be okay for a casual user that is not interested in installing custom lists and so on. But we really would love to have an option to increase it. Maybe through Chrome flags or whatever, at least give us something. Don't make us recompile Chrome on our own to increase it. And finally, a couple ideas for MV4, because, well, using the opportunity to pitch these ideas right now. Please listen. So, first, declarative cosmetic rules. One of the goals of MV3 was having extensions with fewer permissions. And this is a noble goal. And this is not a bad goal, but, well, you should give us the instruments. And the missing instrument right now is declarative cosmetic rules. If we had it, we would achieve 2 things. First, ad blockers with no extra permissions will finally become a possibility. And this fact alone, this possibility, it is a great motivation to provide such a product to the users, because users, they do want to have an ad blocker that cannot see what they do. I see this in Safari. So in Safari, for instance, in Safari, we have a separate model that has extended wide permissions, and we have a base core model that only uses the declarative rules. And lots of users, they opt just to use this limited model because the other one requires lots of permissions, and they're happy. They know that we cannot see what they do. They are safe. And we're happy to provide them with this opportunity. And, well, just give us the tools. And the second point is debugging tools. And again, this is from my Safari content blocking experience. Declarative net request, just like Safari content blocking API, does not provide any convenient tools for debugging rules. And no tools means unhappy maintainers, which means worse filters for your browser, which means unhappy users of your browser. Give us something. You have developer tools. Think about it. Well, maybe there could be some integration between DNR and developer tools. It will mean a lot for us. Finally, so how bad it is after all? And I don't have a definitive answer. So here's what I think. It is not as bad as we feared it will be. It is not as good as we want it to be. It can be improved, and it is improved. Just a short story. Last night I was working, and I saw that Devlin makes a commit. It's a nighttime. And I think, OK, he must be in the US. We'll be talking online. But no, he's working. He's working on improving it right now. Even right now, by the way. And finally, I think that everything will be forgiven if this MV3 is what's required to bring extensions to mobile. Well, like immediately. So that's all. Thank you very much for your attention, and I will be happy to answer any questions you have.
Thank you, Andrey. This was a really interesting presentation. I definitely learned a lot. And yeah, do we have some questions in the audience? I would expect some over there all the way.
Throw it.
Okay.
All right, so I'm not sure what's the relationship between MV3 and getting extensions to mobile. Why didn't you have extensions on mobile?
Why do I think that this is? You see, on mobile apps are just like service workers now are ephemeral, and they can be killed at any point. And well, no one ever confirmed it. So no worries. But it just appears to me that this sounds awfully connected. So ephemeral service worker, ephemeral apps, extension developers, be ready that your app, your extension can be killed anytime. That's the same words I hear as a mobile app developer. Be prepared. Your app can be killed anytime. Well, that's why I make these parallels, and I want to believe that this is true. But they will never confirm it anyway, so don't look at them.
Okay, there's one over here.
Behind.
Yeah, just curious, how much code have you been able to share between your existing Manifest v2 version and Manifest v3?
We had to share a lot, but mostly because we still need to run the old filtering engine for the cosmetic part, so the filter engine is basically shared. And we had to build the conversion mechanism, but it is also based on this engine code, because we need to create instances of network rules, and they are already parsed, and we can use their properties to convert into declarative syntax. So the code sharing is considerable, but it's not that we just switch the version in the manifest. No, it's a lot of work anyway.
I'm back with you.
Nope.
Is there any performance differences between V3 and V2?
We didn't do any benchmarks, mostly because we believe that the current version without off-screen document will work awfully bad, because the service worker is recreated all the time, and the initialization process should be well repeated. But when we have the off-screen document, we will probably try to check it. But anyway, we shouldn't believe these tests right away. So the Chrome's code is changing. The whole idea was to bring the filtering closer to the network service of Chrome, so that there was less inter-process communication, so that they could make the decision faster. And I'm not sure, well, maybe we should do that in a year when the old code is no more, when there is no blocking web request. Maybe we should. Maybe we can run benchmarks already, so, well, if you can comment.
Remember to speak right into it.
Yeah, good?
Yes.
Okay. Yeah, I think a lot of it will depend on the other extensions that are installed. So we're only as fast in a network request as the slowest extension. So if we were to have a setup where we have one MV3 extension with declarative net requests where everything can be processed more synchronously, and we don't have to wait for that extension process, then we can do that comparison.
Yeah.
But even then, a lot of the challenge becomes that it is often an apples to oranges comparison because of the differences in functionality between the MV2 and MV3 extensions. And so I agree with you that we should do these tests once everything has kind of settled down a little bit, and we have some more
in a couple of years, because now the tests won't. It's not. We don't have the end product yet, which is surprising. But anyway, but once we have, probably this is when we should do the benchmarks.
I think somebody already has the cube ready there.
Maybe
Hi,
there.
Andrey, thank you for your talk. It was excellent and really interesting. I was curious whether you did any testing of trying to load, reach the limits of the filter list.
We did.
You did. Did you hit the? How quickly did you hit the limits, or did you?
It was just synthetic tests, because with existing lists, with what we preloaded, since we cannot enable more than 10 rule sets, it's rather hard to reach this 300K limit. With the regular setup, I have a, by the way, I have a slide here with the rule limits. Here it is. And this is a slide from my computer from the version that I'm running with 6 lists. And as you can see, there are only 100K rules used from the limit. And, well, as long as there's just a single ad blocker, the limits are okay.
But I mean, one of the things that you talked about is consolidating the lists,
Yeah.
which I think will happen because you can only have.
Well,
a
I hope
limited
so.
number, right? But then that's going to massively increase the number of rule sets. Isn't it? So
I'm not so sure, because
Really?
the lists currently, they share a lot of rules. There are a lot of duplicates. And again, we do a lot of work to remove redundant and obsolete rules, and the lists still have a lot of them. Well, Fanboy, for one, he made great job cleaning up easy lists that reduced the size like twice. And the same thing can be done with AdGuard filters. I'm not so sure that consolidation will run into this rules limit. But I'm seeing it as a necessity because of the rule sets limit, which is rather low. Which prevents, well, why I think that this is important, because how it works, basically. So there's a power user, and he's not happy with the list that, well, we have on the internet, and he creates his own little list, calls it, I don't know, web ultra very magic lists, I don't know. And after that, he starts like adding new rules and shares this list on the internet. People start using it. The list grows bigger, 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 and then we have a bunch of lists that are called Fanboy lists, and then Fanboy manages easy list, and well, that's how the community works, how it grows. And if we take it from the community, it will hurt. It will hurt the overall quality, the growth of the filter list. That's what I'm concerned about.
Me too.
Yeah.
The one thing I'm worried about with the consolidation is that it creates a sort of single point of failure.
Yeah, sure.
So, and it's more work for rule sets to filter up to actually being used.
Yeah, that's why I'm not saying that we should like merge everything right away. No. We will always have this ad blocker specific like add-ons anyway, however we consolidate. But I still think that currently we do a lot of like double work, the same things in different places, and we could avoid it.
Thanks, Andrew.
All right. One more question over there.
Hi. So you hear me, right? Andrey, this is Humera. Moving a little bit towards the user side, so I read this report that came out that it's the Manifest v3 compatible version is out there. How is the user response? Do you see many downloads? Do you see many installs? How are they taking it?
We don't promote it actually a lot. So there are a couple of thousand users that saw it in the news, like 5,000, something like that, maybe 10, that saw it in the news and installed. The extension rating is rather high. So it's like 4 and 4.6 or something like that. Regarding the feedback that we had, it was controversial. So some people say, oh, cool, so it's not the end, I'm still using Chrome. And some say, AdGuard, why are you doing that? boycott them. So let's switch to Firefox right away, and never do any extensions for Chrome. And so it's hard to communicate with such people, but they exist. They exist. A part of them still use Chrome, by the way. So I'm not sure how it works in their brains. Well, that's it, I guess.
Cool. A follow-up question. So did they recognize some problems in using that particular version of
Yeah, of course. And the main problem with the extension right now is this the service worker itself, because we don't use the off-screen document because Devlin works on it right now, maybe right now, like literally. And well, there are some issues here and there, some like ads flashing because there's a visible delay because we need to reinitialize filter in engine. But we hope that it will go away. So once the situation is stabilized, once all the APIs that we need are implemented, we really hope that the quality it will be rather good. So almost the same as we have in MV2. The main concern with MV3, what many people talk about, and me included, is that with declarative network rules, it will be much harder to innovate, to create new types of rules, and we sometimes still do that. Even this year, I think a new modifier was implemented in network rules, and this is partly true. Again, on one hand, I see that Chrome team, they work, they do a lot of work, they listen to some feedback, and some things get improved. Also, I see that it is possible to bring a pull request, and maybe in half a year it will be merged. It takes a lot of time. You need to, it's hard to commit to Chrome. But at the same time, MV3 will be used not just by Chrome, but by Safari, by Mozilla. We will do the same work. In order to innovate into declarative net request, we will probably need to do the same thing 3 times in 3 different browsers. And well, so yeah, this is true. Declarative net request is worse than imperative approach for our purposes. It could be. It could have, there could be an explanation. But anyway, as a content blocker developer, I think that it will slow us down, unfortunately. Not right now, in a couple of years.
Do you think that Manifest v3 will make it harder for you to distinguish your ad filtering engine from others and to compete on that aspect?
I don't really believe that ad filtering engine is the only important thing we need to distinguish ourselves. I actually think that most of the browser extensions filtering engines are pretty much on the same level at this moment. And the fact that half of this engine now will be declarative net requests doesn't change much. They work pretty much the same. They will be pretty much the same. Well, I don't see much of a problem for us as a company here.
All righty. Any final questions for Andrey? Now's the chance. Okay, questions seem to have come to a stop. Then thank you, Andrey. I really loved your pitch idea for MV4, by the way. That was a good trial here. Some relevant audiences listening, so
thank you.
Thank you. Alrighty, and this is the time for our first break. I mentioned we will do regular breaks. We will meet here again at 12. As mentioned, you can find beverages at your convenience if you take a ride and go down the stairs to the bar. If you want to have a smoke, you might as well also use the terrace right behind me. Thank you, and see you back at 12. right, we're resuming program here. Hope everybody's had a nice snack and a coffee break here in Amsterdam, and I hope the same holds true for the remote people at home. I hope you also got yourself a nice hot cup of tea or coffee and are getting all set for our next sessions. And yeah, I hope the on-site people had great conversations too. So we have another block of 3 sessions before we actually have a bigger lunch break, which I later on noticed I forgot to mention when I was describing the breaks that we have during the day. So no worries, there will be also an extended break for having actual food. But now we first have the 3 sessions, as I mentioned, and we will start with Anton Lazarev, who is an engineer at Brave. And Anton is responsible for many of Brave's content blocking features, including support for CNAME uncloaking, cosmetic filtering in Brave's Rust-based ad blocker. And in his free time, Anton enjoys being active in the open space community, and he loves contributing to software that respects users' choices and their interests. And yeah, Anton also studied computer science and computer engineering at the Northwestern University and is now going to tell us more about content blocking, collaboration in a manifest v3 world. Welcome to the stage, Anton.
Yeah, so yeah, for those of you who haven't met me, I'm Anton. I work on ad blocking at Brave. And yeah, I've titled my talk Content Blocking Collaboration in a Manifest v3 World. So if you're not aware of Brave, we basically have a browser. There's ad blocking built in and on by default. The browser is based on Chromium, and we actually don't rely on Manifest v2 or v3 at all because we patch directly into the source code for the ad blocking. So you might be wondering, why is this guy giving a talk about Manifest v3? The answer is filter lists. Ever since the beginning, we've basically used the same filter lists that extension-based ad blockers have been using, and that's been great for us because we don't have to have a separate set of filter lists that we're maintaining. And it's also been great. We've been able to upstream changes back to the community and collaborate a lot on that front. But of course, Manifest v3, the big change is declarative net request. We have this completely different JSON-based syntax. There's a limit to how many rules you can have. Andrey's actually talked a lot about this, so I won't go too much into detail here. But again, yeah, there's the question of, will we still be able to use the same filter lists? What's going to happen to the filter list going forward? So that's basically what I want to focus on. And I think to answer that, it's important to look at basically what the upcoming ad blocking landscape is going to look like. In particular, if you have a Manifest v2 extension today, what kind of options do you have going forward? So obviously, first option, rebuild for Manifest v3. And yeah, we've seen that happening. Of course, the AdGuard Manifest v3 extension, the uBlock Origin Minhas, or Lite as it's called now, I believe. Yeah, it's happening. And what we've seen is that these extensions, they do work. They're able to block ads. Of course, there are some limitations as we've seen. But they are generally working. But maybe, I think there might be some potential concerns, especially if you look forward into the future as to what might be happening with Manifest v3. In particular, I mean, there is a page of known issues when migrating to Manifest v3 that Google has published. And I mean, there are kind of a lot of them, actually. And of course, being software, there's probably some unknown ones, too. So that's something to consider, right? You're basically building your entire platform, again, on a new platform, which is still a work in progress, and you have a deadline. So all I can say is if you're doing this route, lots of respect to you, because that sounds very stressful. And another thing to consider, right, the web keeps evolving. We've seen Google even having proposals like signed exchanges, where network requests could be authenticated by a different domain than they're actually served by. And so that potentially causes some issues with how we do ad blocking today. You can have a domain-specific rule, but when you have 2 different domains responsible for bringing that rule to that network request to you, how are you going to signal that out for blocking? And web bundles is another example. Basically taking a whole bunch of requests for a single website and putting them into a single network request. such that that's served as a single unit. Adblocking, again, isn't necessarily ready to handle this because these are now not separate network requests. You can't single them out with separate rules. So you might need a new syntax or something to describe this. And I think there's a big question of like, if these APIs become a reality, how is Manifest v3 going to be updated in correspondence to address them? And I mean, you have to consider maybe they will be addressed, but maybe it won't be prioritized. Or maybe you're even going to have to learn C++ yourself as an extension developer just to get these features in that you require. And who knows if your patches will even be accepted. Maybe it's going to be very difficult to get past code review. I mean, I can't answer these questions, but they are certainly unknowns. And I think there's a lot of questions still with Manifest v3 going forwards. Which brings me to the next option. You can continue using Manifest v2, right? Of course, the big news is that Manifest v2 is going away. But, I mean, Chrome isn't the only browser out there. Brave is actually committed to continuing to maintain Manifest v2 and web request so that extensions that we are already familiar with will continue to work in Brave. We actually continue using uBlock Origin for their logging a lot of times internally, just because they have really good logging, and we appreciate that a lot. And we know that Adblock developers put on a lot of thought to the security and privacy and performance kind of concerns about their extensions. So we definitely want to recognize that as much as possible. But we're not alone here. Firefox, Vivaldi, and Opera have all committed to, at least some extent, to trying to support these older extensions, whether that means keeping Manifest v2 or just web request, so that there's still more options available there. There's still definitely a concern about market share, right? I'm sure a lot of you are familiar with a graph like this. Chrome has a very large market share compared to everyone else. But honestly, as an extension developer, you have opportunities here. You can actually put pop-up notifications in the browser. It's not unprecedented, right? Tell users that they have a chance of trying out a new browser which actually supports some of the features that they're interested in, and that could be an option, right? I'd be happy if you got users to switch to Brave, but there's plenty of options out there, and honestly, more client diversity is just a good thing for the web in general, I would say. And speaking of client diversity, third option is to build your own browser. And I know everyone thinks that's crazy, but I'd like to maybe convince you that maybe that's not so crazy after all, right? If you look at the existing browser landscape, there's actually a lot of browsers built on Chromium today. If you want to build a browser for iOS, you're basically limited to WebKit. And so every browser on iOS is based on WebKit. Tor has been building on Firefox for a pretty long time now. And there's actually even startups that are building on top of Brave, which is kind of interesting to see. But it is really becoming increasingly popular to take an open source rendering and execution engine and basically build your own patches on top of that to redefine the vision of what it means to be browsing the internet. And I think that rings true for Brave in particular. And we've been doing a pretty good job at this, I think. We've been documenting all of our processes publicly on our GitHub wiki, and we have a pretty nice set of directions here whenever we onboard new developers. They're looking at this wiki and figuring out how to patch Chromium, and I mean, as a result, we basically have less than 24 hours usually in between a Chromium release and the corresponding Brave release, so we kind of have this down to a science. And speaking from my own personal experience, since I kind of build Adblocking into the browser, I think it's a lot of fun, right? You actually don't need that many patches to have a good result. If you think about for an ad blocker, right, you have basically, you need to make decisions in the network stack as to whether a request needs to continue or be stopped. And so that's a small patch. And then you need maybe to inject some CSS or JavaScript into a page. That's maybe another small patch. And all of a sudden, you have a complete freedom to use your own engine or any other code to put logic into those two places that are patched in C++. And personally, I've been building in Rust. Rust is awesome. It gives you a lot of security and performance. And it's just a joy to work in. So I think there's a lot of flexibility there too. Of course, if you're building your own browser, you have kind of the ultimate power move, right? Git revert. If you're not happy with something that upstream has done, you can always undo it. There's only a small maintenance cost going forward, but if you think about the size of a browser code base, it's actually not that big of a maintenance cost if you do your patches correctly, because the odds that a single part of the code will change significantly over time is not that high. And again, there's no more API limitations, right? I know a lot of people have been interested in seeing CNAME uncloaking on Chromium, and there's been these open issues about getting some kind of DNS API available in Manifest v2 and also in Manifest v3. These have been basically open since 2021, and I haven't seen any activity on these two particular issues since March 2022. So I'm not exactly sure what the status is there. I have seen that there was some interest in getting some kind of DNS abilities in Manifest v3 from this issue, but it wasn't on the known issue list. So again, I don't really know what's happening there. But I didn't really have to worry about this when I went ahead and supported CNAME uncloaking in Brave. I basically just made a single PR here, which was less than 200 lines, as you can see. And I didn't have to ask anyone permission. That's basically the code was mine to work with. And we've had CNAME uncloaking since then, so that's been pretty cool. And having your own browser is also a great kind of experimentation test bed as well. I'm technically under the research team, and we've put in a lot of protections for privacy that are kind of adjacent to ad blocking and give a similar second line of defense, we could say. So farbling, for example, is randomizing different results of web APIs so that it's much harder for fingerprinting scripts to produce a persistent identifier based on your browser hardware or setup. Ephemeral third-party storage is a great way to make sure that third-party embedded content is not able to track you between different websites. That's all completely separated. Sugarcoat is a nice pipeline we built on top of PageGraph, which is like complete in-browser tooling. And Sugarcoat is able to create privacy-preserving replacements for resources on the web that normally might be blocked, but would cause too much web compat breakage if they were just straight out blocked. And we've been posting about a whole lot of other privacy updates if you're interested. So yeah, that's kind of the upcoming landscape, roughly, of people who use filter lists. And obviously, if you're using option 2 or option 3, you're not going to have to really think about filter lists too much. You can continue using the ones that you've always been using. And I can say for Brave, definitely we'll be continuing to use EasyList, Easy Privacy, and all the other great filter lists out there and maintaining them as much as we have to. But for option 1, yeah, you're now going to have to think about what kind of filter lists are we using, where are we going to be getting those from. And I definitely want to stress that the worst possible thing that could be an outcome of Manifest v3 is if we kind of split the whole ecosystem into 2 different camps here. So basically, the community is all working together on solving this issue of making the web a better place right now. And if that's in 2 different parties, then all of a sudden we have to work twice as hard in each respective camp. And that's not good for anyone, pretty much. So I think it's important to consider how can we prepare for this upcoming landscape. And as Andrey has mentioned before, I think list conversion tools are a great idea. That way we can continue using the same filter lists as a single source of truth and derive whatever capabilities we need from those. And this is not new at all. This syntax here looks a lot like what I showed you earlier from declarative net request, but it's actually the iOS content blocking syntax. That's a screenshot directly from Apple's documentation. And yeah, it's JSON-based. There's a limit to how many rules you can load. And again, there's not necessarily one-to-one feature mappings between the 2 syntaxes, but this is totally something you can convert from. I personally built out a conversion tool in AdBlock Rust, which can do this exact thing. I know AdGuard has their own too. And another thing that we need to keep in mind is the size of those lists. And for that, we actually built out a thing called SlimList, which is a pipeline that crawls the most popular sites on the internet and is able to take the most important filter lists rules and basically consolidate just the ones that are most effective by measuring how often those rules are triggered on the web. And so that allows us to really make the most of the rule limit on iOS without sacrificing too much privacy for users. Another thing we can do is just to keep lists clean, right? Because keeping lists clean is great for even existing ad blockers. The fewer rules you have in your lists, the better memory performance you'll have at runtime, and fewer downloads and bandwidth concerns for users who are downloading these lists. But especially going forwards, if we're going to have Chrome and iOS both limiting the number of rules you can load at runtime, that's going to be very important to have small lists as much as possible. So we've actually been sponsoring Ryan Brown, our fanboy, his work on EasyList as a maintainer. And that's been awesome. Especially recently, he's been focusing on making sure that we've been removing a lot of generic cosmetic rules. And I wanted to showcase some of his work here. So yeah, a while ago, you had a lot of more handmade sites, a lot of custom-built scripts, and people would be dumping, say, images named adbanner.png into their public HTML directory, and that was that, just for themselves to keep it organized, really. So we would have a lot of rules targeting kind of generic resource names that we would expect to see as a content that we wouldn't like. These days, you see a lot of third-party platforms for ad serving or user tracking or things like that. And that actually makes it a lot easier for filterless maintainers. Once you find and identify something that isn't good on a website, chances are it's shared by a bunch of other websites too as a third-party resource. So that allows us to have a much more compact kind of list and be much more efficient there. So what Ryan's been doing is going ahead and removing a bunch of cosmetic rules. So for example, somebody probably had had an element on their page at one point called more ads, and that's probably not relevant anymore. So this and a bunch of others have been deleted over the last few months. And if we look at the size of that general hide list in EasyList, this is about 2/3 of what it was at the maximum, and this is bringing it back down to like 2016, 2017 levels, which is awesome to see. We also have a similar thing for network blocking. So at some point, probably someone had an ads folder in their UI directory because they're showing things that are in the UI of the website, and maybe that's not relevant anymore, or maybe we can narrow that down to a few specific websites that are using a similar scheme. So that makes it a lot easier. And again, for the network blocking list, this is almost half of what it was at the highest amount, and that's bringing us back to like 2013 levels of size. So that's great to see. Huge shout out to Ryan, who's here today. And finally, I think the most important thing we can do is just continue to be sharing efforts as much as possible. So, I mean, Brave has been built on the shoulders of giants, really, in the ad blocking community. A lot of this wouldn't have been possible without so much open work on filter lists and the extensions themselves. But basically, everything Brave has been doing has been open source. The browser itself, all of the patches, the ad blocking engine, the ad blocking infrastructure on our server side, that's all open source, and we've been publishing it freely as much as possible. We've been publishing our research on privacy and ad blocking and other related topics so that everyone else in the community can benefit from those as well. And I think really going forward, communication is going to be super important because we're going to have different platforms with different capabilities, and it's going to be more important than ever that AdBlock developers and filterless maintainers are talking to each other and sharing what's not working, what is working, and making sure that we can make our lists as effective as possible for everyone. And yeah, I think it's really important to keep in mind that we all ultimately have the same goal. I know a lot of AdBlock extensions and platforms maybe have slightly different priorities. Some of them want to block as much as possible. Some of them want to preserve more of the publisher content. Some of them focus on giving users as many tools to tweak the experience as much as possible, and some of them are really focusing on a nice out-of-the-box experience where you don't have to tweak anything. But ultimately, we all want to make the web better for users, and so I think we should focus on building the technology that enables that, because ultimately we all want to build a better user-respecting user agent. So I'm looking forward to seeing that with all of you, and thanks.
Hello. Me again. Thank you, Anton. This was really interesting. Again, we have a little bit of time for questions. Just in case, me and my colleague Susanne would like to, maybe in a flight attendant style, quickly remind you of how this mic works, ideally for our remote audience to be perfectly hearable. You take it uncomfortably close to you, and you will look super funny when people look at you, like this. And then people can hear you just fine. So this is how this thing works, just as a gentle reminder. So who's got a question for Anton? OK, I will make an attempt here. Woo!
Hi. My question is about Brave's claim that you would like to keep Manifest v2 alive and to continue to support it. It seems to me that extensions is not just about supporting them by the browser, but it's also about distributing these extensions. And the problem is that at some point, Chrome Web Store doesn't allow Manifest v2 extensions anymore, and we do not have any alternative place to actually distribute these extensions. If you make the users download the CRX file from somewhere on the web, it is at least not very convenient, at least. There are more problems about that. So what do you think?
Yeah, so we actually are in internal discussions right now about building out a web store replacement where users will continue to be able to get Manifest v2 extensions going forwards. We don't have anything to publish on that at the moment, but that's certainly something we're working on internally.
Yes.
And I'll mention, too, if you have any feedback on what you'd like to see on that kind of platform, feel free to reach out. We'd be happy to talk about that.
OK, so a different facet of this problem is that the extension developers, if Chrome has 70% or 75% or whatever market share, they're incentivized to write MV3 extensions. And if they only would maintain MV2 versions for Brave and Brave's App Store or extension store, it's not, it's not a huge audience for them. So I think it still might die a natural death in the sense that why would you spend effort on maintaining an MV2 extension just for Brave, right?
Yeah, I mean, it's a reasonable concern, and that's why there are multiple options, of course. It's not the only option to stay on Manifest v2. You can certainly do whatever you'd like. And I know, for example, I've been looking a little bit at the uBlock Origin extension for Manifest v3. They're actually building it straight in the same code base as the original uBlock Origin extension. So there is potentially some capability of maintaining multiple in the same code base and not having to kind of do that much duplicated effort. But again, there are differences, and ultimately it's up to the extension developers what kind of route they want to take there.
Hi, thanks for your talk. It was great. Have you published any tools that help with converting lists?
Yeah, so we have the iOS conversion tool, which converts to the iOS content blocking syntax. We haven't actually done anything in terms of Manifest v3 formats, but I would be happy to add that into AdBlock Rust if that's something somebody's interested in contributing, or I think that's just a thing that people should be focusing on in general now that Manifest v3 is coming out.
Yeah, I think talking about Andrey's point earlier about consolidating things, having a kind of some place where you can easily convert the filter list rules would be useful. So
yeah,
it's the kind of thing that Brave could do really well.
Yeah. And again, I think the best place for this is actually in the extension itself, if possible. But who knows? Maybe that's not a practical thing to do.
I was thinking, because there's tons of ways for ad filtering that aren't inside a browser as well. And I think that a lot of them use the ABP format. So having a central place to be able to kind of dick around with the formats would be useful, I think.
Yeah, I think that makes sense. So one cool thing actually about building an ad block engine in Rust is we can compile it to WASM and run it in a browser too. So
okay. Yeah, cool.
I've actually built kind of a prototype dashboard where you can kind of tweak filters and things like that. I think that would be fun, yeah.
Alrighty, there's a question over there, but I think, Smart already got the box.
Yeah. Thank you for your talk. Are there other Chromium-based browsers which have the intention of supporting, like keeping support for MV2 and for like APIs like web request? And is there like an opportunity to work together to keep that support?
So I've definitely seen some talk about Vivaldi and Opera trying to support Manifest v2 or web request going forwards. I can't speak for them, obviously, but based on what I've seen online, there is certain discussion about that.
Okay. Any further questions from the audience? Oh, there's one.
Do you have any concerns that at some point you physically won't be able to maintain Manifest v2 anymore?
I mean, it's certainly, there is going to be an ongoing maintenance cost, and I think Brave is committed to working with that as much as possible. I think the main decision of whether or not to continue with Manifest v2 will come based on the extension ecosystem. So if it turns out that most people have decided that Manifest v2 isn't useful anymore, then maybe that's time to let go of it. But I think in the meantime, we're at least still getting a lot of use cases out of Manifest v2 in terms of filter debugging and things like that. So no reason to get rid of it, really.
I think we have time for one last question. Somebody wants to take the opportunity?
Or maybe I'm going to go again. So you mentioned also web bundles and signed exchanger, I think, and in conjunction with MV3, all of these are throwing a wrench in the ad blocking space. And I wonder what's your feeling? Does it seem like these are all like legit improvements to the web overall? Or are they like Google's attempt to destroy ad blocking?
Well, I don't want to make any claims like that. They certainly have some technical merits, but I know my boss, Pete Snyder, he works a lot in the privacy space and does the kind of committees and things like that. So I think he's taken a public stance on them not being great for the web in general. I would generally agree with him. I think he's a smart guy. So.
All right. Then thanks so much, Anton.
Thank you.
And please give him a hand here. All right. Then we are slowly but surely, I believe, getting ready for our first remote speaker of the day. And his name is Felipe Erias Morandeira. I hope I pronounced that correctly. And Felipe is a software engineer and interaction designer, and he is currently part of the web platform at Igalia. For the ones of you who may not have heard about Igalia before, it's an expert consultancy that is specialized on free software technologies. And Felipe contributed to many projects. He has contributed to the WebKit and Chromium web engines, and he also participated in the standardization efforts in the W3C and IETF. And did I miss anything? I think he also actually worked on research and developed different mobile technologies. Right, that's it. And now we... Perfect, I can see you on the screen here at the bottom. Everything seems to be working. So we can get ready for Felipe on more control over static filter rules.
Hello, everybody. Thank you very much. First of all, the slides for my talk are available online at this address, people@igalia.com/morandeira/2022 @filtering. I put it already also in in the chat of the conference, just in case anybody wants to follow along or have a look at the links and so on. Today, I am going to be talking about the work that we have been doing on ad filtering and declarative net requests over the past months. In this talk, I'm going to describe a specific problem that came up in the transition to the declarative net request API. Then I will describe the API that we are, see that? Sorry. Sorry. Yeah, so basically I'm going to be talking about this problem that came up in the transition to declarative net request, the API that we are proposing, the different approaches that we follow for the implementation, and finally some initial benchmarks of this kind of show that we are in the right approach. This is still all a work in progress. I think we will be getting more concrete results, I hope, in the next few weeks and months. But this is still, as I said, work in progress. And then finally, I have some conclusions about the general experience of contributing to the Web Extensions API. So we start with the status as it was until very recently. As you know, in the previous version of the extensions platform, you can use the Web Request API. And the model for this API is that the extension is able to intercept network requests directly. And this gave extensions a lot of flexibility, also in terms of how and when the different filter lists could be updated. On the other hand, web request does have some drawbacks, particularly because the extension needs access to a lot of personal information from the user. And also there are some concerns, some aspects of the performance that could be improved. The interesting feature for us here is that with web request, it was possible for the extensions to fix a problem that happens when a rule is found to be harmful, found to be misbehaving after it has been distributed to users. This is something that happens from time to time. This is a good example. It happens to Google Docs. There was an error in EasyList that broke Google Docs last year. And within 24 hours, the extension developers, the blocker developers, or Adblocking developers, were able to be notified of the problem, identify the cause, fix it in upstream, and then provide solutions for the users, because either the users could wait for the filter list to be updated automatically, or they can also even trigger a manual update. And so it happened very quickly. It was a pretty visible problem, and there are some headlines like, blockers are causing issues, disable your blocker, et cetera, because of course it directly impacts the way a lot of people work nowadays. I brought that up a couple of tweets just to show also the difference in time. There's a few hours between both of them, between the developers identifying the issue and working on it, and then being able to provide a solution for the users. So this quick turnaround, this ability to respond to one of these problems fast is very important to maintain. The problem that we find in Manifest v3 and the move to declarative net request is that in declarative net request, the extension does not intercept directly the network requests. Rather, it provides a list of rules to the browser, and then it's up to the browser to evaluate and modify the network requests on behalf of the extension. There are most of the rules belong to the static rule sets that are bundled with the extension, and there's a certain number of additional dynamic rules that can be added and removed one by one. This is just in case you are not familiar with the details of the API, but basically the update enable rule sets is the method that you use to enable and disable some of these filter lists, rule sets that have been bundled with the extension. And it is also possible to update, to enable and disable individual rules dynamically. Although in this case, there's a limit to how many dynamic rules you can have that is much lower than the number of static rules that you can include with the extension. And the specific issue that we are working on is that fixing problems in these static lists will become harder than it used to be with a declarative net request. Because there are some workarounds, but they all have some drawbacks. Because these static filter lists can only be updated when the whole extension is updated. If there is a problem in a filter list, your choices are basically to either disable the whole list or wait for the extension to be updated, which can take some time. No? And it is possible to try to fix a misbehaving rule, static rule, by adding a dynamic one, but this can also cause some side effects, and we can look into that in more detail. So the tricky part of adding a new rule dynamically is that both the old broken rule and the new rule will be active at the same time. So usually a rule is broken when it blocks too much, and then the inverse of that rule will have the opposite problem and allow too much. These are some examples, real examples of rules that eventually made it into EasyList and then were quickly fixed, quickly removed because they were problematic. So this first one is a typo. This word media was intended as a comment, but it actually was entered in the list as a rule that blocks everything that has media in its URL, which means that it breaks the internet, basically. But on the other hand, if you want to undo a problem like this, if you want to undo a rule like this, you have to add the opposite, and add a rule that allows everything that has media on its internet, which means it could be allowing things that shouldn't be allowed. The second one was a rule that was intended to be a rule. It's not a typo, and it actually worked well at disabling, at blocking some content that should be blocked, content that has the add CSS path in its URL. The problem is that it also blocked some legitimate content that should not be blocked. And again, we have if you want to fix this with a dynamic rule, then you have the same issue of allowing things that were before being correctly blocked. And the third rule is interesting because it blocks content from a particular domain. But if you look into that domain, it turns out to be a CDN, a content delivery network that hosts loads of things from loads of different people. So we cannot know ahead of time if something that is hosted there will be desirable, will be harmful, should be blocked, should be not blocked. So again, if we have a rule that blocks everything, then the inverse would allow everything, and that's also not something that we necessarily want. Usually, the real fix, the fix that is done in the upstream list is to remove the broken rule and maybe introduce a new one, introduce a fixed one, maybe a more specific one that does exactly what we want. And from our point of view, to fix this kind of problems, it would be much easier to be able to simply disable problematic static rules one by one. So basically, our proposal is to provide a way for extensions to disable individual static rules in declarative net request. And this would allow developers to react quickly to rules that have undesirable behavior without losing functionality or risking unwanted side effects, and also without significantly affecting performance or security. So when it comes to designing the API and the implementation, we need to take into account the rate at which we expect that ad blockers will want to disable static rules. So how many rules would this affect? And could this be maybe misused? Could it be abused somehow? We have to look at this. So on the one hand, we have the use case that I just talked about, where this functionality will be used for situations that are similar to the issue with Google Docs that I explained earlier, where there's a rule or a few rules that need to be disabled because they are found to be harmful. But on the other hand, thinking about realistic use of this functionality, we have to ask, what is the maximum plausible, reasonable, likely rate at which ad blockers might want to use this functionality? And from our point of view, our starting point is that ad blockers might try to match the rate at which rules are disabled in the upstream version of the filter lists. So if you're including EasyList in your extension, we expect that you would be disabling rules there more or less at the rate at which they are disabled in the upstream EasyList, which in that particular case means roughly removing a few hundred rules per week. So this is a very, very rough estimation, but basically we, for a typical collection of filter lists, we estimate that about 1,000, maybe 2,000 rules can be removed every couple of weeks. So this is not to say that this is how people would use this functionality, but it's just to say that this is something that our implementation in our API and our performance should contemplate. That we should take care that this use case is correctly served. So after several iterations and experiments, this is our current API proposal. First, we propose a method, update static rules, that is able to disable and enable individual rules within one static rule set. Changes to the rules take effect immediately, or if the rule set was disabled, then the next time that the rule set is enabled, those rules will not be enabled with the rest of the rule set. These changes are persistent until the extension as a whole is updated, which is also when the static rule sets will be updated as well. Basically, our goal with this API is to prevent a rule from accidentally becoming enabled when it shouldn't be. And finally, because in declarative net request, there is a global count, a global maximum number of static rules that can be active at the same time, a disabled rule should not count towards this global maximum. This is the ideal definition of the method, which is also mentioned in the more detailed API proposal document. And this is the second method that we are proposing, which is simply a method called getDisabledRules that returns the list of rules that are disabled within a particular rule set. Basically, so the developer can have a view of what is the current state of the extension. So talking about the implementation of this API, in Chrome, the implementation of declarative net request does a number of steps. First, it parses the JSON lists of rules that have been provided by the extension. It indexes these rules and then stores them in the disk in a format that is called flat buffer. And the flat buffer format stores the rules along with an index. So indexing the rules in this way provides for efficient matching when we are checking if a particular request matches any of the rules, and also allows data to be loaded from disk to memory very efficiently. The main drawback of the flat buffer format in general, or in this case, is that the process of turning a JSON list of rules into an index flat buffer file takes quite a bit of time. And most of the time, also, updating a flat buffer file is not possible without recreating it, recompiling it completely. It is possible to update small fields that have a fixed size, for example, but not to add and remove entries. And besides, there is some interesting value if we are able to keep the compiled filter lists from changing. For example, if the compiled rule sets are predictable, then maybe we can check if they have been modified. We can check if they match the expected value. The extension can provide a checksum, et cetera, et cetera. So basically, taking all of this into account, we have tried different approaches to the implementation. The first one was a very simple one, which is that when you disable rules, we recompile the flat buffer, but removing those that have been disabled, which worked well at runtime, but was actually very inefficient way of enabling and disabling rules. Another one that we tried is to add, as I mentioned, a flag to the flat buffer file, so we can indicate if a particular rule is disabled or not. And this worked, but it's actually quite complex to implement and to maintain, and also might not be usable by other browsers, which have their own way of implementing declarative net request. Finally, this is our current approach to the implementation. First of all, we keep the compiled flat buffer files immutable without changes. And we store the list of disabled rules for each rule set separately from the compiled file. Right now in our implementation, we are storing the disabled rules in a small JSON file for each rule set. But we are still talking about this with the Chrome team, and we might change that and store the list of disabled rules in the general preferences of the browser. When a rule set is loaded, we also load the list of disabled rules for that set. And then the matching algorithm, the one that checks every incoming network request to see if it matches any active rule, holds both the list of rules and the list of which ones among them are disabled. And it checks the active rules, and if a match is found, then the algorithm will check if the matching rule has been disabled before it returns a result. And this actually has pretty decent performance. We have been doing some initial benchmarks, looking in particular at 3 areas: at the performance of disabling rules, of loading rule sets that are partially disabled, and of running the matching algorithm for a given request. I want to stress that these are preliminary benchmarks for our current implementation. It's basically a way to see that this approach is feasible. This is a good idea. But as I said, the implementation details will still probably change. In these benchmarks, I have been using only one rule set with 20,000 rules. In each case, I am disabling up to 2,000 rules, like that's 10% of the rule set. And the measurements were taken in my development machine, so things should look for the trend more than the specific number. So the first benchmark is for the time that it takes to disable static rules. In this first case, we are disabling the rules in bulk. We are disabling a bunch of rules all in one go. First 100, then 200, then 300. And the time that it takes to complete this operation grows slowly with the number of disabled rules. But in a realistic scenario, we would not be disabling rules in these huge chunks. We will be probably disabling them incrementally as they become problematic or as they are removed from upstream. So in this other benchmark, I am disabling the rules 100 at a time. And you can see that the rate at which the performance becomes a little bit slower is it's much more gentle. The increase in time when you are updating the rules incrementally actually means a pretty small difference in terms of time, which is, as I mentioned, the more realistic scenario. The next benchmark, sorry, is the time that it takes to load a rule set that is partially disabled, that has some disabled rules. As we can see in the graph, while there is an increase in time as more and more rules are disabled, the value in absolute terms remains small, the increase in the actual time that it takes to complete the operation. In this case, there's a difference of about 4 milliseconds between no disabled rules and 10% of the rules are disabled, which is not a huge increase. And finally, we have several benchmarks for the time that it takes to find a matching rule for a given network request. Interestingly, it turns out that the main factor influencing this metric is whether the request is matched by a rule or not, and in the case where it's matched, whether the rule is located at the beginning of the filter list of the rule set or towards the end. And the reason is that these are all factors that determine the amount of work that the matching algorithm will have to do. They will determine the number of rules that will need to be tested. So this is the baseline performance when the matching rule is the very first one to be checked. And as you can see, this metric is not really affected by the number of disabled rules. The trend remains flat. Whereas this is the metric when the matching rule is the very last one in the list, the very last one to be checked. And first, you see, obviously, that it's significantly slower than when the match is at the beginning of the set, but also that there's actually, as you disable more and more rules, a trend downwards, because the matching algorithm has to do less work, because there are fewer rules that need to be checked. This is pretty much the same result that we get when a network request is not matched by any rule in the set. This means that all of the rules have been evaluated and none of them has been found to match this request. And again, the values are pretty similar to the ones in the previous case, and we also see this gentle slope downward as you disable more rules and you have less work for the matching algorithm to do. So we can put the last three graphs together and highlight trends. And here what we can see is that as the number of disabled rules increases, the performance of the fastest scenario remains roughly the same, and the performance of the slowest scenario is in a slow trend downwards. So the conclusion is that disabling more rules does not harm performance. As conclusion of these benchmarks, it seems that our implementation adds a small performance penalty for disabling large amount of rules and for loading a partially disabled set, but this is not a big penalty by any means. And it does not seem that disabling rules has a significant impact in the performance of the matching algorithm. So as I said, this is still an initial approach, but it looks like we are on the right path. The details of the implementation might still change because we are still working with the Chrome team to refine it and to get it ready for inclusion. At the moment, all of this is still at the proposal stage. We are talking with the engineers of the Cronin team about our API proposal and implementation. We are also updating the web extension working group so we can gather feedback from other browsers and extension developers. And if you want to participate in this work, the issue listed there at the web extensions working group is probably the best place to get a broad view of the current state of this proposal and the best place to gather feedback from all sorts of different people in the community. Finally, I wanted to have some conclusions about the general experience doing this work. First, from my point of view, Manifest v3 does introduce some interesting innovations, and there is room to adapt it to new contexts and new use cases. But at the same time, it is true that the process for specifying web extension APIs is not as well developed as is the case with more mature web standards. Nevertheless, I think people in the summit and people in the community should be aware that there are forums where they can contribute in the open to the evolution of this platform. In this case, probably the best place to start is the Web Extensions Working Group, where people from different web browsers and from extension makers get together to discuss additions and changes to the extensions platform, because it is a good place to discuss possible new functionality and to also check how it would interact with the needs and the implementation details of the different browsers and the use cases of other extensions. Finally, because I think I am a bit over time, I just wanted to thank a few people. First, I wanted to thank eyeo for organizing this summit, for sponsoring this work, and for helping us in getting a good understanding of this very challenging field. Thanks as well to the Web Extensions Working Group, which has been a great place to gather feedback and evolve this proposal. Thanks also to the Chrome team who have been reviewing our work, specs, and code. Thank you to my colleague Byung-Woo, who has been doing a lot of work on the implementation and helping me evolve and mature all these ideas. Finally, thank you to all of you for attending. Thank you very much.
And thank you too, Felipe, for this great presentation. Since I'm not a dev, I have not become an expert quite yet, but I know more about static filter rules than I knew before, that's for sure. All right, just a reminder about the Q&A setup here with the remote speaker. We're very sorry that we cannot kind of take them ad hoc with him answering on the spot, but as mentioned, I would like to encourage everyone to make use of the Slack chat. You can also use Hopin if you want, but it seems to be a little less reliable, so Slack might be your better option. If you don't have the Slack link at your convenience or ready, you can also get in contact with Noor under the following email address, contact@filteringdevsummit.com, and she will quickly send you the link if needed. And that brings us to our last slot before the lunch break. And I'm very happy to be announcing Hieu Van Lee, who's a PhD candidate at the University of California in Leeuwen. Hieu received his Bachelor of Science degree in Computer Science and Engineering at the UC Irvine. And in 2018, he joined Athena Makropoulos' research group as a PhD student in computer engineering. And his research interests include studying the ads and their tracking ecosystems within web, smart TVs, and the virtual reality space. And that said, Hieu, please come to me and share your wisdom. Thank you. Big hand for Hieu.
Hello, everyone. Welcome to my talk on automated filter rule generation for ad blocking, or AutoFR for short. This is joint work with my advisor, Athena Markopoulou, and our collaborators, Sam Amalaki and Zubair Shafiq. So what makes filter rule generation challenging? Well, the first challenge is really learning the correct rule granularity, because this can affect, obviously, the potential breakage that the rule can cause, and the lifetime of filter rule as well, whether it's easily evaded or not. And it can also affect the number of rules in a filter list. So I'll illustrate this challenge by focusing on URL-based rules. For example, we can have ESLD rules here, or we can have more specific rules like FQDNs, or ones with paths that can target particular JavaScript resources. Now, of course, each one of these rules have their pros and cons. For example, for ESLD rules, they can be harder to evade, of course. And of course, that also means fewer rules to maintain because of their granularity. But for the cons, they have a much higher potential for breakage because they can overblock. Now, on the other extreme, for rules with paths, they have a less potential for breakage, right? Because they're targeting a very specific resource to block. But in terms of cons, they're very easily evaded. So an adversary can just change the path and then to evade that rule. And it can also cause more rules to maintain for filterless authors if we only rely on these type of rules. Now, of course, for FQDN rules, we can just consider them the middle ground that inherits the pros and cons of their neighbors. Now, of course, ESLD rules are preferred because of their pros, especially if they do not cause breakage. But if they do, then we can go more fine-grained to FQDNs and with paths. So of course, we can see that rule granularity matters because of the trade-off between the effectiveness of the rule and breakage. So for the second challenge, we find that creating rules have high human effort, right? Because it has to scale to perhaps thousands or even millions of sites for filterless authors across the web and over time. And I'll illustrate this challenge by looking at the filterless author workflow. For example, given a filterless author and a site that she needs to create rules for to block ads, in this particular setting, we're going to consider that the filterless author has no prior knowledge or no existing rules that is effective for this particular site. So she has to do it from scratch. So in order to do so, what she's going to do is look at the list of possible outgoing network requests and then choose one to block based on perhaps her domain knowledge as a filterless author or keywords like ads or bidding. And then once she blocks it, she's going to have to test the effectiveness through visual inspection. So what does this mean? First, she can look at how the site behaves naturally. Where are the ads being loaded? Where are the legitimate content for the page, like images and text? So we call this the base representation of the site. Once a request is blocked, she can look at, are the ads being blocked? Are any missing content being blocked as well? And of course, the goal of blocking the request is to see if it can block all ads with minimal or no breakage at all. We call this the operating point. Now, once she finds that a particular request is effective, she's going to have to figure out, okay, well, at what granularity level am I going to create the rules for? And so, like I said, there's different granularities like ESLDs, FQDNs, and she's going to have to test one again, probably the ESLD one, like it's preferred. And she'll use that filter rule to test, and then, of course, do the visual inspection again. So this iterative approach, she's going to have to do it over and over until it converges to a set of rules that are effective at blocking all ads for this particular site, then output them and deploy them to end users. And the third challenge, and it's implicitly implied that, of course, these rules have to be effective. And here we just focus on rules that block ads. And these two challenges are exactly what AutoFR tries to address in our work. And next, I'm going to explain how we formulate this problem of filter rule generation as a reinforcement learning problem. And this basically allows us to convert this human process of creating rules to an automated process. So first, what we found is that we're going to formulate the problem as a multi-armed bandit problem for two reasons. First, we consider filter rules as the effect on the site as independent. So for example, rule A will block one ad, and rule B can block two other ads. And if you use them together, they'll block at most 3 ads. And the other factor we have to consider are site dynamics. So this means that every time a user visits the site, different ads can be served, different content can be served to the user. So testing a particular filter rule once is not enough. You have to test it multiple times to make sure that they are effective across different visits. So next, I'm going to explain formulation using standard terminology for reinforcement learning. So now the filterless author is replaced with what we call an agent, who's a smart entity that is tasked with learning the best rules for the site. And the agent's goal is to actually maximize its cumulative reward over time by just testing rules out and getting reward back. And it has to maximize the reward over a particular time period. And so the agent cannot just simply randomly select rules to test. They have to be smart about it. So in order to do so, the agent is going to follow what we call a policy. And this policy will help at each time step tell the agent, okay, select this particular rule to test. And it's going to help basically balance the exploitation of certain good rules that we know will get high reward, and also exploring rules that we are uncertain about but may have high reward. And our filter rules here, we will now call them actions. And our action space is basically the list of possible filter rules to consider. And in order to automatically derive these rules, we're just going to simply take our list of outgoing network requests and then automatically generate the rules based on granular levels. And our action space will have a hierarchy structure as well. So if we focus on a particular node here, we can see, for example, doubleclick.net is in ESLD form. And it has edges to the right for FQDNs. And this has a more finer grained relationship. And the intuition here is that we want to try the coarser grain first, right? Because it's more preferred. But if it causes too much breakage, then we can try more specific rules. Now, the vertical edges here denote a initiator relationship. So, for example, doubleclick.net is going to initiate other requests to clmbtech.com. Then the intuition is that we want to block the top of the chain, because maybe the whole chain is ad related. Now, of course, if that's not effective or there is too much breakage, then we'll try its children. So this hierarchical structure basically reduces the number of actions that the agent needs to explore. And so the agent's going to apply a rule in what we call the environment. And this environment encompasses the browser and the inputs from the user, like what site to test. And now the environment's going to give back basically a reward. This replaces the visual inspection. And this reward is going to measure the effectiveness of blocking ads, of the filter rule. So how do we do this in an automated fashion? So what we do is we now represent the site as 3 basic visual counters. For example, the counters of ads, the counters of images, and the counters of text. And we can do this automatically by using components, existing components like, for example, ad highlighter that looks at, that annotates basic ads that has ad transparency logos. For images and text, we can write our custom JavaScript. For example, looking at the size of the image, width and height, and opacity to see whether it's visual shown to the user. And for text, we can look at whether the text it's a text node type. And all right, so we're going to repeat what the filter list authored before. We're going to know the base representation of the site, right, without any action applied. What are the counters that we expect? And then we can compare them when the action is applied. So when you apply doubleclick.net, what happens to these 3 counters? Here we can see that the ads went down to 0, so that's good. And then we can also compare the numbers of images and text. And this can change because of maybe site dynamics or because of the rule. So I'll defer more details of how the actual reward is in the paper. But important to note here is that the reward considers how much ads were blocked and how much legitimate content is missing to measure breakage. And we also allow a user to tune a particular knob, and we call this threshold W. So it basically denotes how much the user cares about avoiding breakage. So it's from 0 to 1. So for example, if a filter list author can pass to AutoFR 1 for W, which denotes that, okay, we want to avoid breakage at all costs. Now, of course, a user, maybe a power user, it's okay to break the page a little bit in terms of, okay, I'd rather have, ads blocked. So here we'll revisit these challenges and how this formulation has addressed them. For example, the threshold W allows us to control the amount of acceptable breakage. The hierarchical action space allows us to learn the right granularity of rules with acceptable breakage as well. So, if ESOD is good, then we should stick with it. If it's not, we'll go more finer grain. Our formulation using reinforcement learning allows us to completely automate the human process of filter rule generation. And our reward function ensures that the agent learns rules that are effective at blocking ads. So next, I'll explain how we go from this particular framework to implementing it as a practical tool. And I'm going to focus only on one major bottleneck here, is that every time you test the rule, you have to go visit the site. And of course, this is dependent on the site, but it can take up to like 45 seconds to a minute to wait for it to load, to see if ads are going to be served. And this is actually a big problem when using reinforcement learning for real-world applications. So basically, the agent has to test hundreds, even thousands of times. And we predicted this would take hours per site. So in order to resolve this particular bottleneck, I'm going to present this concept of a site snapshot. It's basically a graph representation of how the site is loaded. And it connects, how the structure of the DOM to network requests and JavaScript as well. And here, given example 1, it's a simple site with a div and 2 images, and each image is initiating its own request to grab that resource. But in its raw format, we kind of don't know which image we should care about. So what we can do is, like I said before, we can write custom JavaScript to annotate this graph, like this, to show that the one with the blue background is visible to the user. So we care about that image. The one that's grayed out is invisible to the user. So if we apply a particular rule here on the graph, and it blocks this URL, then we know that, okay, it's bad because it's blocking legitimate content. Now, if we block the other URL, well, we're not going to care about it. For example, number 2 here is the same. We first need to annotate this graph. For example, with this iframe, we don't really know whether it's an ad or not. So we can use add highlighter, for example, to annotate it and say, OK, this iframe is an ad. And we can use our custom JavaScript to annotate the image. So the blue image is also visible to the user. So now when we apply the rule, if a rule blocks JavaScript B here, we're going to know that, OK, that's good. It blocks the ad. But if the rule blocks JavaScript A, we know that it's going to have mixed effects. It's going to block both legitimate content and ads. So here, what we've done is we're going to replace the browser now with a set of site snapshots. And what we're going to do is collect 10 site snapshots, so we visit the site for real, to capture the site dynamics. And these are locally saved files in terms of graph.ml files. And so for each action where we apply the rule, we are going to randomly select from the set of 10, and then basically read in memory and select it, and then apply the rule in a post-processing manner. And so what we've effectively done is reduce the required number of visits to the site from hundreds to thousands down to a fixed number, like 10. Oh, and I'll show it. Play the demo, please. Oh, here, I'll show it in terms of a Python script. I'm going to pass in crickbiz.com, and then the set of site snapshots that I already collected. And then we're going to play it here. So what we see that it's going to go through the reinforcement learning portion of the algorithm to output rules. So we can see here that it outputted a filter list with 3 rules. And this is only per site, so it's only for crickbuzz.com. We're now, OK, the experiment took about 4 seconds, and the initialization time took 3 seconds, so about 7 seconds overall. We're now going to use this verbose logging to show reinforcement learning iteration. So here we selected a particular action to test out. So we're going to block this particular JavaScript. And we're going to randomly select a site snapshot. So here I print out the name of the site snapshot from the possible 10. And we see that we get the 3 counters again. So images, ads, and text. And we can see the ads are 0. But the reward, and we have to make sure that the rule actually triggered, of course, because that matters. And then the reward here is 0. So basically, for this particular example, the rule was able to block ads, but it caused breakage that we didn't want, so the reward was 0. And so next, I'll present our evaluation of AutoFR. So in terms of efficiency, like I said, when we visit the site for real, we predicted it would take about 13 hours. This is an estimated number. If we compare it to using site snapshots, there's a huge improvement, down to 1.6 minutes per site to collect and use the site snapshots. And this is a real number of when applied, the average number applied to the top 5K sites. In terms of performance, we apply both AutoFR and EaseList on the top 5K sites. And we find that they have a comparable performance here. Next, we also repeat the same experiment 6 months later. And we find that around 6% of sites needed their rules to be updated. And we envision filter list authors or ad blockers companies can just simply use AutoFR to update the rules for these particular sites. We also compare the rule granularity. So in terms of the rules that were created by AutoFR, and compare that to EaseList, the rules that were triggered by EaseList on the top 5K. And we can see that the distribution of rule granularity is similar to EaseList. ESLD is the most common that triggered, and FQDNs and width paths are less common. So here, in summary, AutoFR can fully automate the filter rule generation as a framework. It focuses right now on URL-based rules per site that can block ads. Right now, it only considers visual breakage. And we can implement the framework as a practical tool using site snapshots. And the performance is comparable to EaseList in the wild. Thank you.
Thank you, Hieu. So we have a bit time left for questions, if you want to. So let's see. Oh, there we go. Anton goes first.
All right. Can you say more about how you evaluated the performance versus EaseList?
Yeah. So there's actually lots of details. In order to make EaseList more comparable with what AutoFR is doing, because we're only focusing on those 3 rules, basically what I did was I stripped out all non-URL-based rules. So I just kept everything for network blocking rules, and then apply them on the top 5K. That's about it. I evaluated in terms of AutoFR can actually, we can use it to evaluate the performance as well, because it can get that reward back. In the paper, I also do a manual verification of the results, and it was similar as well.
Okay, thank you.
Right next to you.
I'd also like to ask about the performance, how you compared it. Have you compared the actual number of rules that were generated by AutoFR and how many rules EaseList had for the same website? So were there any things that AutoFR missed?
Yeah, that's a good question. We will actually be updating the paper for version 2 very soon. So in that version, I do compare the rules that were generated versus EaseList that was triggered. We find that there are a lot of differences, but we don't see them as missed. This is because, EaseList is created through a human process, right? In terms of what AutoFR is doing, the algorithm only will output rules that can actually block some ads on all the 10 site snapshots. So it's a very conservative approach. For example, if a rule only blocked ads on one of them, we consider that not very good in terms of being robust against site dynamics. That's one of the reasons that's on top of my head right now. But yes, I can give you more examples later, but there are definitely differences.
I think there was a question over there earlier.
So it looks like a critical part of this system is the ad annotator, and it seems like if it's working correctly and it's able to tag ads on our website, it's almost like doing half of the job. And it might just, why would the user not use the ad annotator to annotate the ads and hide them through element hiding?
Yeah, that's a great question. So first, AutoFR can be a framework, so it's actually agnostic of any of the components. So you can kind of interchange them with any other component, right? Second, yes, ML-based rules, or ML-based approaches, or other, or using heuristics as well, they simply, they're not comparable to filter rules, right? Whereas this particular purpose of AutoFR is to help generate filter rules. So what we found is that most of these approaches will, when you just simply generate what they target as blocking, then it's going to be mostly rules with paths. And so what of course, that has its cons as well, like what I've shown in the beginning of the presentation. I hope that answers your question.
Looks like a follow-up question.
Yeah.
That does answer my question to a degree. So maybe a different question instead. So are you also considering cosmetic filters or element hiding filters?
Yeah, that's definitely what's planned for future work. I think we can expand the action space to consider element hiding rules or even JavaScript-based rules, right? I think the initiatory chain has what script, what script is executed, which method is executed, and that can be connected to perhaps the element on the page. And also other cosmetic rules. Yeah, so I do think it's extendable.
Maciej, you may want to do this.
Hi. Have you considered adapting AutoFR for detecting trackers? So you could repeat the same kind of process, but reward it when there are no changes to. So you can block the different requests, and if there's nothing changed on the site, that would be a rewarded rather.
Yes, we'd definitely consider that. That's going to be follow-up work, so look out for that. There's, I think, several approaches that we can do with this. We can just integrate existing ML models that are that can target tracking requests, and then use the algorithm to create rules for them. Oh yeah, one other thing I forgot to mention is that a lot of the other works as well, they don't test the rule after they target it, basically. AutoFR actually tests the rules multiple times to ensure that it's within an acceptable breakage. So that's also very important.
Thanks.
Did you look at all at breakage across domains? It seems to me that as a filter list developer, oftentimes something would work fine on the site that you're on, and then you don't realize that it broke Google Docs, for instance. So.
Yes, absolutely. Thank you for the question. So what we did in the paper, well, in the beginning, what I presented is that I think this is a very core problem to filter rule generation in terms of creating rules from scratch. In the paper at the end, we also tried to figure out an approach to go from per-site rules to global, what we call global rules. And yes, of course, global rules have the potential to break, or what we call collateral damage, right? It can break sites or unseen sites even. So what we did was we used a simple heuristics such as the popularity of rules. So for example, if AutoFR created the same rule for 3 or more sites, then we convert that into a global rule. In the paper, we create 10 filter lists based on different popularities, like 1, 2, 3, 4, 5. And then we test 2 of them. We test the base one where we're like, okay, let's just take all the per site rules and put them in a filter list, act as global rules, apply it on the top 5K to 10K sites. So those are unknown to AutoFR. We do the same for the popularity that is of 3. So the rule becomes a global rule if 3 sites created that particular rule as well. And we found that I think we achieved 80% compared to EasyList stayed at 87% actually, right? So it's still not bad, but what we found, I think it's a much more challenging problem, and we're actually also trying to do this in future work, so there's lots of different pathways for future work for AutoFR.
All right. I saw that there was one more question, but I will need to ask you to use the opportunity at the networking and lunch to ask it in person, okay? Because we would like to, nobody wants to have more talk when lunch is waiting, right? And I don't know about you, but my stomach is starting to growl, so lunch would come in handy, and this is exactly what we're going to do. We will meet here again in 60 minutes and resume the presentations at 2:30, and please be on time, you don't want to miss it. We will have Chrome updates for you ready. We are also going to hear about how Facebook does with its political ad enforcement, and we'll also have more news from the academic perspectives. So you don't want to miss out. Bon appetit, and see you later.
Hey, ja.
Dus, ja, catchbook. Zit hier nou? Zo, hallo. Oké. Ja, wat zou ik eens vertellen? Ik ga even de NOS-app zoeken. En dan ga ik eens even wat vertellen. NOS-app. Ik hou hem expres niet te dichtbij, dat snap je natuurlijk. Dus. Even kijken hoor. Wat we te vertellen kunnen hebben. Allemaal irritant nieuws. Dat ga ik allemaal niet vertellen. Nou, ze is ook wel op tijd. Ze zijn eindelijk begonnen met het herstel van de kademuren in Valkenburg. Dat duurt een half jaar. Best lang. Het is al hartstikke lang geleden dat die waterramp daar gebeurd is. Maar goed. Er gaat een weg dicht in Friesland vanwege overstekende slangen. Ook wel interessant. Dus, ja, wat hebben we nog meer te vertellen? Even kijken hoor. De VS en Zuid-Korea lanceren raketten in reactie op roekeloze daad van Noord-Korea. Even kijken, voetbal is nooit interessant. Ja, wat hebben we nog meer? Er is eigenlijk niet zoveel interessant nieuws. Gewoon weinig interessant nieuws. Maar goed, wat moet je ermee? Moet ik even op een ander plekje gaan staan ondertussen? Hè? Ja, dat kan. Ik kan hem ook gewoon dichterbij houden. Maar ik dacht, dat doen die mensen ook niet, dus doe ik het ook niet. Ja. Beter hè? Zal ik eens even naar de andere kant lopen? Dat is wel leuk, want ik weet niet of je hier wel eens gestaan hebt. Als je hier staat en je praat, dan heb je een enorme reflectie van Hilde Gunther. Hier zaten net heel veel mensen die wat te zeggen hadden. Op zich gaat het best goed. Ja. Wat zei je? Ja, maar dat maakt niet uit. Het is te verstaan. Ja, gooi die monitor eens even aan. Ik heb hem weer teruggezet op PowerPoint via de Stream Deck. Dus dan weet je dat. Er is gewoon geen interessant nieuws om voor te lezen. Normaal gesproken heb ik wel je nieuws, maar dat is allemaal onzin. Onzin. Staat die monitor al aan? Of nog niet? Ja, stel nou ik zit hier. Gaat het dan ook nog goed? Zelfs dan, hè? Zelfs dan gaat het goed. Nou, ik hoor wel een kleintje hoor ik. Ik hoor een kleintje. Ja, ik hoor een klein rondzingertje. Echt zo'n beginnertje, weet je wel? Dat je denkt van, het is... Ben je al klaar? Oh, bijna. Zet de monitor al aan. Super. Oh, fantastisch. Oh, er zit ook een klein, een beetje laag rondzingertje in. Op een of andere manier. Terwijl er geen laag meer in deze microfoon zit. Toch knap. Dus. Hè?
Yeah. All right, all right, all right. We still have people coming back from the lunch break. I take it as a good sign that the food was tasty, that people are still coming back into the room. Yeah, and as promised, after the lunch break, we are continuing with news from Chrome. And I will just see if there's still a lot of noise downstairs here, but I warned people before the break that they don't want to miss out. So I think everything is being recorded, so who's too late will then have to watch a bit the recording. Anyways, so as promised, here we have the updates from Chrome, and we will have on the stage Simeon Vincent, who is Developer Relations Engineer at Google. We have Devlin Cronin, who's Tech Lead Extensions Platform at Google. David Lee, Product Manager Extensions Platform. Alexandre Blandin, Lead Product Manager Extensions. And last but certainly not least, we have Zach Warnicki, Software Engineer, Chrome Web Store. Gentlemen, we're looking forward to hear what you have to say, and we start with David. Thank you.
Sweet.
And yeah, a big round of applause, please.
Thanks a lot. Okay. All right, let's get started. Oh, wait. Okay, I don't see it here. Okay, welcome. This talk is called Notes from Chrome. And it's called Notes from Chrome because there's a number of different announcements that we wanted to talk about, some that we have recently announced, some features that we have been working on, capabilities that we've been working on, as well as things that are coming out soon, and some things for discussion that we want feedback from you all. So it's an aggregate of a number of different topics. So the few topics that we'll be going through today in order are, one, about the recent Manifest v3 migration timelines, as well as some of the efforts that we have related to those timelines. We're going to talk a little bit about the Web Extensions Community Group, which has been mentioned a couple of times already today. And then we're going to go through some changes in the extensions platform, as well as the Chrome Web Store recently, as well as going into the future. And then we'll wrap up. So to start off, introductions. I'm David, Product Manager, Extensions at Chrome, at Google, and I wanted to talk about the recent announcements that we had made via blog on the Chrome developer blog regarding the Manifest v3 migration timeline. And in general, there's 4 big updates. In reality, it's really 3 updates and 1 little preview of something that we have coming up. And so really quickly, to get started, the first set of changes are the updates to the timeline with respect to Chrome browser. And back in 2021, we had published a post about the Manifest v3 migration timeline that was very clear about what was going to happen in 2022. We had a lot of details about a lot of those changes, and it was a bit fuzzier going outwards into 2023. And now we know a little bit more about how the rollout of this Manifest v2 deprecation is going to take place, and we have additional details to share with everybody because we are committed to transparency, and we have a commitment to being transparent and keeping the community informed of how we're approaching these changes in the next year. And so a couple of the most important changes are with respect to the way that we are going to deprecate. Originally, when we announced a January 2023 date, it felt very much like a hard cutoff time. And we received a lot of apprehension. We felt a lot of apprehension from the community that everything was just going to suddenly stop working in January of 2023. And that's actually not going to be the case. So in actuality, we're taking an experimental approach to deprecation. So something is still happening in January of 2023, but it's not that all Manifest v2 extensions will stop working completely. And by an experimental approach, it means that we wanted to refine the experience for the end users of Chrome. So we wanted to try out a few different things, make sure that it's a smooth experience for them when this transition occurs. And the way that we're going to approach this is that starting in January 2023, the experiments will begin in Chrome 112 plus. So basically, starting in January, thereabouts, we'll start some experiments on a small percentage of Canary users. Likely, we'll test a few things out, have it stay a little bit, see how users react to it, iterate on it, and go from there. And so our commitment is, don't expect that in 112 and in January, everything will suddenly break. It won't, not even for all of Canary. We'll start off with low amounts of people, and we'll move from there. In June, those experiments will expand to stable channel. And so again, small number of users, try it out, iterate, see reaction, and go forward. And then notably, like enterprises that are deploying extensions to their workforce, who are deploying Chrome to their workforce, can opt out of these experiments and can actually opt out of the deprecation and get an extension on those deadlines until January 2024. We also looked at, given those changes to the browser, what would be appropriate changes in the Chrome Web Store itself? And what would make sense given that that functionality shift is happening in the browser? And here's like the same dates that correspond to the ones that you saw on the browser side. In January 2023, as we start experiments in Canary, Manifest v3 becomes a prerequisite for the featured badge, which is one of the badges that we'll talk about later. As Manifest v2 is not guaranteed to work for everybody in Canary. In June of 2023, we are imposing the requirement that all Manifest v2 extensions must be published as either unlisted or private visibility. People can still access it. If it's unlisted, people can still access it via a direct link, but it's not going to be, we're not going to treat it as, promote it as much. It's not going to be as visible in the Chrome Web Store as they might be today. And then finally, in January 2024, that's where it gets a little bit fuzzy, but around that time, when the enterprise policies expire, and enterprises are no longer able to run, nobody is able to run Manifest v2 extensions, then we will remove them from the Chrome Web Store. One additional thing that we had launched and announced alongside this blog post, and I saw some of the issues here referenced in an early talk, I believe from Brave, is a known issues page where we are detailing some of the issues that our community is running into when migrating to Manifest v3, new capabilities that are being requested, and these are the ones that are top priority. These are the ones that we're focusing on. We've noticed that previously there were disparate attempts. It was all tracked via disparate CR bugs, and we wanted a single place where people can look and reference. And finally, for documentation. So this is coming up soon, but we are revamping our getting started documentation for new developers. That's slightly less relevant for the folks here, but for new developers, basically the current tutorial is very much a lengthy tutorial about accomplishing a particular use case over basically several pages, several iterations of an extension, and we're going in a more modular direction. So more compact modular tutorials. But the important part about this is that we're setting the groundwork for new tutorials in the future. So we'll be offering a way for developers to suggest new tutorials, like maybe with new APIs that you're curious about how we best can use these. You'll be able to suggest these, and that means that as we take in feedback, that opens up the possibility of advanced tutorials in the future. And so with that, those are some of the announcements we recently got through. As with all of the things that I've shared, it was a result of listening to feedback from developers, either here or in the broader community. It was a result from looking at issues in the Chromium Extensions Google group, discussions in the Web Extensions community group. So please continue to share with us feedback in those channels. Chat with us today. I wanted to quickly mention that there will also be a Q&A session that we will have tomorrow alongside Firefox. And so please come, ask any questions at that time. And with that, I'll hand it off to Simeon to talk about the Web Extensions Community Group.
Hey everybody, I'm Simeon Vincent. I'm a developer relations engineer on the Chrome team, focused on the Chrome extension platform and Chrome Web Store and everything Chrome and extensions. I wanted to take a few moments today to give you all a brief update and overview of the Web Extensions Community Group. I know a decent number of people here are familiar. I'm going to assume not everyone, though. So first up, the Web Extension Community Group was founded or formally launched in the middle of last year, about, 16 months ago? And this was an effort after ongoing conversations with other browser vendors to come together to explore how browser vendors and other interested parties can work together to advance a common browser extension platform. That's from the announcement itself. But that's really the core idea, is that we realized over the past 5 more years that browsers have been coalescing on a common extension format and approach to exposing extension capabilities to third-party developers. And ultimately, it's a bit challenging for developers to target a common platform that actually isn't common. It's just loosely related. In a lot of respects, this feels to me like the early days of the web, where everybody was independently going in the same direction. And we're trying now to get together and talk about what we do, how we do it, and figure out what a common browser platform, what a common specification might look like. So that's largely what this group is aimed at doing. The group was founded by the 4 companies behind these browsers, Google Chrome, Microsoft Edge, Mozilla Firefox, and Apple Safari. We are each individual rep is a member of either the chairs for the group or the editors. So I'm co-chair with Timothy Hatcher from Apple. And by and large, I'd say we have a pretty democratic process. It is very much, everybody is interested in making as good of an experience as we can. We're not dictatorial, we're pretty open, very engaged in conversation. We don't do moderated queues very much. For the most part, it's an open conversation. The primary places where we do our work right now are on the Web Extensions Community Group GitHub page and on the bi-weekly, what's it called? I want to say GBC, video call, where we all get together and talk about developer concerns. The format for these meetings is pretty loose, but basically, over the course of the period between meetings, developers will open new issues and comment on existing issues. And as issues are added, we add them to the agenda to discuss in the next meeting. Then for the meeting, we will review the new issues that were created. We'll talk about open issues that have had some interesting or relevant updates. We'll follow up on issues we didn't have time to talk about last time, and generally open it up to the floor to give people an opportunity to talk about their concerns and make sure that we're aware of them. For the most part, this has been a pretty organic and dynamic situation that we've kind of settled in. But one of the issues with the way we currently run meetings is it has been invaluable for getting developer feedback and for making sure developers are heard. But we were explicitly created with a charter and a set of deliverables and objectives that we're trying to drive at that we haven't made a whole lot of progress on. So one of the main issues that we discussed at the most recent TPAC, TPAC, for those that aren't familiar, is an acronym that is, it might as well be meaningless. It's essentially the annual event that the W3C runs to have people that work on browsers and in the web ecosystem come together to talk to each other. So it's kind of a great opportunity to have a bunch of serendipitous conversations and drive work that spans multiple groups. In our TPAC session, one of the issues that we heavily focused on was how do we more effectively make progress on our goals, our explicit stated reason for existence, while also ensuring that developers still feel heard and we're able to make progress on some of those issues not expressly chartered, but are still important to the community and ecosystem. So to that end, that conversation, we had a couple of major items that we're planning on covering in the coming months, or trying to make some more progress on. We're tentatively talking about spinning up a separate meeting. So in addition to the existing biweekly meeting, we'll have a spec work-focused meeting that will serve basically as a project sync. So we can all get together and talk about what sections of the specification we're actually trying to work on, how much progress has been made, how we can best unblock each other. Basically the open version of your typical team meeting, which also means it's going to be slower. As part of that work, one of the things that we're going to be doing is trying to gather the IDL files, essentially the way that the individual browsers declare what APIs they expose. Try to gather those all in one location and review and compare them in order to begin to determine what kind of inconsistencies we have across APIs in terms of types that we accept or other potential incompatibilities like that. That then will kind of lead to some reconciliation discussion and opening additional issues and follow-up. But the important thing here is that we're trying to get more systematized in how we approach figuring out what the common platform is that we all implement and actually specify that behavior. And finally, the last item that we kind of discussed and resolved was that we're going to be targeting a set of manifest JSON tests. So a manifest JSON file, as I imagine most of you are aware, is the primary entry point to an extension. And browsers have a decent number of incompatibilities on how they parse and handle values in those fields, especially between MB2 and MB3. So our goal in creating this suite of files is that browsers will be able to parse them and have an expected set of errors that they'll produce for invalid types. And when we start to see incompatibilities, gather that up in some kind of report that we can share with relevant engineering teams and with the broader community to help everybody better understand what works and what doesn't. And with that, I'm going to hand it off to Mr. Devlin Cronin. David Cronin.
Thanks, Simeon. Hey, folks. I'm Devlin. I work on extensions. So I want to talk a little bit about some of the changes that we've been making in the platform, and this is just going to be a small subset of what we've been doing over the course of the last year or so. So this isn't by any means meant to be exhaustive. It's not everything we've done. There's lots more. These are just some of the highlights. So diving in, I blatantly stole David's different format here for here are some key areas. We just, for some reason, love the number 4. It's the number of colors in the Google logo. It works out. So to start off, we're going to talk a little bit about service workers. Service workers, as we heard earlier, are one of the main kind of pain points that people have really been encountering when they've been transitioning to manifest v3. And there's a lot of good reason for that. And we've been working at making them better to work with, more powerful, a better fit for the extensions platform. One of the main things that has been a real struggle has been the lifetime management for service workers. And we've realized that it's a real difficulty when you have some unpredictability, where you don't necessarily know when your service worker is going to be terminated, and when sometimes it can seem like you're still doing work, so why was it shut down? We've been working on how can we give developers more control over that and give them longer lifetimes when it makes sense, but then also while keeping that ephemeral nature of the service worker that is really kind of key to the vision of the platform that we have. So we're working at making that better. We've also been looking at how can we bring new functionality to service workers from the web that exists. Extensions are built on web technologies. They're designed to be the web plus more. They're web with superpowers. But that means that they should be able to use these things that are available on the web today, and they can't always use all of those. That's one of the things that we really want to change in extensions and then also potentially bring to web service workers. And there's some interesting work here where we've added module support in service workers. We've added support for fetching file schemes that didn't exist previously. We're looking at bringing WebUSB and WebHib to service workers. And there's going to be a lot more of that where we try to really make service workers a powerful platform for developers to use. At the same time, we know that the web doesn't solve everything, and there are going to be gaps here. And so we're looking at different ways that we can fill those gaps with that exist with service workers to help developers transition and to help Manifest v3 become this complete platform that can solve all the same things that you could do in Manifest v2. One of the ways that we're doing that, for instance, is with off-screen documents. One of the other areas that we've had a lot of different investment in is in scripting, where we added support for dynamic content scripts, which was something that was one of the key feature requests that's been out there for years. And we added that support in Manifest v3, where you can register and tweak content script registration at runtime. We're also giving you more control, the ability to inject into different JavaScript worlds and specify which ones those are, so that you as developers can say, this is what I want to do, and target the specific context that you have, as well injecting in other schemes that we didn't previously support. And then, as was called out in Anton's talk, we're also working on user script support, and we're hoping to have a little bit more information about how that's going to work coming soon. We've been looking at other APIs as well. We've been adding promise support across our APIs, now over 370 different method support promises. This is really kind of in line with bringing the extensions to the web as the web modernizes. Extensions previously kind of got stuck in the past in a little bit of the way, where the web moved forward and the extensions platform, because it was so distinct from the web, got left behind. And we really want to make sure that as the web gets better, we get to use all those same things that make the web great, that make the web powerful. And so we're working on promise support as one of those instances. We're introducing new APIs and new functionality. One of the main ones here has been in-memory storage, where we recognize that as a pain point. When you have an ephemeral context, how do you have some data that you don't want to write to disk, but you need to have readily accessible? And so we've added that in-memory storage API. And then we've also added support for new favicon handling that doesn't require extra CSP or exposure to other schemes. We're working on giving developers more control over how and when their extensions are embedded in websites to reduce fingerprinting, to give you more ability to say, this is how my extension should run. And again, this is just a small subset of the stuff that we've been working on. And then, of course, I want to call out that we've also been working with external contributors, like the folks at Igalia. And we've added a couple of different APIs in conjunction with them. One of them was for more targeted rule filters in declarative net request, where now you can have initiator and requester domains. And that was contributed by an engineer that I believe previously worked at eyeo and then worked at DuckDuckGo. And then we've been working with, like I say, Igalia on what you heard Felipe talking about earlier on disabling individual static rules. And this, to me, is really exciting because this is really us working in collaboration and us making the platform better as a group. And I want to make sure that we're continuing to do that. So that's a few of the brief updates we have. And with that, I will give it over to Zach to talk about the web store.
Thanks, Devlin.
Oh, and I forgot a slide. I'm so sorry.
There you go.
Never mind. And coming soon. Not done yet. There's one more thing. We also want to give you a preview of some of the things that we're also working on here. One of them is that we've been working on giving extensions access to the side panel UI surface in Chrome, where we know that this is something that extension developers have wanted for a really long time, and we've seen people developing their own versions of this. Chrome now has a native side panel where we're looking at how do we give extensions that access and that integration to make this kind of a first-party citizen of Chrome. And then we're also working on how do we give users more control? As we change the extensions platform and as we see this shifting landscape that we've heard a lot of talks here around privacy and security, how do we give users that transparency into their extensions, and what does that look like? And so those are some of the UI changes that are coming down the line as well. And now I'm actually going to hand it over to Zach.
Thanks. All right. So yeah, I'm Zach. I work on Chrome Web Store. I'm just going to give a highlight of a few features we've worked on or have been working on. So Chrome Web Store, at its core, really is about curation and like giving items or putting items in the hands of users. And as part of that, one of our main focuses has been on reducing complexity for end users, both extension users and developers. In particular, reducing information overload that can make it hard for developers to make quick and effective decisions within our store. And one of the first of these changes that we looked at was regarding privacy. So privacy is increasingly more central to our users. And unfortunately, though, privacy practices tend to be long, complex, and hard to parse through. To make this sort of better, we decided to standardize and distill the elements of a privacy practice into a short form that developers can fill out and that we display to users so that users are more easily able to figure out what data we collect, or sorry, what data extensions collect and how they use it. The next thing we looked at was our item listing pages, in particular the top of page metadata, which is the first thing that users typically see for an extension. For this, we took all of the information we had and put it into two simple badges, one focused on the extension and the other focused on the extension author. The featured badge, as we call it, just indicates if an extension adheres to best development practices, respects user privacy, and also has a clear and helpful store listing. The established publisher badge, on the other hand, indicates if the author has met two critical criteria, I'd say. The first is that we verified their identity, and we currently do that by verifying ownership of a domain or URL. And then the second is integrity. Has the developer followed our our policies and had a strong track record of doing so? If the developer meets both of those criteria, then we give all of their extensions the established publisher badge. The next thing we looked at was more on the developer side of things. How can we reduce complexity for developers? So over time, our developer program policies have become more and more complex in an effort to sort of protect our ecosystem and improve the quality bar for our extensions. And this, however, has come at a cost to developers because it's much, much more difficult for well-meaning developers to stay in compliance with our policies. And so to combat that, we created a set of principles that sort of simplify our policies and organize them. The first is be safe. So we want to make sure the store is safe for both end users and developers. So for instance, we may take down extensions which use data improperly or are otherwise risky. Be honest, so we have a responsibility to maintain user trust. So for instance, we may take down extensions which do not clearly indicate what their actual behavior is. And then lastly is be useful. So all extensions really are meant to help Chrome users navigate the web. And they should meet some minimum level of utility. This typically for us just means removing extensions which provide negative experiences, say like clickbait. And then lastly, I wanted to mention some features we're considering specifically on the developer side of things. So one common gripe that we hear a lot from developers is that there's no easy way to roll back a new extension version. Like say you publish a new extension version and you discover later while it's in review that there's some bug. And currently, there's no easy way to get around this because what you'll have to do is go in, resubmit your older extension version, and then hope that the review just doesn't take very long, which in most cases is not really the case. So what we're considering is we're exploring ways that we can allow developers to just straight revert back to a previous version that we trust without going through review, as well as canceling in progress reviews, for instance, if you notice a bug and need to just immediately cancel the review. We're also looking at ways we can decrease review times, in particular fast tracking like low risk changes that don't impact core item functionality, such as declarative net request rule updates, as well as other things. But anyway, we're always looking for feedback, so definitely let us know if any of the features I mentioned here or otherwise are important to you, or you can always just reach out to Simeon later on the extension forums. So with that, I'll give it back to Devlin to close us out.
Okay, we're already over time here, so I'll try and make this as brief as I can. I've been working on extensions for around a decade now, and that's really, really fascinating for me to be able to say that in an industry like ours where I feel like most people kind of transition every couple of years. The thing that's almost more fascinating to me is that as I look around, I'm not alone. I see other people here who have been working on extensions for a decade or more. I'm not the one who's been working on them the longest. I'm not by any means this like weird person who just stuck around. There's something about this platform that really draws people in and really does keep their attention, keeps them interested, keeps them fascinated, and makes lives for users better. When I started working on extensions, they were viewed as this power user feature, this thing that, you know, a few of those folks, those like pseudo developer types, yeah, they're kind of odd, and they might go and install this thing that changes the way your browser works. That's not what extensions are anymore. I don't think that's what extensions were then either, but we definitely know that's not what they are now. Extensions are for everyone. With that shift, we've also had to make a lot of changes in the platform to account for some of that. And that's really, really hard. That's hard for us, but it's harder for the ecosystem. It's harder for developers. So I really just wanted to say thank you all for all of the really hard work that you've been doing. We know that this is challenging. We know that this is a struggle. And we think that this will make it to a better place. But that doesn't come for free. And so thank you so much for helping us keep this ecosystem alive and vibrant, for giving us the feedback in the Chromium Extensions Forum, in the Web Extensions community group. I'm really, really excited to see where this goes in the future, where we can take it. Extensions are so important to the browser. We know that they're loved by users. They're the way that you curate your own browsing experience, that you can make the browser yours. And a browser without extensions isn't the same. So thank you so much for being a part of that, for enabling us to give users a good browsing experience.
Okay. Cool. Alrighty. Thank you, gentlemen of Google. That was very insightful, and it seems there's a lot of... You forgot something, didn't you? I knew I'd see somebody here again. All right. Yeah, this was very interesting, seeing your approach, how you're going to do with the changes in the extension space. And where was I going? Gee, lost my red line here, as we would say in German. Anyways, so we are moving on with the program. Next up, we have Mohamed Morsy, who's actually a dear colleague of mine. He works as product manager in our company. And Mo has found his calling in product. He has been working in various roles over his career. During the last 15 years, he's been working in hardware and integration testing, technical pre-sales, solution architecturing, but has eventually made its way back to product management in 2006. And he joined eyeo 2 years ago. And yeah, comes with a lot of experience working in very large corporations and has also a lot of experience working with intercultural teams. And Mo is now going to actually let us know how feature innovation through partner collaboration can work. Big round of applause.
Thank you, Caro. Thank you, everyone, for being here today and everyone for tuning in online. My name is Mohamed Morsy, and I am a product manager here at eyeo. And today, I would like to share a story about how the partnership we now have with the Avast Secure browser started, and how we both ended up innovating each other's products through the process. But this won't be a tech talk, and it won't be a product talk either. Maybe somewhere in between. Actually, it's more about the series of fortunate incidents in the form of challenges and changes that happened before the call that led to the collaboration taking place. So basically about that little bit of luck or magic that we sometimes need on our side to be in the right video call at the right time. Now let me start by setting the scene up a little for you. So Avast had quite a successful browser, the Avast Secure browser. And their user numbers were going up fast, very fast. And I apologize for the slide. I know it's confusing, but they had a lot of users. And in fact, in just over 5 years, the Avast Secure browser managed to have well over 20 million active and loyal users, which is really fantastic for a desktop browser these days, right? And I say loyal here because their users were really using the browser and all of its features, or most of its features. So Avast had extensions for ad blocking and anti-tracking, which were being used by 98% of their users. So that's really good penetration, right? But of course, success doesn't come without challenges. And so the first challenge that they had was memory consumption. So it was too high memory consumption. And that was mainly due to the browser having both of these features in dedicated and separate extensions, one for ad blocking and one for anti-tracking. The second challenge they had was the tech stack. Although they were using open source software extensions for these features, they still had a pretty convoluted tech stack that was not very transparent. And this made, for example, troubleshooting issues a lot more difficult because it took time to pinpoint bugs, but it also made lead time for innovation and adding new features to these extensions take much longer. So it was slowing down innovation for them. And then finally, topic of the day, there was still a lot of uncertainty around Manifest v3, around the impact it would have, around the limitations that would come with it, and if the solution they were using would support it on time. And you have to remember this was a year ago, so things looked a bit different back then, right? So how did things look on the other side of the table? Well, eyeo also had a very successful B2C product, right? We had our web extensions, which some of you might be familiar with, and we also had a lot of users. And sorry again for the same slide, but you pay the royalty fees once, you may as well reuse what you have. But it still wasn't enough users to make the impact that we really wanted to make on the industry. And we needed more users to really reach that critical mass. And so our strategy became distribution. That meant starting to distribute our technology via browser partners. And anyone probably knows to be able to go to market quickly, you do what I just did a few slides ago, you reuse what you have. So we took our proven tech, which was B2C product, we wrapped it up, packaged it nicely in different ways to support desktop and mobile B2B partners in this case. So that was basically white label extensions and mobile SDKs for Chromium and WebView. But of course, this approach also had its challenges. And the first challenge was performance. And so coming from the desktop kind of domain with our extensions, and now being on mobile, this was something new to us at eyeo. So it was very important for mobile browser partners, and it was an issue that was new to us. And obviously, there was room for improvement. You have to deal with a new kind of hardware, different limitations, and so on. And so optimizations were needed. But since the core technology, the filter engine, powering all of the products at the time was common, to be able to get to market quickly, it was hard to make changes that were specific to a certain platform, like mobile, for example, right? So there was very little room for optimization in the setup. And the product synergy, aka the common core, which helped us get to market quickly, was now actually holding us back. And when there was finally a chance to do something about the performance and optimize something, we didn't have the benchmarking set up to know for sure that whatever optimizations we were doing didn't cause any performance degradation somewhere else. So with all of these challenges at hand, and with Chromium picking up traction both in desktop and mobile, it became clear that it was time for some change. And the first change actually was to take off the wrapping paper and rewrite the Chrome filter engine from scratch, but this time natively for Chromium. That meant doing it in C++, that meant following the Chromium paradigms, and optimizing it just for the Chromium platform. That, of course, required also setting up benchmarking environments to know that we were on the right track. And this is actually a topic that I'm really fond of. I think I had a few conversations earlier about. So if you also struggle with benchmarking or have a great solution for it, please feel free to reach out after this talk, and we can exchange notes. But luckily enough for us, Chromium also brought in some tools that helped us set up our benchmarking setup environment. And now with this new wind of change in the team, we decided to introduce a Slack day, basically, which we called Innovation Day. And this is also another topic that if you have time afterwards to talk about, how do you foster and manage innovation at a small scale within a product team and still remain productive and deliver your commitments? Let's chat afterwards. But anyway, Innovation Day is where the second change idea actually came from. And I actually dug up the pitch slide for this one. So It was kind of a joint idea by Alex, who funnily enough lives in Amsterdam now, and by Maciek, who's with us here today. And the idea basically was to start using the SDK not just for mobile, but for desktop as well. And the rationale back then was because testing and troubleshooting was a lot easier and faster on desktop, so it made sense. And this is what we did. We started using the SDK for desktop, but initially just as a dev tool. So let's recap. On the Avast side, we have over 20 million users on desktop. They had a few challenges, which high memory consumption, long lead times for troubleshooting and innovation, uncertainty about the impact of Manifest v3. And on the I/O side, we started following a distribution strategy. We had a strong focus on optimizing performance. We were now writing a native Chromium SDK, which was no longer focused on mobile, right? So you can already see the points are already starting to align and match up even before we got on the call. And that's what I mean when I say being in the right video call at the right time. Because a year earlier, we wouldn't have had such a perfect fit. So timing, AKA luck, also played a big part in this story. And now we get to the call, or series of calls to be precise. But instead of just summarizing them for you here on stage, Antoinette, who is the product manager at Avast, and we thought it might be more fun if you actually got a chance to watch the call. So that's what we're going to be doing. We're going to be watching it together. And while you're watching, I'd like you to keep an eye out on one thing. What was the key question, do you think, in your opinion, that paved the road for the collaboration to move forward? So let's play the video.
Okay, hi. So we heard you're looking at ad filtering solutions. How can we help?
Yes, we'd like to update our ad filtering extensions that we have in the browser.
Oh, great. Well, we have white labeled extensions that you could just reuse. Would that work?
Do you have a solution for the MV3?
Manifest v3. Well, not yet, but our extension team is working hard on MV3 support for extensions.
Okay. What about the memory consumption? Do you have an idea of how much memory do the I/O extensions use? Because there is a limit on our memory usage on our extension side, and we currently are running 2 of them, and we have an issue around that area.
Yeah, well, I mean, as an extension, we would probably have the same limitations. Why do you need to run 2 extensions, if I may ask?
Because we have 2 different cases. The one is the ad blocker that we have and the anti-track. And each of them, they have their own filtering engine that lives within the extension.
Well, we have an SDK for Chromium that we're currently adapting for desktop. So the filter engine would live as a native feature in the browser, and that wouldn't have the memory limitations that normal extensions have. And then we wouldn't also have to worry about MV3 at all, since it's not an extension. The question is, do you need the UI, the user interface, to look like an extension, or do you need the full feature to live in the extension?
Actually, to just look as an UI.
Ah, okay. Then we can integrate the native SDK in the browser and then implement an API, let's say, for the extension UI to control it. How about something like that?
Well, that actually sounds, yes. Will it still need 2 instances for the SDK, one for each extension, or can we merge?
Actually, no. So since both extensions are using more or less the same functionality, which is a filter engine, it's enough to have a single instance of that native filter engine and then have both of these extensions just make use of it.
Oh, wow. Okay. So that will actually help us a lot with the memory consumption.
Yeah, it would definitely drop memory consumption, I mean, by at least half, but probably more than that, since we're really working on optimizing the SDK.
Okay. What are the next steps? Can we meet with to discuss more about it?
So yes, we did meet up a few more times to discuss more about it, and it was and still is a great partnership and collaboration that we have between both of these product teams. And that's what makes collaborations like this one a real win-win-win solution, as I like to call it. Because not only do both product teams and their respective companies get something out of it, but the user wins as well. Because that's the main driver for this collaboration, but also for most of us here in this room, at the end of the day, to give users a better user experience, right? So what did we get out of it? Well, Avast, they got to have a single extension for both features, which is originally what they were after. So now they have the privacy card extension in their latest browser that does both ad blocking and anti-tracking. They have reduced memory consumption now. They have a manifest v3 safe solution because it's not an extension after all. It's a feature that lives in the browser. They have a leaner and more transparent code base, which makes troubleshooting and innovation easier. On the I/O side, of course, we get to distribute to our technology to more users, helping us kind of on our mission. We are now officially supporting desktop with this native Chromium SDK, which is great for the team as well. We added new SDK features in the SDK, so these extension APIs, for example. And we improved a lot of our other features due to this collaboration. We get feedback continuously from their team, and we help each other improve our products. And most importantly, all of this in a very transparent and pragmatic dialogue between both teams. And that's the real foundation for a good partnership, in my opinion. To be able to get on a call and have both teams agree that not all bugs are critical and not everything is a feature. And so with that, I thank you for your attention and would love to catch up with some of you on some of these topics I touched upon here, especially, like I said, benchmarking. And please reach out to me, and I will see you around. Thank you.
Okay. So, thank you, Mohamed. I think that was a brilliant example of how understanding the problems of partners to their core and having good dialogue and exchange helps finding the right solution. So that was pretty good. Yeah, we again, I think, cruised a bit ahead of our time. And next in the schedule, we actually had another break. So I would invite you for another cup of coffee. And actually, since we have a bit of extra time, I will give you an assignment for the break. So here it comes. Talk to somebody in the audience that you haven't talked to before. I will test this. Okay? So have another nice break and see you in a little bit. We resume here at 3:45. Thank you. Okay, and everybody's coming back. Did everybody manage to do their homework during the break? Yeah? I saw a lot of people looking engaged in conversations, so it seemed like everybody was busy doing what I asked them to. All right, I have a little announcement which I also missed to share earlier. The same as during the last years when we did this event on-site, we will of course also have the opportunity for more extended networking with some drinks and snacks later on. So from 6:40 to 8:30, we will also just stay in this beautiful venue and keep on enjoying ourselves and having good conversations. So stay with us for that. And up next, we have two faces that you might actually recognize from last year, because they have also been presenting there. It's going to be a two-speaker presentation. And we have also lovely colleagues of mine. First, we have Dr. Humera. She's Director of Engineering at eyeo. And then we have Parinitha Herhal, who is AI Product Manager. And we will first have on stage Pari. And Pari is a computer science professional with over 6 years of experience in enterprise data and customer engagement. And she's done her bachelor and master in computer science and is super passionate about machine learning, obviously, since she's an AI product manager with us. And she's super interested in artificial intelligence in general and is all set to explore its range of applications also within our industry and the space of Adblocking. And then Humera also developed her love for data very early on in her professional life and is still amazed by its power. And she actually did her doctorate in computer vision and machine learning and has also over 20 years of experience. And yeah, is leading also teams working with big data in her experience. Yeah, and she's also passionate about making differences in people's life, and that is basically reflected in every product she picks up in our company. And yeah, with that said, I would like to welcome to the stage Pari first. Big round of applause.
For such a warm introduction. Hello, everyone. It is so great to be here. It's just amazing to see you all, and I hope everyone is having a good time, and everyone online are having a good time too. Today, I, along with my amazing colleague, Dr. Humera, we will be talking about ML-powered anti-tracking and machine learning in the privacy space. Even before I start talking anything about this, let me quickly play a video for all of us, and let's check this video. I'm sure if not all of us here, some of us might have felt this way. You know, imagine having cameras all over you, tracking your movements, tracking your gestures, trying to understand where you're heading next, and tracking your whereabouts. That sounds scary, right? So this is what is happening in the web world today, kind of. And these cameras that we are talking about are the trackers. We will talk about trackers in a bit, but these trackers are the ones that are recording all of your movements, your preferences, some of the information about you, and things like that. So the intention of having something like this in the web world was to understand your preferences and to serve you right with a streamlined user experience. But it's gotten into a whole different level today. We cannot help but see some of the downsides that it's causing for all of us today. So much information about us being gathered that it's making bad people out there So easy to mishandle this data. It's helping with snooping, spying, location tracking, you name it. Yeah, so that's not good. If you take a look at it, there's a lot of information that is being collected about us. And most of us don't even know if this is happening. Like, half of us are not even aware that all of this information is being collected about us. And the kind of data that is being collected varies on a spectrum of PII data all the way to pseudo data such as clickstream data. They're collecting your name, IP addresses, email addresses, your anonymous data such as ad views, your Google search history, clickstream data, etc. And that's a lot of high data, and that's a next level data. And all of this data, even before you do something on the web browser, even before you click something, all of this data sometimes even without your consent is sent to different other entities, like ad servers, advertising servers, or market retargeters, etc. And this is something that needs to be addressed. And how is all this happening? It is via web trackers. What are web trackers? So web trackers are basically a piece of code in the form of scripts, snippets. So basically a piece of code which are there on the browser and are served by a particular service. And the main intention of these trackers is to understand your behavior, understand your preferences, and to sort of create user profiling. There's different kind of trackers. The most common ones that we mostly talk about are the cookies. Like, first one we can talk about is session cookies. And these are associated with a given session. The moment you're logged into a website, you're browsing and having some experience, then you're logging out. The data that is being collected by these cookies are pretty much deleted. But next ones are the persistent cookies. These cookies are also cookies which track data, but they might be there on your browser for an indefinite amount of time, just collecting all kinds of data. And there's also different other advanced level trackers like browser fingerprinting, et cetera, et cetera. But just for the sake of this presentation, let's focus on cookies. If you see, these are some of the most common and high sources of trackers, sources of most common trackers found in the top 50K websites on the Alexa list. And some of the main players are Google, Facebook, Amazon, Rubicon Project, etc. So when you start visualizing this, this is how the image looks. For a given web page, you have like thousands and thousands of trackers associated. Now here, one very important thing is we need to understand not all trackers are bad. Like I mentioned, the whole origin of having trackers was to streamline user experience and to understand and serve the users right. And those are what we mostly call the first-party trackers. First-party trackers are the ones that are served by the website that you're browsing. For example, Amazon. I can consider that as a standard example. Let's say you're logging in and trying to browse something on Amazon, and you've been greeted with your name, and you're recommended with products that you have preferences for, et cetera. And that's basically you having a good streamlined experience, which is needed. But the real troublemakers here are these ones, the third-party trackers. And these trackers, they are placed on your websites, and they're not even associated with the website that you're browsing. They are placed by a whole different entities that you're not even aware of. And these trackers might or might not be collecting data that you haven't even consented for. And these also pretty much make experiences a little bit annoying, no offense. Like, for example, let's say you're at a random point of time, you're just Googling for a product, and then you go to a whole different website. This happens. And then you're kind of tired, you want to go to some other source, just find something else, and then this happens. And then you're tired, you just shut down everything, and then sort of this happens. Yeah, third-party cookies sort of follow you everywhere, causing that feeling of annoyance. But what eyeo is doing in this space is, we have a product called Crumbs, and Rotham, our point of contact person, so we have a product called Crumbs, and this is a privacy product. When installed in your browsers, it identifies the trackers from the URL and basically blocks them. So the way it works right now is it uses EasyList and Easy Privacy List to identify the trackers from a coming URL, and it blocks the trackers. So along the similar lines, we wanted to do something with machine learning, and that's where we brought in machine learning. We wanted to also use machine learning in identifying trackers, but another additional thing is we want to ensure that there's a good balance in the internet between user experience and privacy without costing compromise on any other side. So we wanted to use machine learning to not just identify trackers, but to differentiate between first-party trackers and the third-party trackers. And so we started experimenting a few things. And this is basically how our approach looked like. We started with data collection, trying to understand what kind of data can be used, like identifying the right data sources, and then identifying the right features by data processing, and then identifying the right kind of models. We tried NLP models, we tried graph-based, and or some of the out-of-the-shelf models, and then finally benchmark them. So I will now call Humera to take us through some of the details, technical details of these processes, and explain some of the challenges that we came across. And yeah, then I'll see you all in another few minutes. Over to you, Humera. The video.
Thank you very much, buddy. Maybe we can go back a slide and play a video. And we don't see the video?
You don't see
Peter,
yeah.
Come take a look at this.
Look at this.
The numbers, they keep getting bigger and bigger.
The clicks are off the charts.
Yeah.
Yoshi, it's Walter. We're back.
Yes, sir!
I need more trees. More trees? I'll get you more trees. Hey, take a look at wood pulp.
Whoa. Everything you got on wood pulp right now.
He really loves that thing.
Hello, everyone. This is exactly what we mean when we say data is your foundation for decision making. I'm Humera, Dr. Humera, and I'll be taking you through our machine learning solution that we built for anti-tracking. And we'll start with data collection. And when we start with data collection, we'll ask a few questions, very deep questions. Questions like, what data to collect? Because it's important to know what data we want to collect, because if we don't know that, we might be collecting redundant data at best, or even useless data in the worst case. The second thing that we need to know is how are we going to collect that data? Where are we going to find that data? Just like we saw in this video, we don't want our source of data to be the wrong one. And once we have that data, we also need to provide information on how we generate the ground truth. Ground truth is important because if we don't have the right labels, we won't be able to train our machine learning models. So now let's have a look at these three questions in more detail. Starting with the first question, what data should we collect? It's basically about scoping the problem. You need to define the scope. What are we going to focus on in this exact problem? Because there are trackers, yeah. There are first-party trackers, there are third-party trackers. We need to identify both of them, but we do not want to block each one of them. So that's our scope. We are talking about third-party trackers. Now, how do we actually represent those trackers? Cookies is one way of representing those trackers. But then there are other ways. We have HTTP requests. We have pixels out there. So that's our scope. Okay, we want to identify these trackers. But then there are advanced tracking mechanisms as well, like CNAME cloaking or fingerprinting. We decided we are not going to talk about them at this point in time. So that was our scope that we started with. And then we moved on to answering the second question, that what are the data points that we are going to talk about? We have been talking about cookies, and what comes to your mind when you hear the word cookie? For me, it's this. But for a developer who is about to train a machine learning model, it's something else. So it's an alphanumeric combination of elements. It's a string of characters. What else do we need? We need domain information. We need URL request. We need request information. It's a post request. It's an image. It's a script. What kind of information is there? What are the query parameters that are coming up? What's the domain that we are talking about? What's the URL that we are talking about that's creating the request? So we need to know all that. So now that's our scope. This is the data that we are going to talk about. Now that we have this data, which is, as a summary, the request URL and some query parameters, we can move on to answer the second question. How do we get all this data? Which means, how do we generate the ground truth? I think I missed something. No, I didn't. So now that we have the data, we need to generate our ground truth as well. So how do we generate our ground truth? We spoke about easy list and easy privacy. I indeed missed one slide. I'll go back, because the second question was, where do we get this data from? And I still don't see it. I'll skip the slide. I'll talk about how did we get the data. So there are a number of sources which are out there. You know, there are Alexa lists, which you can use to crawl the web, because they give us the popular domain information. Then there is the Tranco list, which is a research-based list. And we decided to go for that research-based list from Tranco so that we can crawl the web and get all these data points that I just showed you. So that was the question number 2, which I just missed in the slides, but it's OK. And the third question was, how do we generate this ground truth? And for that, we used easy list and easy privacy. Now, all of you most probably know what easy list and easy privacy is, and how does that play a very important role in ad detection and tracker detection. And it looks like this. We have easy lists, which have a lot of filters, and these filters are used to identify and block ads. Then we have another list, which is easy privacy. And it has also a lot of filters, which are there for identifying trackers. But what about this overlapping section between easy list and easy privacy? What do we do with them? And what do we do with everything which is outside of both of these lists? So we thought about this, and we said, OK, we will consider everything which is coming from easy privacy as positive examples of trackers. And everything which is only in easy list, we ignore them for the time being. We are not going to use them. And everything outside of these two lists will be our negative examples. And those of you who are a little bit involved in machine learning, you know that we need positive examples and negative examples whenever we are training a model. So this is how we get our positive and negative examples. Now we have our data ready. Now we took a step back and think about what kind of modeling do we use? What kind of models can we use? What kind of approach can we take? So when we took a step back and think about trackers, we realized that trackers are nothing but alphanumeric values. They are words. For example, adfilteringdevsummit.com. It's a URL which is composed of several words. And so are our domains, so are our URLs, so are our tracker names. And these words, they actually indicate that this is actually a natural language processing problem that we are solving. It's an NLP problem that we are solving, which means that in order to detect trackers, we can dive deeper into the NLP solutions that are available out there. Now, These trackers are alphanumeric elements and natural language stuff. But the machine learning model, they need numbers. They are maths majors. So we need to convert the natural language stuff into numbers. And how do we do that? Let's do a quick 101 class on machine learning, and especially natural language processing. One of the terminologies, or one of the concepts that we need here is bag of words. What happens in bag of words is that there is a sentence. You do some normalization, like lowercasing everything, removing all the special characters. You take care of any plurals that are out there, past tense out there, and then you take all the normalized sentence, put them in a bag, remove all the relationship between the words, and take them out. And when you count them, it gives you one kind of indication. That's bag of words. We can take this approach to a little further step. This is, for example, in addition to counting just the occurrences, we can compare them with the total number of words in the document. That's TF-IDF approach. That's a step better. And then we can take it to the next level, and then we have continuous bag of words. Here, instead of taking the full sentence all at once, what we can do is divide them into chunks, which are n-grams, and based on if we are talking about 2 words, that is bigrams, or 3 words, as you see here, which is trigrams or 3 grams, we can actually create something which is called as word embeddings. The cool thing about this is when we use this approach, then if we mask any word, let's say I remove the word jumps from here, then using the context of the sentence, that word can be predicted. So if I give as input a quick brown fox dash over the lazy dog, then the model can actually predict that we are talking about the missing word jumps. And then we need a total opposite of this approach. We sometimes need that jumps is the only word which is there, and we try to predict the whole sentence. So if I give jumps, the model should be able to predict that the rest of the word or the sentence was a quick brown fox over the lazy dog. And this approach is called as skipgram. Now that we have these word embeddings, and now that we have a 101 course on machine learning based on NLP, let's move towards the approach that we used and the model that we used for training. The first one that we used was fast text. Fast text uses exactly this technology that we just studied, just saw, and use them to make models. It's an approach given by Facebook research group, and instead of n-grams, which are based on words, they actually use characters. Now, what you can do is you can take this built-in model and put your data on top of it. So let's say your data has different words and it has different clusters. You put these categories. In our case, that would be positive and negative examples of trackers. You put them on top of your fast text model, and then when you give them some unknown data, some unknown new trackers, it can look at these 2 pieces of information and predict which category it belongs to, tracker or no tracker. Fast text is very cool because it's fast, and it's based on 290 plus languages, so it's very versatile. We got pretty promising results when we used this. But we wanted to take it to the next level, and then we moved to another modeling technique, which was BERT from Google. BERT is bidirectional encoder representations from transformations. No, we are not going to have a 101 on this topic. We can take it up offline. But the good thing about BERT is that it's based on a much more amount of data than fast text. Here, the model that's pre-trained, that's actually based on 2.5 billion words coming from Wikipedia, and 800 million plus words coming from the Google Books corpus. So since the amount of data on which this model is based, that is huge. So the data and the model is then much more robust. It's much more generalizable, but it also takes a lot of time for training. We tried this approach, and we got some nice results. So to evaluate them, what we did was we went just recall, we just saw this slide a few slides ago, that we had some positive examples and negative examples coming from easy privacy and easy list. And easy privacy and nothing from easy list. We then used this easy list information for testing. What we did here is we took all the filters that were there in easy list and actually shoot them on our model. And it gave us the prediction whether this is a tracker or not. We were able to get quite good results. So FastText, for example, was able to give us 80% plus score. And BERT was able to give us even 98% plus performance score. So the initial results, the preliminary results that we have are pretty cool. And we are very happy that we were able to get some good performance. What comes next? For that, I'll hand over to Pari.
Yeah. We did definitely try all of these experiments, and we did have promising results. But that doesn't stop us from doing anything more. We have our immediate next steps defined. We definitely want to diversify our data sets. We want to collect more and more examples and train our models with more and more such data so that there's more and more accuracy with the models. Definitely do performance evaluation, and ideally also want to generate that filter list, which possibly just identifies and blocks the third-party trackers as opposed to first one. So, oops, I need to take this call. Sorry. Hello? Oh. OK. You know what? I just heard from a few people that some of them here are actually tracked based on their online activities. Really? Yeah. Do you know who they are?
Actually, I also got some cues here. Let's see. I need your help, because we need to uncover who is being tracked here. I request all of you to please stand up, so that once we are here, we can then isolate the person who's being tracked. This is really serious, guys. So I also got some cue, and what I'll do now is I'll present these cues one at a time. And if that relates to you, please keep standing. And if you think it's not relating to you, then you can sit down. And for our online audience as well, if you feel it relates to you, then you just mention that it's, you are at risk. Otherwise, when you find out that you are not at risk, you can just say, I'm safe, and take a sigh of relief. So what do we have here? So that person is on site. So at least our online audience is protected. That's a male. OK, so females, you are protected, so you can sit down. And what's next? It's not working for IO, so Ionians can sit down. Maybe we were using crumbs, so we are protected. It's a PhD scholar, so at least the colleagues from industry can sit down. Flew for the summit. So I can shortlist it to one of the two of you. And it's Hieu. And you can sit down at least, thankfully. And you just, OK, it's OK. I got you covered. You're protected. Ladies and gentlemen, did you notice that it took us only 5 data points to track a person, not only online, but in real physical world? That's what privacy violence looks like. That's scary. What do you think, Pari?
Definitely. And I think that's why our ML-powered anti-tracking solution could just be the one out there that can solve these kinds of problems. With that, we are now open for any questions from you.
Thank you very much.
Thank you very much.
Yeah, we're going to do the usual. And there are already hands going up there.
Great.
Great presentation. Thank you so much.
Thank you very much.
Great performance as well. So,
Thanks.
You were talking about 80% performance of the model. Could you please elaborate what does it mean? So what does the testing, how does it look like to test it?
So we were able to use almost 6,000 data points, which were coming from our easy list. Because if you recall, we were using easy privacy data for training, but not the easy list data. And we took that and we shoot them on the model, and the performance that I'm talking about, for the sake of simplicity, I just said performance score, but we mean F1 scores. So we calculated the accuracy and the precisions, and the weighted sum of them was coming out to be 80%. So in 80% of the cases, we were able to correctly identify a tracker as a tracker, an unknown, unseen tracker as a tracker, and an unknown, unseen non-tracker as a non-tracker.
Am I right that you say that EasyList is also trackers, and the target is the goal is to identify the whole EasyList as trackers, right, using the model?
You are right in the first part that there are many trackers available in EasyList as well, which inadvertently got in.
Got it. Thank you.
Thank you.
Just to elaborate, with EasyList, ad companies also track, so you have to make a decision whether you put it as a tracker or as an ad company, and normally an ad company comes first because they're an ad company, you know. That's why, even if they do track, it will go into EasyList because they're technically an ad company and have tracking things. How does it compare with easy privacy overall? Like when you find these, how effective is this? Say if you just ran easy privacy by itself versus the email version of this, is it more effective, or is it just as effective as easy privacy is?
So you mean easy privacy versus EasyList?
Easy privacy. So easy privacy versus the email generated list, I guess.
The one that machine learning model potentially would generate the third-party.
OK, that list. This is something which we still need to evaluate. The initial results are very good. But if I understand the question correctly, you mean to ask that if we use our machine learning model to generate a similar list, how would these two lists compare?
Yeah.
This is something that we still need to evaluate. Right now, a very big problem is for us to generate the ground truth data, which is unknown, unseen, and manually label them. Because our initial results with EasyList, they are pretty good. But to do this evaluation at a large scale, we need to generate more ground truth data so that we can use it for testing. So it's too soon to say how would these two lists compare.
Yeah, it'd be good to see if we missed anything in easy privacy, that something that was picked up by this email generated thing that we could actually implement ourselves automatically. Like, okay, we found a tracker that we didn't pick up ourselves, but it's being picked up by the script, and we can just roll out a patch, for example. That would be really helpful.
That's totally true. Yeah. Because you want to take this up further?
No, go for it, but I can add on the comment later.
OK. You are totally right, because easy privacy has a number of problems in its current form. It's manual generated. It's not professionally handled. It's not under control of a central authority, which might be a good thing. But when it comes to maintenance and somebody taking ownership and responsibility, then this becomes a bit challenging. And having an automated solution to create filters, even remove filters, that would really help and save the day and be fast.
Well, good, thank you.
One small thing I just wanted to add is, right now, if you really want to compare the easy privacy with the potential list that we are planning or aiming to generate, then the one that we are really aiming to generate is really the third-party trackers, which has like clear differentiation between the first-party versus the ones that are third-party trackers. So hoping that we are able to identify just the third-party trackers and not necessarily completely block the first ones.
So you mentioned that you're using an NLP model, and you're using the URLs, I presume, as the data. So I'm curious how you tokenized the URLs. If you could say more about that.
So we take the URL, take each and every character as a separate token, and we assign them a numeric value. There are a number of ways how we can proceed further. One of them is that we create then metrics out of it. The rows of the metrics are the domain names. The rows are then representing the filter hits. And then using that combination, we proceed further. And then this is only one of the different parameters that we were talking about. There was the request URL and the request parameters as well. There we actually use one-hot encoding. So there were 12 different types of request parameters that were there, image, script, post, etc. So we took a 12-element vector and used one-hot encoding for representing them.
Got it, thank you.
Mm-hmm. Awesome.
Excellent.
Good throw.
Good catch.
I got a couple of questions. So the first thing is, have you made the data public from your research?
We are in a very preliminary stage to make the data public, and it's actually easy list and easy privacy, and the Tranco list, which is all public information.
Right. I meant the ML generated list. I was curious to have a look through it.
Not yet.
No? Okay.
We are not yet
very
there.
preliminary stage.
Fair enough.
We are not yet.
The other question was, I don't know if this is really for you, but is this with an idea to having some kind of acceptable tracking program, like the acceptable ads thing?
That's a very good question.
Yeah.
But this is definitely not for us.
Okay.
That would be a good add-on feature, maybe later part in the roadmap, but right now we don't have that in our radar at least.
All right,
Add it to the backlog.
Yeah, thanks for the idea.
I'm sure I'm not the first person to think of that.
Anyone else? Okay, I think I might. There you go.
That was dangerous. Hello. What data points do you use to identify whether it is tracker or not? I understood that you use the URL, but do you use the cookies that are transmitted with the request, because it might be like really important?
No.
Might be a good idea to do.
That's a good idea.
Yes.
Yeah. Right now, we are just looking at the URLs and
The request.
The request
and
URLs.
domain names,
Yeah.
the query parameters.
Pretty common. The cookie names are pretty common for trackers, for different tracking systems, because there always will be some kind of a UID, session ID, and this kind of stuff.
Exactly.
Awesome.
Sorry. So it picks up trackers, say, if we look at Google Analytics or Google Tag Manager, you could mark that as, obviously a tracker. But with easy privacy, obviously there's a lot of sites that will break if you decide to block said trackers, because like the checkout button, for example, is bound to a script that checks that if it's has an assigner value for Google Analytics or Google Tag Manager or whatever, it'll break. So this wouldn't pick up false positives where, while it's a tracker, it could potentially break a site, eh? You understand what I'm saying? It's like sort of, it can't distinguish whether that tracker is going to break the site or not, will it?
That's a very good point. In fact, this is part of the future plan as well, that we do not block everything as, because there are essential trackers as well. In addition to first party, there are these essential trackers as well, which break the site utility, and we need to work on making sure that we are not breaking the site utility as well. We need to think about how we can actually protect user privacy by maybe reducing or filtering out the private information that is being transmitted to the from outside of the user's machine by blocking something like that and not blocking the whole tracker as it is. But this is also part of our future future work. Yeah, as the next steps. Detecting the trackers was the first one.
behind you.
So are you saying that the main differentiator between the first-party tracker and the third-party tracker right now in this approach is the domain name?
Domain name combined with the URL request, yeah.
Okay, so if there is a common sort of group of interest, let's say Amazon and Twitch, if the actual tracker is by Amazon on the Twitch entity, which still is a sort of first party, that will be tracked as, or treated as a third party, right?
Pari, you want to take this?
Well, yeah, that's one of those exceptions where I think
we spoke about it a lot.
Yeah, yeah, those are some of the exceptions that we also want to consider in the future. Like the Twitch would be considered a third party, but not necessarily a third party. So I don't know. I think we do definitely have some of the open questions, and we are at a preliminary stage. So I mean, great that such good questions and ideas are coming from this crowd. So this will definitely help us with, taking things on those lines. Definitely, that's something I would like to say at this point.
And we have been discussing whether we want to use this first-party versus third-party differentiation as an input to the machine learning model, or we want to use the machine learning model to train on distinguishing between the first-party, third-party, and non-trackers. So far, it was like just tracker, non-tracker data, but the future plan is also to have first-party, third-party, non-tracker information detected by the model. We have a question here. Yep. Oh.
Yes, a couple of months ago, I was on an online marketing event, and they were worried about 80% of their jobs because of the new cookie law. What is your view on this?
80% of their jobs can be lost because of the cookie blocked or cookies not blocked.
Yeah, they were not allowed to use cookies anymore for their marketing tracking events. And it's their job. I was surprised. 80% is a lot.
80% is a lot. And I think this is where it comes back to having a fair internet. We really don't want people to lose their jobs just because they cannot reach their customers. And therefore, we really need solutions like privacy-protecting ad solutions, like crumbs, which can actually. This was not a big question, but yes, definitely. But definitely, and that's why at eyeo we are actually focusing on bringing a fair internet to the user, so that the publishers, the advertisers, the users, they all have a win-win-win situation. Nobody has to lose their job because they cannot reach the users. And that's why also when we block ads, we don't block everything. This is not ad blocking Dev Summit. This is ad filtering Dev Summit, because we totally understand the concept that we need to make sure that some ads need to reach the users. They have to be filtered, not just blocked. Thank you. That was a very good question. I think we are over time.
Yeah, I think we're closing the questions here, but people can still reach out to you afterwards, during networking later on, or also the breaks. Thank you, ladies.
Thank you very much.
Big round of applause. Yeah, all this machine learning and AI is really a mystery to me, so thank you for kind of laying it out in such comprehensive, easy words. It's such a complex topic, so that was really great. Also the multimedia use, including making the audience stand up and stuff, that was something, right? Okay, but we are moving on now, and we have another talk that is shared by two speakers, and we have Athanasios Andreou, who is a researcher at the Algorithmic Transparency Institute, and he's sharing this presentation with Victor Lepocha, who is a PhD student at the IMEC Distrinet KU Leuven. And yeah, a few words about our speakers maybe. Athanasios is a researcher broadly interested in transparency, security, and privacy, and targeted advertising. And yeah, he's also a holder of a PhD that he got at the University of Sorbonne in 2019, and later on was also a postdoc at the CNRS in France. And yeah, I mentioned he's currently working at the Algorithmic Transparency Institute in the US. And about Victor is his name. Victor is also a PhD researcher, so we are kind of going more into the academic route here again. And at the IMEC Distrinet, KU Leuven, and he's also an FWO PhD fellow. And he also studies web security and privacy and is particularly interested in the exploration of malicious web ecosystems and including malicious advertising and improving research methodologies. So I don't know who's on stage first. Athanasios. Great. Then we're looking forward to hearing about your audit on Facebook's political ad policy enforcement. Thank you.
Thanks for the introduction. So, essentially today we're going to talk about two different approaches that we did, each one in a different study, to audit Facebook's political ad policy enforcement. Now, in my case, I started working on these things around 2017 with respect to political ads. And at that point, it was all the rage, all the aftermath of the 2016 US presidential election. You might remember scandals like, for example, the fact that you had fake news on political ads and like completely made up facts that were featuring as political ads. And I don't know if you recall at that point, for example, Facebook was not banning these ads because it was comparing this to censorship, which was kind of controversial also at the time. Also, you had other serious stuff, like, for example, foreign interference in elections. I don't know if you recall, but at that point, there was some kind of Russian-based company called the Internet Research Agency that sent a lot of ads that targeted US users on topics such as, for example, securing borders, about LGBT issues, or about, for example, ads that were comparing Hillary Clinton to Satan and Jesus to Donald Trump. These ads have been studied, and they were shown that they were very effective. They had 10 times the average click-through rate compared to normal political ads. They had content on polarizing topics, as you can see, and they were targeted over a very large span, like over 2 years. And they made use of all the micro-targeting that Facebook was enabling them. Like, for example, they would target users interested in African American history, Latin hip-hop, or even attributes that existed then at Facebook, like black nationalism. So, yes, that was one other thing. And there were also other scandals you might remember, for example, the Cambridge Analytica scandal, etc. So, we wanted to work on these things. The first thing that we wanted to define is essentially what is a political ad. And that's not a very clear question. In the case of all these things in social media, the definition is left to each platform on its own, and they decide what it is. In the case of Facebook, in 2018, a political ad was an ad that was made on behalf or about a current or former candidate for public office or a political party. It was about some type of elections, referendum, etc. It related to national legislative issues. All these are ors, not and, so either of these clauses would qualify for a political ad. It's regulated as a political advertising, and the last part was if it's related to issues of public importance, which is a very broad definition because everything can be an issue of public importance. These days, Facebook has made this list a bit narrow, so you see that there are changes also in these things. Now it's a bit more compact. This very broad definition about any social issue has been removed, and it has been replaced by something that says about social issues in any place where the ad is being placed. And then they give a list of social issues per country. So you see that this type of thing is kind of left to the platforms on their own to decide. On the other side, the oversight falls also to the same advertising platforms. Essentially, even today, let alone in 2018, there was not a really up-to-date legislation for these things, and everyone was making their own policies. In the case of Facebook, political ads could only be sent by advertisers in the same country as the targeted users. I guess that was a response to all this scandal with the foreign interference. They needed to verify their accounts, which usually requires some kind of national identification. And they needed to have a paid-for-by disclosure, which shows who pays for this campaign, which campaign it belongs to. Another big thing then, which was kind of a breakthrough, was that Facebook offered an ad library where users could historically look at all the political ads that were posted on the platform. While this was definitely a move forward, it was also a bit controversial, and it received a lot of criticism then, mainly because of the huge data asymmetry. Essentially, Facebook was allowing users to target with tons of features. More than 250,000 attributes were detected then. And attributes you can see, like, for example, anti-abortion movements. And I had even found attributes like fascism at some point that were running. Usually they're curated, and sometimes they get removed and they get updated. On the other hand, in the political ad library, you could see only information about the cost of an ad and the age, gender, and location that it was targeted. So there is a huge asymmetry and usability in these things. However, recently there has been some improvement. Now you can see some aggregated statistics about attributes that were being used, just not on a per ad basis, so per advertiser basis. At least it's a move forward. Another thing that is left to the platforms to figure out is the enforcement policy. Essentially, how to catch ads that are in fact political, but but they were not declared as such. When I was working in these things a few years ago, there was not a lot of information on how this thing is enforced. And as you will see in my study, you will find examples that they could have been easily been detected, but they were not detected. Now it seems that we know more things about that. There seems to be a largely automated detection of political ads, like this here, for example. And essentially, what Facebook does is that it disables the ad and retroactively puts it in the ad library. However, this process ends up to having many missing information. Like, for example, if the advertiser did not put who paid for this ad, this never appears anymore in the library, and this information is lost forever. So, to sum up, as we see that there are a lot of places where there is a lot of leeway, and there can be many things that can be improved, and essentially, things are a bit opaque and are left on the platform. So what we wanted to stress at that point, and we wanted to create, is some kind of external auditing mechanism for political ads, and how Facebook and every other platform enforces their rules for that. So now let's go. Yes, that was. So now let's go to two different approaches to do that. In my case, this corresponds to a paper we wrote, which was presented at WWW 2020. Now, in our case, the landscape was that we wanted to detect political ads for the 2018 presidential election in Brazil, because we're collaborating with some Brazilians at that point. And our solution was to essentially build an independent auditing system that enables the participation of the society to solve this problem. Essentially, we ask users to donate their data, and with this data, we use them in order to detect political ads. We did that with a tool that I developed at that point called Ad Analyst, which was essentially a Chrome and Firefox extension, which was, unlike the ad blockers, it was trying to detect ads, in this case, on Facebook. And we were collecting ads on Facebook and the explanations that users receive about these ads. And we did several more studies with this tool. And actually, right now, the tool, I have left this development tool to the team now. So this tool was not really maintained, but I think during this month there will be an updated version. So if anyone wants to look at their ads on Facebook, if they don't block them, they can have this tool to get some more transparency. On the other side, after we detected the political ads, we gave the users back a political ad detector for the Brazilian elections. Essentially, we had an application like the Facebook ad library with the political ads that we detected on the platform. Unfortunately, this link is now defunct because a lot of years have passed since the elections in Brazil, but now our collaborators there are preparing a new one for the new elections. Another thing which was a very big challenge, especially in a work that is a collaborative work and requires the participation of society, is to get users. In our case, we did many articles in newspapers, especially Brazilian newspapers, to highlight the issue and advertise our tool. And even our collaborators in Brazil presented something in the Brazilian Senate about political ads. And we garnered some publicity. And with this, we managed to have around 2,000 users that volunteered to install our extension, which is something that allowed us to move forward. So overall, we collected from ad analysts around 240,000 ads from 40,000 advertisers, covering both the pre-electoral and the electoral period in Brazil. On the other side, we also collected some ads from the Facebook ad library, which were essentially all political, around 100,000 ads for the same period. Now, again, we're going a bit to machine learning. Essentially, we wanted to detect political ads. And how do you do this with machine learning? You have some positive examples, some political ads, and then you have some negative examples, some non-political ads, and then you use some kind of supervised machine learning algorithm for that. In our case, we operationalized Facebook definitions of 2018 to what is a political ad, and we took a random sample of 10,000 ads in Portuguese from ad analyst, and we asked 3 students, poor students, to label these ads, and they came out that 233 political ads were in ad analyst at that point. Where these ads obviously were not enough to train something, but that's why we have the ads from the political ad library. These are essentially compliant advertisers, and they're a very rich data source to use it. So essentially, our data collection had 10,000 ads from the political ad library, plus the ads from ad analysts that were as political, and the rest non-political ads were the negative examples. Now, in order to classify, we used different classifiers, 6 different classifiers, most of them very common, like naive Bayes, logistic regression, SVMs, gradient boosting, and we also used some convolutional neural network that has been used in previous bibliography for detecting political content. For features, we just used the text of the ads. And we represented it with word embeddings, in particular word2vec. So something similar in this case. And finally, we did some type of tenfold cross-validation for our validation. Now, what were our results? Here, you see that all of our models got really, really good accuracy, more than 92%. While this makes sense in our data set, which is like a balanced data set, in practice, you have much more non-political ads than political. So essentially, accuracy is not very meaningful when you have a setting like that. Because if you have, for example, a classifier that classifies every ad as non-political, probably it will achieve very high accuracy. So we focus on a different measurement. So we look at the true positive rate, which is essentially the recall, for 1% false positive rate. And we see that there, the CNN and even naive Bayes, which is a completely out-of-the-box solution, essentially achieve pretty high true positive rate, around 78% and 85% respectively. What does this mean in practice? It means that if you have, for example, 10,000 ads and 500 of them are political, our naive Bayes approach theoretically will correctly label 425 of them and miss the rest 75, but it will also mistakenly label 95 of non-political ads as political. That is also important why we need to have such a small false positive rate. For example, even if we had something with 100% true positive rate but 5% false positive rate, we would make 475 mistakes because most ads are non-political. Afterwards, after we had this model and this classifier, we tried to employ it in the wild. Look at the rest of our ads in Ad Analyst and see what we find there. And what we find is that we detected 835 ads that we classified as political. These ads look like this example here, some of them. This is actually an example which shows that very distinct on why it is a political ad. So what do we see essentially? We see that these ads are political, but they were not in the political ad library, so they were completely missed at that point. And so this also makes us wonder what else is missing from the ad library, and also stresses out why we need such a system. To go a bit back, there is also another thing which was very interesting with these things. In Brazil, there were several separate rules alongside Facebook rules about what is a political ad and what it should have. And it had several rules, like, for example, that ads could be sent by candidates or political parties, which were similar to Facebook. But they also had some rules, like that ads can be sent only by candidates, so not someone who is not a candidate or a party. And that all ads need to have essentially some kind of information, like the tax ID of the person who is a candidate. And what we noticed is that 20% of all these undeclared ads came from advertisers who were essentially not allowed by law in Brazil to post ads, so they shouldn't have sent to begin with. And another thing that we saw is that 10% of the undeclared ads had the appropriate disclaimer with the tax ID, so they were following Brazilian law, but they were not, they didn't know perhaps how to declare it in the ad library. These ads also, because they had all these things, even a very simple regular expression search or something could have detected them, which also points out that perhaps Facebook, at least in Portuguese at that point, it was not really having some very solid enforcement mechanism. Overall, what we saw in this work is that many advertisers in Brazil did not label their ads as political, and that the Facebook ad library was missing these ads. But we also saw that essentially it's kind of, you can have, with a very simple classifier like naive Bayes, if you have the correct data, you can really make something like that work. And also that you can have something work by asking users to donate the data. Even if you don't have a huge user sample, you can do something. So now that was the first approach. That's my cue for Victor to go to his part.
Hello? Okay. Okay, thank you. So now I'll present our approach that we did in our study. Let's fast forward 2 years. So the audit was done in 2020, and there are quite a number of differences between the approaches that we took, but essentially it was the same goals. We wanted to understand, does Facebook's enforcement of its political ad policy actually work in practice? So indeed, we wanted to audit the political ad policy, and for this, we did a quite different approach to data collection. So instead of crowdsourcing a small sample of data, but from real users, we went to Facebook and we collected the ads that they published, as Thanos mentioned, on their ad library, but on a much larger scale for every page that we knew to have published at least one political ad, and across the entire world. So also not only Brazil, but throughout the entire world. We collected all the ads that these pages published from a period between July 2020 and February 2021. So we covered, for example, the 2020 US presidential election and also major elections in Brazil at that time. In the end, we ended up with over 33 million ads, but a lot of these ads were actually not that interesting for us to study. First of all, there were the 4 million ads that were properly declared as political by the advertisers. So they ticked the box saying to Facebook, this ad is political. And that means that Facebook's system didn't have to do anything, because Facebook knew from the advertiser that the ad was political, so they didn't have to invoke the machine learning and get the system to decide whether it's political. No, the advertiser already ticked the box, so the system doesn't have to do anything. Then there were over 29 million ads that neither Facebook or we thought were political in nature at all. And this can happen because some companies will from time to time publish a political ad, or more likely this kind of social issue ad, let's say about the environment. But usually it's just commercial ads, and that means that they do end up in our data set, but we kind of ignore them overall. What are the interesting ads? Those are the 189,000 ads that were not declared by the advertiser. So the advertiser didn't tick the box, and upfront we don't know whether the ad is actually political or not. But then either Facebook or we determined that the ad is political in nature. And these are the ads where Facebook's enforcement system should have kicked in or actually kicked in. And these are the ads that we look at in much more detail. As a bit of a side note, in terms of data collection, I already mentioned we didn't crowdsource data. We got data from Facebook, but this ad library, it does have an API, and this is like the standard way of collecting data in bulk from Facebook, but it only archives known political ads. Facebook can only put an ad in there if they know that it's political. But that's insufficient for our auditing purposes, because we need to have the ads, even if they're not political and have not yet been caught, because we kind of want to understand how long does it take for Facebook to actually catch these ads, or the ads that are actually never caught, and we want to know how many ads does Facebook system actually never catch and are never labeled as political. So we had to resort to the web portal, which does list all the currently active ads for every page on the platform. But there the challenge is that the ads disappear once they become inactive. And as you probably know, the lifetime of an ad, it can easily be only a few hours or even less. So we need to be quite quick in actually collecting these ads. And we also built a tool to then collect these ads, store them, and archive them for later analysis. So let's go on to that analysis. So again, we wanted to understand how well does Facebook's enforcement system work. So we need to look at the two error types that exist. And we start with what are the false positives. So these are the ads that Facebook detected, the system kicked into action, it took them down, it thinks that they're political, but then according to our analysis, they're actually not political, so they were mistakenly taken down. And for this, we used a manual annotation of 600 ads. So we had, again, poor students labeling the ads. This is a standard practice, actually. And the annotation, the goal of the annotation was specifically, are these ads in scope of Facebook's political ad policy? Because, again, the definitions change between platforms, even between people. Some people think something is a political ad, while others don't. But we specifically wanted to test the system, so we asked to specifically answer this question. And the result of that annotation was that 55% of the ads that were detected by Facebook were actually incorrectly detected. So here, the system thought it was political, but actually they're not political at all. And when we extrapolate this number to the entire data set, this means over 40,000 ads were actually mistakenly taken down. And these ads, they cover a wide variety of topics. There are classic commercial ads, like the car sales ads in the middle, but also a lot of health-related ads, and at the time, of course, also ads related to the pandemic, which are like beneficial messages that actually do not reach the public because they are being taken down by Facebook. And then you have like the silly examples like pie recipes, which are apparently very controversial and political. The other error type are, of course, the false negatives. So these are the ads that Facebook did not detect, that were also not declared as political, but that, according to our determination, are actually political in nature. And we established a lower bound for the number of ads that Facebook missed by using the rule that all ads from a political actor should have been declared. So what we did is look for these actors through external lists of known pages of political actors and the category that the page assigns to itself, such as political party or politician. And then we just looked at, do these pages have any ads that were not declared, not detected, but that are therefore still political in nature? And there we found almost 117,000 ads that were not declared and that also were not detected. So these were ads that Facebook system failed to find, even though they were clearly political in nature. And these are ads from major political parties, major political candidates, also ads that usually, almost always, are like clearly political in nature. The message that they have is clearly political. So these ads should have been pretty easy for Facebook's systems to catch. As a bit of a side note, the distribution of these false negatives was quite uneven worldwide. So obviously in the US, where they mostly speak English, the models work pretty well. In the US, less than 1% of ads were actually missed. To compare with this audit from 2018, we actually see a bit of improvement with the Brazilian advertisers, so from 2.2 to 1.5. But there are certain countries, like Malaysia, all the way on the right, where up to 45% of ads were actually missed. So it seems that the system at the same rate with the same accuracy across the world. So to summarize, even after 2 years, even after the 2018 audit, in 2020, we still see that the enforcement is quite flawed. I highlighted classification metrics that we computed based on these false positives and false negatives. If you do not know what these are, that doesn't matter. Just know they range between 0 and 1, and 1 means that the system works perfectly and classifies everything correctly. But the F1 score of 0.29 suggests that the system does not really work that well and actually makes a lot of mistakes. Now, why might this be? Why might these systems not really work properly? We identified 5 limitations in the approach and in the way in which Facebook enforces its policies, and also make some suggestions on how Facebook could improve. And the first limitation is just the approach. I think in our audit specifically, we kind of didn't want to use a lot of machine learning while trying to evaluate these ads, because we know that automated solutions might not always work, and we see here that it seems that they do not learn certain obvious signals of the political intent. For example, the advertiser. If you only focus on the content and do not take into account the metadata, such as who is advertising, you might miss a lot of ads. So we suggest that they do this as a first step. You look at the advertiser, and in general have simple rules that are clearly enforceable and that can still complement automated review. It's of course still useful to cope with the scale, but still you can have certain clear rules like the regex that also Thanos mentioned, that make it a lot easier to have an accurate model. Secondly, the consequences of running ads that are political but without properly declaring them. According to Facebook's statements, they do have a policy in place where pages that run these kind of violating ads can actually be prohibited from running ads in the future, or the pages can actually be taken down. But we do not see a lot of evidence of this happening. So either Facebook does not want to do this or is still unable to do it somehow. But this could be an effective way of actually getting advertisers to comply with the policy and actually do the right thing of declaring their political ads. Third, consistency. As I showed with the false negatives, the consistency is not there worldwide. The performance is not the same globally. And this is, of course, also a question of fairness. Every country, every community deserves secure online political speech and deserves that political ads are correctly treated on the platform. So we suggest that Facebook adapts its policies and its systems to local context. Train your model on local languages. Look at local legislation. Make sure that you're compliant. Try to work with local organizations to understand what the local issues are, what maybe local keywords are that are important in the political communication, and really integrate them into the system to make sure that this performance is equal worldwide. Fourth, the policies themselves. So, as we mentioned, they are quite lengthy definitions, they are quite vague, ambiguous. Also, when we try to do this annotation on over a quarter of ads, we still disagreed on whether these are actually in scope of the policy. Are these actually political ads? And these ambiguities also complicate compliance for advertisers, because if they have a lengthy document that they have to go through with vague statements, they do not know if they have to comply, if they have to declare their ad. And that also complicates the enforcement for Facebook. If they have complex rules that they have to integrate into their system that enforces their policies, it is more likely that the system will not work properly. So we suggest that they clarify the policies, simplify them, such that this compliance and enforcement becomes much easier. And finally, Facebook emphasizes transparency as a solution for online political advertising because it allows people to look at the ads, see who is publishing ads, and then hold people accountable. But with the bad enforcement that we showed is happening in Facebook systems, also comes bad transparency. Because as I mentioned, mainly only known political ads are being archived. And there are therefore, due to the false positives, a lot of bad ads that are actually not political, that are still polluting the data set. And there are, due to the false negatives, a lot of ads that are missing from this data set that should be there. So we advocate to just get rid of this distinction and just archive all the ads and all the metadata. And there are certain limitations and certain complications that happen because of this, but we can work with this. And by archiving all the ads and all the metadata, we can actually improve this accountability and make sure that malicious ads do not make it onto the platform as easily. Because with better transparency, better accountability can really be achieved. Because if we have access to data and we can do these kind of audits and really look at whether these systems work properly, then there becomes like an incentive. Then we can hold people accountable, both the advertisers and the platforms. And once we have this, then there are incentives for the advertisers to comply with the policies, because we can see whether they do or not. And there are incentives for the platforms to start improving their enforcement, because we can see whether their systems actually work properly. And once we have better compliance and enforcement, then we actually achieve our goal of better security of these platforms and making sure that malicious ads do not appear. And in this case, it's of course also the security of online political speech, because we really want the benefits of online political advertising to start outweighing the risks and the vulnerabilities that we identified. So with that, I'd like to thank you for listening, and we'd be very happy to open the floor to questions.
Thank you. This is super interesting. Enforcement, huh? It's a complicated field. And there's clearly room for improvement on Facebook's end. Do we have questions for Athanasios and Victor, not Peter? Sorry, I had to be sad.
Hi, great talk. I was wondering, I assume you guys informed Facebook about your findings? And if you did, okay, if you did, what did they say? And were there any change in how they enforce policy ads?
From my side, I'm not really sure. I mean, I know that some of my collaborators had some meetings and they met at some point with people from Facebook, but I don't know exactly what was the feedback. But what I want to say is that it seems that there seem to be some changes over time to the platform that can be attributed to maybe some of these things, but yeah, there's not really a direct communication line or something like that.
Yeah. For us, it's also a bit of a long and complicated history. So yeah. Our study was done in collaboration with people from New York University, and in the past, they actually had a quite good relationship with Facebook, and they exchanged ideas, they made suggestions on how to improve the platform. But then they also had this kind of extension which crowdsourced ads, the ad observer, and Facebook didn't like that, and they actually sent them a cease and desist letter to take down the extension, and that kind of closed the phone lines between the two. So with this study specifically, we didn't really notify Facebook upfront. There wasn't also really a need to, because we didn't find some sort of major vulnerability on the platform and something that had to be fixed urgently. It's more of a question of policies, of what does Facebook prioritize? Do they want to invest a lot into these systems and make sure that they work properly, or they're more interested in maybe commercial interests? And is this maybe some sort of an afterthought? We don't know. But of course, they did see the results when they went public, and we had some media connections. So the journalist basically asked Facebook, what do you think? And in my opinion, Facebook had a bit of senseless arguments. They were like, oh yeah, but there are a lot of well-declared political ads on our platform. Yes, there are, but the system doesn't have to do anything about those. So it doesn't say anything about the system itself. And yeah, we do see small improvements over time, but they're certainly not yet enough to actually achieve really the goals of transparency and security that we aspire.
Mm-hmm. Yeah, so funnily enough, I had exactly the same question. So thanks for asking that. I have a second one, which I can now ask. It relates to false positives, and I understand that it can be very tricky to say this is a political ad and this is not. But the cases that you showed, Victor, in your presentation show really odd examples that were flagged positive. The recipe, I think one was a car seller. Do you have any hypothesis why those ads get flagged positive, even though there's not even normal room for interpretation how that could be?
Not really, especially the commercial ad surprises. So what we did see in a few cases, but like maybe 5 or 10%, is that there were certain keywords that might suggest why Facebook's system flagged these, like some shop which was in a street named after a mayor, and then the word mayor is there, and then the system flags this. But this was not like the majority of these ads. So we actually don't really know. Probably it's just the model picking up on something. These models are, of course, also certainly to us black boxes. We don't know what they do. We don't know what their inputs and outputs are. So it's very difficult for us to tell why this is. And again, there's no transparency. Like if there would be a label that says like this ad was flagged because of the photo or the text or this or that, then we could know. But now we basically don't have a clue.
That also raises the follow-up important issue of how all these auditing systems need to have transparency. And they need to be, it's perhaps better to be a bit open sourced or something like that, because like that, people can understand how they work better instead of being completely black boxes. Yeah.
There are a few other questions. Go ahead.
Yes, okay. Facebook and all is one of the social media platforms. Do you also apply this sort of research to other social media platforms?
Well, to advertise a bit our work now. No. In my institute, we collect data from basically...
I think it's the two catchboxes too close.
From basically every social media, and we try to do different things. Like, for example, right now I'm working a lot on TikTok data, for example. Yeah, so in general, you need to do this for all the social media. But in terms of like academic papers and stuff like that, the thing we're discussing, usually you focus on the bigger one, and then you hope also that the community will catch on, and other people can also, since there is the methodology now to use it, they can use it. Especially when you're talking about collaborative ways, because then you need to recruit users as well, so there is this difficulty.
And the second element is actually, in credit to Facebook, they have one of the best and most advanced policies. So it is actually like very clear what they consider a political ad or not. And they have like the most elaborate transparency. They have this archive. They do put in effort to make data available to us. That's not the case for some of these other big platforms. So it's also much easier for us to study Facebook as a subject. And actually, it allows us to really understand how their system works.
Is there no rules and regulations and a carrot and a stick that you can say, okay, you have to do this, otherwise you get a fine for $1 billion or so? They talk about billions, so they're not impressed with a couple of thousands.
Coming up. So in the US, there are now proposals for legislation that would really require transparency into ads and political ads. There the issue is that sometimes they only say for like really academic researchers, but we really want this to be open to journalists and non-governmental organizations and even like just the public, because everybody deserves to have transparency. And also in Europe you have the Digital Services Act, which has like an addendum which also focuses on political ads. So people are working on this. Just the issue with legislation is it always has to catch up, and by the time the legislation has been written and voted, it's already 3 years too late. So it's always a bit of an issue. So it's also a bit to these platforms to take their own responsibility, which again they do to an extent, but it's also for them that they have to take the responsibility of self-regulation, like the oversight of their own platforms.
The sample that you used, so the ads that were categorized political or not political, was this purely automated on Facebook's side, or also sometimes based on user reports, because those are then categorized later by people, not machines, right? So they have these big centers.
I think as far as we know, both. And even like a third option where the automated model says, I'm not sure, so I'll have a human review it. But again, we literally have those 3 sentences, and we don't know how often does that happen, how many user reports are there, are these user reports still being vetted or not. So we can only say one of the 3 or either or, but we can't say like how many or how important these different paths are.
Other questions? All right, yes.
Are you going to do any stats for the 20 2022 and 2024 elections, so the midterms in the US and 2024 US elections?
Not yet, because they haven't happened yet.
Well, it's coming. We know it's coming, I guess.
Yeah. I think in our case, the study would be quite difficult to repeat at the moment because the data collection that we had to do, the pipeline is not really able to work anymore because Facebook is just like applying more and more restrictions on being able to collect the data. So it's quite difficult for us to actually repeat that study. But I think in general, a lot of researchers are looking into like the different patterns that exist for this election and the upcoming elections. Yeah.
Similarly, for a collaborative method where you get the data from Facebook and stuff like that, you always have the challenge that usually these platforms don't really like you when you take the data, and they really try to make it much more difficult. During, for example, my PhD that I was working on such stuff, I had to change the way I detect ads and some things like 5, 6, 7 times, sometimes on weekends where otherwise I wouldn't be able to collect data. At some point, I had started like reverse engineering the Facebook code behind because everything was going like much more automated. It was not just a sponsored tag that you can just detect it easily. So essentially, you need also constant maintenance, and every year these things become a bit more difficult.
Yeah, if you ever want to see something funny, right-click the sponsor tag and go to developer tools and see what it actually looks like. It's crazy.
Yeah.
That's our fault. Sorry for this. So I was going to ask, but do you think that the kind of farce that happened in 2016 elections could happen again, or is it there's enough scrutiny these days that it wouldn't happen to the extent that it happened there?
I'm hopeful that in the US it wouldn't happen because of all the scrutiny and all of these extra methods and how many people are looking into this stuff. But there is certainly the danger of happening in some other country where there's much less oversight. So, yeah.
All right, and I think we're also out of time. I'm sure there are more people who have questions, but good for you. We have another break coming up, so there you can just grab Victor and Thanos and just ask all your questions in person, or still via the chat if you wish from home. So thank you very much. Thanks. I learned a lot about Facebook and its work that it needs to do. Okay, then we meet in 20 minutes, 5:30. And then we have our last slot for the day. Now, All right. We're coming back online with our last block of 3 sessions for the day. The following ones will all be held by remote speakers. And we're getting started straight away. So the first talk will be a lightning talk by Abdul Haddi Amjad. And he is a PhD candidate at the Virginia Tech University. And Abdul focuses his research mostly on solving network security and privacy problems by leveraging software engineering techniques. And he's also working with Dr. Muhammad Ali Gulzar at the Virginia Tech, as well as Dr. Zubair Shafiq at the University of California, Davis. I think the one or the other of you might have also already met Dr. Zubair in the context of this event in the previous years. So that said, I hope, Abdul, you're live. And we're curious to hear from you. What's the next era of content blockers?
Hi, everyone. I hope you can hear me, right?
Yes.
Perfect. Thanks for the introduction, and thank you, everyone, for attending my talk. I'm Hadi. I'm a second-year PhD student here at Virginia Tech, and today I'm going to discuss about the future of content blockers. So briefly about my research background. So I apply software engineering techniques to security and privacy problems. Specifically, my ongoing research applies principal software debugging, fault localization, and software testing techniques to identify and localize this semantically problematic JavaScript codes, such as advertising and tracking scripts. So let's talk about something in bigger picture, and then we'll see a concrete example to understand the problem. So there are 2 key stakeholders in ad blocking: advertisers and trackers, and content blocking tools. Advertisers and trackers are engaged in an escalating arms race with these privacy-enhancing content blocking tools. On one side, we have these publishers who serve ads and trackers on their sites for monetization, whereas on the other side, we have these content blockers who try to block these privacy-invasive ads and trackers by using filterless. Now let's understand the problem using real-world examples. NBCnews.com is ranked 21st in the news and media category in US. So on this website, we see the script named app, then there's a hyphen, and then long identifier.js. The yellow box on the slides exactly shows the URL of the script. In short, I'm going to refer the script as app.js in future. This script is sending requests to taboola.com, which is very popular ad exchange to help publishers and advertisers in driving user engagement. Since this is a tracking activity, so it's shown in red color. This script is also sending requests to get the functional content of the website, like a watch live button and login for the users of the website. Since this is a functionality, so it's shown in a green color. This is one of the conflicted situations for the content blockers because they have very limited options to handle such case scenarios. Let's just walk through the 3 possible approaches for these content blockers and discuss their shortcomings. The first and the obvious one is to just simply block the network request to taboola.com. However, this can easily be made ineffective by moving content to any CDN. For example, by changing taboola.com to CDN taboola.com. Now, the second choice is to decide if you are going to allow app.js or you are going to block it. Allowing it means simply adding this URL to the allow rules of the filter list. But again, this incentivizes web developers to combine functionality in tracking scripts to simply avoid these content blockers. Whereas blocking it means compromising functionality. As you guys can see on the slides as well, the watch live feature has completely disappeared and navigation and login button becomes totally unresponsive. So users tend to simply disable content blockers if they adopt the later date. Now, this means that content blockers cannot make a reasonable block or allow decision for such mixed scripts. This issue maps to a well-known problem in a software engineering community, where we attempt to localize faulty functions based on whether they pass or fail test cases. We adopt a very well-known fault localization technique from software engineering to solve this problem. Here, automated fault localization is used to localize tracking functions in the mixed script on the basis of its activity. On the slide, you can see the function I in the script app.js that initiates tracking requests to taboola.com. After identifying the function, we simply terminate the calls to this function from script app.js instead of blocking the whole script. This renders the website nbcnews.com properly and without any breakage. Now, before we conduct any large-scale deployment for our approach, we actually wanted to investigate the prevalence of mixed scripts widely on websites. For this, we conducted a longitudinal experiment on the frequency of mixed scripts on 100K websites over the past 2 years. So last year in 2021, we saw 42% of the scripts as mixed, whereas this number increased to 49%, which is a huge jump in 2022. Therefore, these results further motivate us to do some JavaScript code analysis of these mixed scripts like app.js. Now let me explain how automated fault localization approach can be used to localize problematic functions in mixed scripts. We crawl the website and capture the complete network request profile. Then we use filter list to label network requests as either tracking or functional. And on the basis of an initiated request count, we annotate the entity. For example, script utag.js is initiating 132 tracking and 161 functional requests, whereas the function loader and firecourse are solely initiating tracking and functional requests, respectively. This ends up with script utag.js as mixed, and further scrutiny helps us to find that function loader exhibits solely tracking behavior and can easily be blocked by content blockers. So we have designed experiments to compare the effectiveness of method level blocking versus script level. So in script level blocking, we block all the scripts that have similar behavior like app.js on nbcnews.com. Such scripts are referred as mixed scripts. Whereas at the method level blocking, we only block the tracking methods in the mixed script, such as method I in script app.js. Now we conduct our experiment in the two phases. The first one is an automated analysis of 100K websites. In automated analysis, we are going to compare, obviously, the blocking of mixed scripts versus the breakage after blocking the tracking methods in mixed scripts. And to compare the breakage automatically, we compare the missing DOM media tags of control experiment with the blocking scenario. For example, image source 2 is missing in the blocking scenario. We compare the URL of the missing tag with the filter list to label it as tracking or functional. If it's functional, then it's considered as a breakage. Now let's talk about the results of the automated analysis. So missing functional image tags in script level blocking was around 35K, and it dropped to 14K at method level. Missing functional iframe tags in script level blocking was around 18K, and it dropped to 11K at method level. And missing functional script tags in script level blocking was around 52K, and it dropped to 28K at method level. These results clearly show that method level blocking is much more effective as compared to script level blocking. Now we further complement our automated analysis with qualitative manual inspection of 383 websites. Here we label website breakage in terms of 4 categories: navigation, which includes the links to the internal web pages. Second is single sign-on, which includes the user sign-in using credentials like Google or Facebook. Third one, we have appearance, which include media appearances, except for advertisements, just like the scrolling behavior for the websites or the HTML tags. Lastly, we have additional functionality, which includes everything that does not fall in the above mentioned categories, such as the dark mode or website setting, etc. And then we classify each page load at 3 levels of breakage. No breakage when everything looks good. Minor breakage when we see slight abnormal behavior. And last, we have major breakage when something is totally unusable. The results of minor breakage on 383 websites show that 15% of the websites have minor breakage in script level blocking, while around 9% websites show minor breakage in method level blocking. In short, we see less minor breakage on 7% of the sample websites. Similarly, the slides show the results of major breakage on 383 websites for those 4 categories. We find that 26% of the websites have major breakage in script level blocking, while only 7% of the websites show major breakage in method level blocking. In short, Method level blocking recovers functionality in 48% of the sampled websites that have breakage due to script level blocking. Again, these results validate the findings of our automated analysis as well. Let's just conclude everything. Hopefully, I have convinced you guys today that the automated fraud localization techniques can be really fruitful for content blocking, especially as advertisers move to mix advertising and tracking and functional resources together. So these principal software engineering informed techniques can actually assist in creating the next generation of the content blockers. Since I cannot take questions live from the audience, I would just like to just get some questions on Slack, or you can just email me at my email on the slide as well. So yeah, that's pretty much it. Thank you so much. Thank you so much for listening and attending my talk. Over to the host.
Thank you so much, Haddi. As you probably remember, for remote speakers, we're making use of the Slack chat. So everybody at home or also from here on site, use your phones, use your keyboard, and hit the keys. And Haddi will be happy to answer. All right, and we are moving on here with our next remote speaker. And it's Franziska Rösner. She's an associate professor at the University of Washington. And yeah, Franziska also co-directs the security and privacy lab there. And her research focus has actually been quite broad on computer security and privacy for end users of existing as well as of emerging technologies. And yeah, her previous work has studied topics such as online tracking and advertising, security and privacy for sensitive user groups, security and privacy in emerging augmented reality, and also on the Internet of Things platforms. So very broad research here. And also actually on online mis and disinformation, as we've heard earlier today, maybe also in the context of political ads, etc. That is an important topic to look at. With her work, she has also acquired numerous awards, so I'm actually quite excited to hear Franziska's session that will basically be covering what is problematic content in online ads. And I hope that Franziska is with us. Good morning to the States.
Good morning.
Hello.
Good evening to you.
Everything is working, you're live, and you can take it away, Franziska.
Okay, great. Thank you so much for the introduction and the invitation to be here. I wish I could be there in person, but I'm glad we can at least connect in this way. So again, I'm Franziska Rösner. I am an associate professor in the Paul G. Allen School of Computer Science and Engineering at the University of Washington in Seattle. So it's morning here. And I co-direct the Security and Privacy Research Lab. And as you heard, our focus in this lab is really broadly on computer security and privacy topics, understanding current technologies, anticipating future technologies, thinking about technical systems, but also thinking about people and what they need and how they interact with technologies. One of the lines of work that we have been doing over the last 10 years or so, like many of you, has been studying the online advertising ecosystem. And we've looked at that now from a variety of different angles. And, you know, I think the venue here, many of us think about all of these different topics, ranging from the privacy concerns associated with tracking that supports online advertising, potential implications from targeting, the way that that private data is used, but also the way that potentially vulnerable individuals can be targeted with ads. And more recently in our lab, we have been studying the user-facing content of these ads. And so that's what this talk is about. And I hope I will both show you some interesting examples, but also convince you that the problematic content in these ads is an issue and something that we should be thinking about in addition to the underlying technical mechanisms of the advertisements. So, you know, in my research community, the security and privacy research community, our work and others has focused a lot on these underlying technical mechanisms of the targeted advertising ecosystem. So considering the privacy concerns with tracking and targeting and so on. And all of this work has really been mostly agnostic to what the actual content is of those advertisements. There's been some work looking at the use of advertisements to distribute malware or exploits, but the user-facing content like you see in this slide is something that we haven't really studied systematically previously. And so this has been the core of our research focus over the last few years, understanding what is the user visible content of ads and what is potentially problematic there and what's going on in that ecosystem. So to motivate this a little bit further, this started in part, this research direction, not just based on our prior work in ads, but some work that we've been doing related to online misinformation and disinformation. And one of our observations, kind of bringing these two areas together, is that a lot of the work in the mis and disinformation space is really focused on content that we see on low quality or misinformation news websites or on social media, kind of first-party content. But one of our observations is that much of the content that users actually see on the web, if they're not using an ad blocker, consists of advertisements. And these advertisements are often hard to distinguish from the news content that they see on the same pages. So here's a screenshot just to make this, this visual. This is a screenshot of some news site, and the top two articles are articles on that site. And below, I think probably this audience is skilled at recognizing these things, but below there's this feed of advertisements that are labeled as sponsored, but otherwise use roughly the same styling as the rest of the articles. And there's been plenty of work in other fields also studying the detectability of these ads. So how good are people at identifying this content as ads? And by design, people are not so good at distinguishing this from primary content. So this has been our core observation, that not only is this content hard to distinguish from first-party content for many users, it also just frankly makes up a large fraction of the content that people see on the web. So if we think about the web as an information platform where people are getting news, they're getting health advice, they're getting all sorts of crucial things, a lot of the content that they see in practice is in ads. And I think when we're thinking about this type of content, it can sometimes be easy to think of ads as this secondary thing that's not primary to what users are seeing, but it really makes up a large fraction of the real estate of many of these sites. So our research questions around this have been kind of threefold. First of all, conceptualizing what problematic content actually appears in ads and what makes it problematic. And I'll show you a few examples on the next slide, but we sort of see a spectrum of different types of content ranging from things that are, clearly bad, I would say, like outright scams, to things that are more distasteful and maybe would not be considered problematic by everyone. So we've been trying to wrap our minds around this spectrum of content and whether and how one can draw a line somewhere. As part of that, it's important, of course, to understand users' perceptions. So I'll talk a bit about what we've learned from asking users directly about these ads. And then the bulk of our research has been on web measurement. So understanding what type of problematic content is prevalent in ads in the wild, how prevalent are these types of ads, who is creating and distributing these ads, and on what websites are they appearing. So what do I mean by problematic content? You might have some ideas in your mind, but let me show you a few examples. So on the one hand, we have advertisements that are advertisements, but are poorly disclosed as such. So these are things like insurance advertorials, investment pitches, product advertorials that look often like news article headlines. And even the underlying news article, when you click on it, looks like a news article. We've even seen cases where the sites on which these articles appear are using logos from legitimate news sites. And they're sometimes disclosed as advertorials, but often not very clearly. We also see plenty of low quality content that is trying to hook people with some shocking story and then ultimately just distribute more and more ads to them on these low quality content farm pages. We see similar types of ads on particular topics, like especially on medical topics. We see a lot of low quality, unverified supplement ads and other things where you can start to imagine that the harms from these ads might be more than just wasting somebody's time by going to a low quality website, but potentially actually impacting their health decisions. We also see some things that are a bit more traditionally computer security concerns, like potentially unwanted software, ads that make it seem as though you have to click on the button to download the browser extension. And who knows what all these browser extensions do. That's something that we actually have not studied yet. That would be very interesting to look into, but using kind of these manipulative design patterns or dark patterns to trick people into downloading software. There's also a big category of clickbait ads that overlap with mis and disinformation. And I'll talk a bit more about these later in the talk, but I find these particularly interesting because on the one hand, they're in a gray area. They're often not making falsifiable statements. Like this one is one of my favorite examples. It says there's a viral video that exposes something fishy in Biden's speeches. And I'll talk a bit more when I talk about our study of political ads in the 2020 US elections about why I think this is such a problematic category of ad. And then finally, we see plenty of dark pattern manipulative design style ads, like these ads that look like polls or otherwise trick people into clicking or convince them that they need to click. And users may think they're doing something else, but in fact, they're clicking on the ad. So you see all of these different examples, and we could have a debate, of course, about how bad these different examples are and what we should do about them. But I think one of our observations in this work has been that there is, frankly, a lot of this type of content in the ad ecosystem, and there's a spectrum of potential harms from it, ranging from traditional computer security risks from unwanted and untrustworthy software, all the way to clickbait that is wasting people's time, but that is really lowering the quality of information that people are getting on the web. So our initial work focused on our own researcher-based analysis of ads that we collected in a measurement study, which led us to pose our initial research questions and identify these categories. But of course, one thing we really wanted to understand is not just what do we as researchers think, but what do users actually think, and do they also agree that these types of ads are problematic? So we ran a study a couple of years ago where we asked users about their preferences on ads in a couple of different stages. The first question was simply understanding the reasons why users like or dislike ads. So we selected a set of 30 ads from our previous measurement study, spanning what we thought was the spectrum of, high quality, well-disclosed product ad, all the way to these types of unwanted software scam downloads. And we find a range of user likes and dislikes that align with, perhaps what you would expect. But I'll build on this in the next slide. So, people dislike ads just because they are poorly designed, they're boring or irrelevant to the user, they're unclear. We see a set of ads that users are uncomfortable with. They find them distasteful or offensive. They find them too politicized. So we see examples like this, where there's a clickbait ad where there's some sort of gross image or an image that seems gross on first look, even if when you look at it more closely, it's actually something benign. So users react really viscerally to these types of gross ads. And this visceral reaction is, by design, but users don't like this reaction. And then we find ads that are, further on the spectrum that users viewed as deceptive and untrustworthy. So, for example, some of these stock ads, investment pitches, set off the alarm bells for users, thinking that this seems like a scam and like it's not from a reputable source, and so on. So this part of the study gave us this set of reasons that participants disliked ads. And what we then wanted to do is classify ads, cluster ads according to these preferences. So then we did a much larger survey with 1,000 participants, where we had each participant label 10 ads from our measurement study and label it with these labels that we developed in the first part of the study. So we randomly sampled ads from a crawl of the top 3,000 global websites. And then based on the participant labels, we clustered the ads and found 13 thematically distinct clusters of those ads, which we then further manually analyzed to characterize ourselves. So let me give you two examples, the clusters that were most disliked by our participants. On the one side, we have these scammy and untrustworthy ads, and the label distribution here tells you the the fraction of ads and participants that participants labeled with these labels that again came from the original study. So here's where we see the ads that are primarily viewed as deceptive and as clickbait as well. So that's where we see these investment pitches, these kind of health and supplement ads, software downloads, and so on. Then we have the distasteful and gross ads, which are overlapping thematically, but came out in this distinct cluster, which is more focused on clickbait and these distasteful ads that are trying to evoke this strong emotional reaction. It might be something that's disgusting. It might be sexual. It's a lot of human interest, celebrity news, clickbait, and so on. So one thing we found is that, perhaps unsurprisingly, participants, on the one hand, agreed roughly with our concerns about problematic ads, but participants did not all necessarily agree with each other. So it seems there is some degree of personal preference in what is across some line and what is not. I'll come back to that a bit later. Okay, so let me move on to talking a bit about our measurement results. So the first thing we want to know, of course, is how prevalent are ads in these different categories. And the short answer is these ads are quite prevalent. We can look at this in two different measurements. So one is looking at this set of 3,000 websites, the random sample of ads that we had participants label. How did these ads look overall? These same labels that I mentioned before. And we see that 20% of the ads were labeled by at least 50% of the participants who labeled them as clickbait. And over 10% of them were labeled as deceptive. And again, this was a random sample of these ads. So whether these percentages are higher or lower than you might expect, it's clearly a large fraction of what folks are seeing when they browse the web. We did another study where we used labels that we as researchers applied to the ads, where we did a lot of qualitative content analysis of the ads. And here what we were looking at is ads on top news sites, reputable news sites, and ads on top known misinformation or lower quality news sites. And the results here were actually really surprising to us because we went into the study expecting to see that there would be more problematic ads on the misinformation sites. The hypothesis was that maybe these misinformation sites pull users into a rabbit hole and they see worse and worse content as they go down this rabbit hole. But in fact, what we found is that these problematic ads appear nearly as frequently on the top news sites. So this is breaking down ads appearing on the home pages of these sites and ads appearing on the underlying article pages of these sites. And we see that nearly half of the ads were labeled as problematic under one of our researcher-created categories. So again, this is just a huge fraction of the content that people are seeing on the web. We can then also look at where are these ads coming from, who's serving them. And for those of you who know this ecosystem, you'll probably not be surprised to know that many of these ads come from these native ad platforms like Taboola and Outbrain. And we see that these platforms served a much higher volume of the problematic ads than other platforms that focus more on kind of traditional display ads. And not only is it a higher volume and looking just at the number of ads that are served, but also a much higher fraction of the ads served through these native ad platforms are problematic. In some cases, up to 100% of the ads are basically this type of manipulative clickbait. And so it's worth distinguishing this from Google here, where many of the problematic ads we saw are also served through Google's ad platform. But of course, Google serves a huge number of ads. So the fraction of ads served through Google that's problematic is much lower than for these native ad platforms. There's also the question of where do these problematic ads appear? And as I mentioned, I think a big finding for us initially that was surprising is that they appear significantly on both news and misinformation websites. And so in other words, this ad ecosystem is supporting financially all of these different sites, and sites are not necessarily making distinctions based on the quality of their own content. But one thing to note is that these ads are nevertheless not distributed equally. So looking just at the top 100 reputable news sites, about half of them served problematic ads in our measurements. A few served no ads at all, and then about half of them served no problematic ads, so only higher quality, well-disclosed display ads and so on. So the distributions here are actually quite skewed. So I've talked about some general measurements in our understanding of users, but one case study that I wanted to talk about in particular was around the US elections in 2020. So at this point, we had set up our ad measurement infrastructure. We had done the study of user perceptions. We had done our qualitative content analysis as researchers. And we were in the position to be able to collect and analyze ads around the US elections. So here we were looking at ads appearing on websites, so not social media ads. So some of these findings complement and give us the bigger picture of the advertising ecosystem, along with other work that you've heard about looking at the Facebook ads and so on. So over 6 weeks, approximately before and after the US elections in the fall of 2020, we collected 1.5 million ads from about 800 news and media websites, including some of those low quality and misinformation sites. Of those ads, we built a political ad classifier. We trained a political ad classifier, and about 56,000 of them were politically themed. And one thing I'll emphasize here is that we took a broad definition of what is a political ad. So looking not only at official campaign ads or things that would appear, say, in Google's or Facebook's ad transparency platforms, but also things that were leveraging political themes in some way. So including clickbait that mentioned political themes, but would not officially be labeled as a political ad by some of these platforms. So we found a spectrum of ads with arguably problematic content along the lines that I've shown you, including many of these misleading political polls, so this sort of manipulative design pattern that looks like a poll. It's leveraging people's political motivations, asking them to click. And when you click, you are redirected, of course, to the ad landing page, and also often asked for your email address or other contact information to finalize your vote, in which case you may be signed up for a mailing list that continues to push problematic content on you, as we've seen in other studies. We also see a lot of political product ads, some of which are unproblematic, but many of which fall into this gray area of feeling kind of scammy, this bait and switch pattern where you might get something for free with a large shipping and handling fee, and often targeting kind of US right-leaning, especially Trump-related paraphernalia during this period. And then finally, there is this category of political clickbait, which we saw a significant amount of. And I mentioned that I would come back to this. Again, these are ads that are not official political ads. They're really just the ad ecosystem taking advantage of the topics of interest of the day, and using these classic clickbait styles of sensational headlines, leaving out information that makes you curious and want to click. Often we looked at the underlying articles for some of these, including this one. The underlying articles contain very little substance and often don't really back up the implication of the original headline. And I find these to be very slippery. You know, they're not directly falsifiable. So it's hard to argue that you should take these down on those grounds. But they are a significant part, again, of what people are seeing as they are browsing the web leading up to the election. And it's contributing to their perception of trustworthiness of candidates, like, you know, in this case, the something fishy in Biden's speeches contributes to this narrative that there's something untrustworthy about Joe Biden. And people may not even identify these as ads. They may not later remember that they saw them as ads and just remember, you know, I keep seeing there's something untrustworthy about this candidate. And so I find this category personally really problematic because it kind of slides under the radar in being not explicitly problematic. It's not really a computer security exploit. You can't go after this in the same way, but it likely has really problematic impacts and contributing to you know the low quality of our overall information ecosystem. I'll show one last example from this case study. This is one of my favorites. This is actually an official ad from the Republican National Committee that was running in Georgia. And it looks like, you know, an old Windows dialogue. And I don't know if this is a joke or if this is intended to manipulate people, maybe older people who are still using older operating systems. I don't know what the intention here is, but I think it's just a really nice example of you know, the types of manipulative design patterns that come together here. So in the last few minutes, let me sum up what we've learned so far and also leave you with some what I think is our call to action here. So we see this spectrum of problematic ad content ranging from things that are clearly problematic to things that maybe not all users agree are problematic, and maybe you don't agree are problematic. But we see a significant amount of all of this content in ads appearing on websites, around half of the ad content that we see in some of our measurements. These problematic ads often appear in native ads, so they go together with this problematic design pattern of ads that are designed not to look like ads, and they're concentrated among certain ad networks. But they appear across many different types of websites, including mainstream media sites, misinformation sites, and across at least the US political spectrum. And then, as I mentioned, we see that people have varying perceptions of these ads, but nevertheless, there are some clusters of problematic ads that emerge from user opinions, especially around deceptive ads or emotionally charged, viscerally emotionally triggering ads. So where does that leave us? What should or can we do about all of this? I think the biggest thing that I hope you take away from this talk is that we need to be thinking about ad content as an important part of what we think about when we think about ads, and an important part of what we think about when we think about our online information ecosystem. So when we think about online mis and disinformation, thinking about these ads not just as potential funders of primary content, but also contributing to this type of problematic information that people see in the first place. I think there's a lot of room still to better understand the impacts of these problematic ads. We've asked for users' opinions about their emotional reaction to them, essentially, and we have some hypotheses about the impacts. You know, I've explained why I dislike these political clickbait ads, for example, but I think there's more scientific work to be done to really demonstrate and document these impacts on different users. So in terms of time or attention or emotional reaction or political opinion or subsequent behaviors or decisions around health and so on. There's also, of course, especially in the context of our venue here, supporting end users both in understanding this type of content, that it is ads, what its potential impacts are, or filtering this type of content. And again, there may be some personalized filtering that is valuable here as users have different preferences on the spectrum of problematic content. And ultimately, I think our work and related work is really important in providing increased transparency about what's going on in this huge ecosystem where users see different things and so on. And so providing transparency for users and regulators about this type of content and putting pressures on advertisers, publishers, and ad platforms to think about you know, the potential impacts of this problematic content, both emotionally, intellectually, and so on. So I will stop there. I know I can't take questions synchronously, but I would be more than happy to hear from you. I'm on the Slack, so please ask me questions there, or you can reach out to me via my email address or anything else I've put up here. Thank you again so much for the invitation, and I hope I'll see some of you in person soon.
Thanks a lot, Franziska. I think we can all agree that probably a lot of the ads that Franziska was describing should be blocked or filtered out, definitely. And yeah, it also reminded me of Gertrud's anecdote this morning, where we need to clean a few things in the oceans, and in the web there seems a lot of cleaning that needs to be done there as well. So thank you, Franziska. And,
thank you.
Oh, sorry, there's a slight lag here. Okay. And then we are moving on here on site to our final speaker of the day. And that is Umar Iqbal. and he is a postdoctoral scholar at the University of Washington as well. So I assume he's a colleague of Franziska. And yeah, he's also received many fellowships and various awards for his work. And his research has been recognized with actually Best Applied Research Award at Cybersecurity Awareness Worldwide 2020. So that sounds like quite an achievement there. And his work has also been actually covered by quite popular press outlets, including ABC, The Verge, The Register, and CNET. And I hope that we have Umar already with us. I can see you on screen, which is a really good sign. I can also see you blink, which means you're not frozen. These things, you know, during the pandemic, they happened, right? So looking forward on hearing more about breaking advertising and tracking request chains. Here you go, Omar.
Yeah, thank you so much for having me. As you mentioned, my name is Umar, and I'm a postdoc at the University of Washington. And in today's talk, I'm going to talk about some of our research on detecting advertising and tracking request chains. So in this talk, my objective is to convey 4 things to all of you. First of all, I want to show that advertisers and trackers abuse request chains to track people across the web, and they also use them to bypass privacy protections against cross-site tracking. Secondly, I want to demonstrate that existing countermeasures are not equipped to protect against privacy harms caused by request chains. And third, I want to explain our machine learning-based approach called Khaleesi, which is purpose-built to protect against advertising and tracking request chains. And at the end, I want to demonstrate that Khaleesi is deployable in a real-world setting because it is scalable, robust, performant, and does not cause any usability disruptions. So before I explain how advertisers and trackers abuse request chains, I want to very briefly explain what I mean by request chains. So in a typical HTTP request, the browser sends a request to fetch a resource from the server. The server evaluates the request and responds with the requested resource if it is available. And in case the server cannot fulfill the request on its own, but it knows that another server can, it redirects the browser to fetch that resource from the other server. The browser will then have to issue a subsequent request to get that response. So overall, this exchange of requests and responses between the browser and different servers form a chain of requests and responses. And this is what I refer to as request chains in this paper. So these request chains play a core role in online advertising because they allow trackers to share information across origins. It is not possible for trackers to do that inside the browser because they are restricted by a security mechanism called the same origin policy. So as a workaround against that policy, advertisers and trackers simply read whatever is accessible to them and embed that into redirects, which force the browser to send that data to whichever domain the redirected is going to send the request. This is a standard ad tech practice, and it is commonly known as cookie sync. More recently, we have seen that trackers are now relying on request chains to bypass third-party cookie restrictions. And the idea behind these restrictions is to only allow cookies from domains that have been visited by the user as full-fledged websites. And most people do not visit tracking websites and full-fledged websites, so trackers end up losing their cookies. But interestingly, trackers have found a way to rely on request chains to bypass this mitigation. They do this by tricking the browser into visiting the tracking website as full-fledged websites, and they do this by rewriting the links on the website. So when people visit the websites and click different links, they are navigated to multiple advertising and tracking websites before they land on the intended web page. And as a result of this bouncing, trackers are able to access their cookies when they are loaded as third parties. This technique is also useful because trackers can embed identifiers in the navigations, which can be read by the scripts on the navigated web page and stored in the first-party cookies. So now we have seen some of the ways in which advertisers and trackers abuse their questions. Let's see if existing solutions are effective at protecting against these threats. Most people on the internet rely on ad blockers to protect themselves against advertising and tracking. But unfortunately, ad blockers are not equipped to effectively block requests. The reason I say that is because ad blockers operate at the level of individual request and try to block known trackers with the help of manually curated filters. For example, if you look at this request chain, you can see that it is trying to share tracking identifiers with another domain, but ad blockers will not be able to detect that behavior. They will only look for the domains and URLs that are present in the crowdsourced filter list. And if one of them is present, they will be able to block the request. So despite that chain showing an obvious tracking behavior, the ad blockers will not use that information. People have tried to improve ad and tracker blockers by relying on heuristics to detect tracking instead of trackers. These heuristics rely on a narrow set of rules, which makes them very effective at detecting known and precisely defined tracking behavior. But anything that falls outside that narrow heuristic is not detected by these heuristics. To demonstrate that, I'll show you these two cookie syncing and bounce tracking requests. And you can see that the heuristic on the left is supposed to detect the cookie syncing request. And if we execute that heuristic on these two chains, it will be only able to detect, excuse me, the cookie syncing request, and it will be clueless against the bounce tracking request. These heuristics have also been generalized with the help of machine learning to detect a broad range of tracking behaviors. And there are plenty of machine learning approaches out there, but the state-of-the-art approaches organize website execution in form of graphs and use the execution traces of trackers to detect them. These approaches are very good at detecting generic tracking behaviors, but they are less effective at detecting specialized tracking behaviors, like the ones carried out through requests. The main limitation that they're somewhat ineffective is because they do not capitalize on the sequential nature of the requests. For example, if you look at this request chain to make a determination, they will use the necessary context available at each request, but will not capitalize about what the request chain has been doing so far. So overall, in conclusion, we can make a point that all of the prior approaches do not capitalize on the sequential context simply because they are not purpose-built to detect advertising and tracking request chains. So it causes them to have accuracy issues. To bridge that gap, we propose Khaleesi, which is a specially designed approach to detect advertising and tracking in requests. Our key idea is to capitalize on the sequential nature of the request chains because the purpose of the request chain becomes clearer and clearer as the chain grows larger. I will motivate that insight by walking you through a cookie syncing request. So as soon as we observe the first request, we are in a position to infer the intent of the chain. For example, with as simple information as this request going to a third party and reading some identifiers from cookies, it could be an indication of tracking. And if we let it go and receive its response, we can see that it was not just reading the cookie for itself, but it is also embedding that information in a redirect and sending it to another third party, which is an even stronger indication of tracking. And as we let the chain grow larger, we can see that it was a bilateral data exchange between an advertiser and a tracker. So overall, by analyzing the request chain in a sequential manner, we are able to capitalize on a much richer and necessary context that was absent in prior approaches. We use that sequential context to develop a machine learning-based approach called Khaleesi, which is purpose-built to detect advertising and tracking requests. Khaleesi first uses the web extension APIs to capture HTTP requests and responses and arranges them in form of chains. And after arranging them in form of chains, it extracts features from the request, response, and sequential properties, and labels them using add and drag blocking filter lists. After doing so, it feeds all that data to a machine learning model, which learns to detect advertising and tracking requests. So in Khaleesi, we capture requests that are initiated at both the network and the JavaScript layer. At the network layer, we simply link the subsequent request and response pairs that appear in HTTP redirects. And at the JavaScript layer, we arrange two kinds of request and response pairs in requests. First are the top-level navigational redirects, which are typically initiated with window.location API. And second are the requests that are initiated from the same script which contain common identifiers. And by incorporating both the network layer and JavaScript layer requests, we are able to capture a broad range of advertising and tracking behavior that is executed through these requests. So after organizing these requests into chains, Khaleesi extracts different kind of features from them. The first are the request features. And here our intent is to capture properties that can tell us what the request might do. For example, if we notice that the length of the URL is very long, it might be an indication that a lot of identifiers are embedded in a request. With response feature, which is our second category of feature, we try to capture properties that can tell us what the request response might do if we let it execute. And here, the length of the response, for example, if a tracking pixel is loaded and the response length is very small, we would know that it is likely going to be involved in tracking. With the sequence feature, our intent is to capture properties that can tell us what the request chain has been doing. So for example, if we see a lot of different domains appearing in request chains, we might be able to identify the cases where information is exfiltrated to many advertisers and trackers. So after extracting these features, we train a random forest machine learning ensemble to detect advertising and tracking requests. We use EasyList and Easy Privacy as our ground truth and train a model on request chains extracted from the top 10,000 most popular websites. And after training, we test the classifier with tenfold cross-validation and achieve an accuracy of more than 98%. And this is an improvement of almost 40 percentage points as compared to some of the prior research work. In terms of visual representation, these graphs show the communication between advertisers and trackers with and without privacy protections. You can see that on the graph on the right side of your screen, that filter lists do provide a substantial improvement in privacy, but Khaleesi even further improves that. And in terms of a head-to-head comparison, Khaleesi is able to block request chains with more than 1,250 new advertising and tracking domains that were not blocked by filter lists at the time of our experiment. And it included some of the domains of popular advertisers like Devlin, which now have been added to the filter list. So far, I have shown you that Khaleesi is effective at detecting request chain-based advertisers and trackers, but this evaluation has been in somewhat favorable conditions, and one could argue that these findings may not translate in a real-world setting. So we next evaluate Khaleesi on several simulated real-world browsing conditions to demonstrate that Khaleesi can be deployed in a real-world setting. First of all, we evaluate Khaleesi on different browsing configurations because users may use different browsers or they may configure their browsers differently. And in total, we test Khaleesi on 3 different browsing configurations. The first one is a crawl with user interaction, which is scrolling on the web page and clicking several links to the subpages and also some external web pages. We also extend that condition by blocking third-party cookies, because third-party cookies blocking is becoming very prevalent, and most browsers now provide controls to block third-party cookies, and some actually do it by default, like Safari and Firefox now as well. And the third one is a simulated Safari, because a lot of attacks involving request chains were initially targeted towards Safari. And the biggest example, perhaps, is bounce tracking. In all of these cases, Khaleesi performed extremely well, with an accuracy ranging from 92 to 95%. And the reason for this slight decline in accuracy is because in subpages, the benign URLs were a little longer, which were similar to what tracking URLs are. And in the cookie blocking configuration, we saw a lot less cookies associated with requests, which is typically an indication of a benign resource. But I want to make one point here that if we increase the training set of Khaleesi by involving data from varying browsing configurations, we'll be able to improve Khaleesi's accuracy by a lot. So next, we evaluate Khaleesi's robustness because ad blockers have to constantly defend against adversaries that try to circumvent blocking. And some of the common attacks include changing or rotating the domains that are used to serve tracking and advertising resources, or masquerading the tracking request as first parties, which is commonly known as CNAME blocking, and manipulating the query string by either hashing or changing the name of identifiers in the query string. These attacks would achieve an evasion rate of almost 100% for ad blockers, but for Khaleesi, they are able to achieve a success rate of few percentage points, except for CNAME blocking, where it exceeds to 13%. Another reason that leads to robustness issues in ad blocking is when filterless rules outdate. Machine learning-based ad blockers like Khaleesi do not suffer from this problem because they block requests based on advertising and tracking behavior, and not the domain or the URL of the advertiser or tracker. But in case the advertising behavior changes, the machine learning classifiers may also lose their performance. And an ultimate solution to this problem is to continuously train Khaleesi or other machine learning classifiers to keep up with the changes in advertising ecosystem. But we wanted to test, in case we don't update Khaleesi, how much of its accuracy will degrade. And we identified that even without training, after 1 year, Khaleesi's accuracy will only decline by 4.5%. Ad blockers also cause breakage because they block resources, and their breakage can be classified as either minor or major. Minor breakage refers to the scenarios where the user is able to perform the functionality for which they visited the website. For example, if icons are missing, the user will not be bothered that much because they will be able to use the website properly. And in case of major breakage, which refers to the scenarios where the user is unable to perform the functionality for which they visited the website. And it may involve cases where a user is trying to book a flight on a travel reservation website. We evaluate Khaleesi to see if it causes any of minor or major breakage. And we identified that it does, but that is on par with what AdBlock Plus also causes, which is around 3%. We also evaluated Khaleesi's breakage on authentication scenarios because that's one of the larger benign use cases of request chains. A lot of identity providers like Google and Facebook rely on request chains to sign into users on different websites. And in all such cases, Khaleesi did not cause any breakage. Lastly, we evaluated Khaleesi's performance in detecting requests because machine learning has some performance overhead because it extracts features and also classifies. But we noted that in case of Khaleesi, Khaleesi is able to offset most of the overheads by blocking more advertising and tracking resources. And in compared to a stock browser without any ad blocking, Khaleesi is able to improve the page load time on almost 91% of the websites. And Khaleesi was also faster than AdBlock Plus on the 60% of the websites that we tested. So before I finish, I want to mention that Khaleesi is peer-reviewed and accepted at a computer security conference. There's a lot of interesting analysis in the paper, which I did not get a chance to talk about. So I would encourage you to read the paper to know more about that. And a shout out to all of my co-authors who put in a lot of effort to execute Khaleesi. So in conclusion, I first demonstrated that advertisers and trackers rely on request chains to track people and bypass privacy protections. Then I showed that existing solutions are ineffective at detecting request chains. After that, I showed that Khaleesi bridges that void by leveraging sequential nature of request chains to effectively detect them. And at the end, I showed that Khaleesi is deployable in a real-world setting because it is scalable, robust, performant, and does not disrupt user experience. Lastly, I want to mention that we package Khaleesi as a browser extension, and you can visit the link in the QR code to try it out. And if you're interested in machine learning-based ad and tracker blocking, or if you have any other questions, please feel free to reach out to me. Thank you.
All right. Thank you, Umar. This was really, really interesting. The Khaleesi approach sounds really like next level to really break advertising and tracking request chains there. So I will definitely try out your QR code and install it and play with it and see how it works. And
yeah, thank you.
The lag again, sorry. All right, and yeah, you already know how we do it with the questions. Please use your phones and make use of this great opportunity to ask experts like this, because I had already a few questions coming up that I would have liked to ask him, and I'm sure the experts in the audience in the domain will even have more questions. So that said, I want to say a big thank you, because it's time to wrap up the day. We have finished all our sessions. And yeah, first and foremost, I want to thank all of the speakers who have put in so much creativity, preparing their presentations, also delivering them in really stunning ways. And I have learned a lot. And I hope that the same holds true for our remote audience as well as the on-site speakers. And yeah, please give a huge hand to all of the presenters for today. And that said, I also want to thank the audience for coming, joining us here on site, and also at home. Thank you for your interest, and I hope that you tune back in tomorrow morning when we start again. Thank you, and see you tomorrow. Remote speakers behind, but on site, as you know, we still have the networking event that will last for about 2 hours. So we have, again, some tasty drinks and snacks downstairs. And yeah, I hope that a lot of questions can still be asked. Have a nice evening, everyone.